gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and feel alright. Digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Hi, Kelly Dack for AltiumLive Connect 2022. Back with you this afternoon. We're very pleased with the presentations and how they've been going so far, and we thank you for joining in with us. We've been speaking with behind the scenes with lots of our presenters, and today we have Ted Puela, who's going to be joining us. He's the Chief Ecosystem Officer and Head for Nexar Altium. So that's going to be very exciting to learn and understand more about Nexar and what Altium's plans are for this program. Another thing we want to introduce is the Altimade solution to things. And look who's joined us right now. Ted, I just introduced you, so your timing is impeccable. It's perfect. Right. Thanks for joining us.
Well, thanks for taking time to talk with me.
Yeah, we've got a whole a whole viewer audience with us today, and we want to dive or do a flyover. Let's fly over and then dive over the Nexar products, Altium Nexar, and rather new. I thought it would be a really good opportunity for you to explain how this is working and what it is. How about the 5 W's? Who, what, when, where, why, and how?
Sure. I don't know that I have it in my head in exactly that sequence, but I'll just tell you what I would tell you. What I would tell you is that just exactly a year ago, it was January of 2021, when inside of Altium, we kind of said to ourselves that there's so much that's different about not moving, but kind of like adding cloud to our game. So, our tools have always been desktop, and they still are, all the design tools. But what we've done is cloud enabled them, and getting people to kind of like understand the benefits of the cloud, building for the cloud where you don't have kind of typical, like release cycles and launches in that way, but you're constantly doing that. It takes, kind of a different way of operating. That's our perspective. And so we split our business into 2 business units where we were just one big entity before. Now we've got 2 business units, one that we kind of call our board and systems, or that's our CAD team really. And then we have Nexar. And Nexar is all about our cloud platform. And, our customers know that platform as Altium 365. And of course, it gives them lots of benefits for collaboration and all that. But we also said that, look, there's many things that we're going to want to do and we're going to want to help our customers with that go beyond our capabilities to build it organically or in-house. And so we need partners, and we want to work with partners who are best in class. And that means we need a way for them to connect to our products, to connect with our customers, and kind of offer value to them.
Let me pause you for a second. You for a second, Ted, and get crystal clear the point of Nexar and Altium. How are these? You had mentioned that one is the other. It's like a parallel concept. Sorry.
Yeah. No, I mean, like I said, they're so Altium 365, the cloud platform our customers work with, and Nexar, they're just 2 faces of the same thing. It's sort of like having you're inside a room. I've got a window over there, and I've got a window over there. On one window, you see Altium 365, and you work with that through features and capabilities. The other window, though, is like APIs and things that we call embedded experiences that are like widgets, for example, that you could put pricing availability from Octopart or a design viewer that works natively with your CAD files and stuff on your website, that sort of thing. Okay. So Nexar is all about those things to bring partners in.
Okay, very good. So kind of in parallel, but the same thing. Yeah, when we talk about the cloud and cloud access, it takes
Yeah.
for connectivity, it takes accessibility. So that I would imagine that's the purpose of the whole thing here.
Well, it is. I mean, the problem that Altium set out to solve many years ago was kind of connecting design, supply chain, and manufacturing, right? We've talked about it forever, and we're now at the point where we're actually starting to do it, not just talk about it. And we felt that, hey, the cloud is the most natural sort of technology to underpin collaboration that exists. And
Yeah.
in fact, we think it's the only way it can really work.
Yeah, the data is such that it's becoming so rich that it gets quite large, and it's we don't want to be emailing things anymore, of course, or loading them
No,
up. It even takes
right.
time to load things onto servers and things. So the cloud that's the way now. That's what we use. So tell us more about it. Tell us more about the goals. I mean, we mentioned connecting manufacturing and the supply chain. Tell us how all that works.
Well, so I mean,
Maybe an
from a
example.
Yeah. Well, so the best example I could probably give you is this thing that we've launched here, this new application called Altimade, right? So Altimade's an application that's built on that 365 platform. And what it's really doing is taking all of the rich sort of supply chain data that we have, not only from Octopart, right? Octopart's been an Altium company for a while, but we have partnerships with IHS. We've got partnerships, even with companies like EMA for Ultra Librarian, with Snap EDA for more CAD parts to bring in and so forth. So the point is, there's a rich set now of data relative to components and chips that is available to our users in the design environment, right? So now they're literally connecting directly to the suppliers, to the distributors and manufacturers to know what's there and what does it cost and what's its life cycle status, all of that kind of stuff. And with Altimade, we're also now connecting directly to a manufacturer in the form of Macrofab, right? So that we don't have to zip up a package of design release files and Gerbers and things like that in a separate BOM. We simply have a direct pipeline between Macrofab and ourselves so they can get just the data they need in order to give you a quote, in order to be able to make your board and all of that kind of stuff. So it's really kind of on that framework. When you're designing, you're already connected to manufacturing and have the benefit of the insight of the guy that's on the manufacturing floor, and as well as all of the insights from the supply chain.
Yeah. Hey, let's talk about supply chain. Let's talk about availability because it's we very much address and are familiar with the lack of availability of certain components. They become unavailable, and it changes our world. It stops everything, and we have to even go to the point of redesign. So we talked about the supply chain very often in terms of components, electronic components, which fit onto the circuit board. But a lot of folks aren't thinking about the actual bare board as a component. And
Yeah.
when we talk to our fabrication suppliers, we in a sense have, well, in actuality, we have some supply chain problems now that we're experiencing with materials because everything is adjusting. And I'm wondering, it's been a thought in my head, are we addressing or can we address supply of laminates perhaps, so that if a certain stack up recipe it maybe already exists, we can get data on if the laminates are available to build that stack up. Is that existing or coming in out our product?
Yeah, it's a little bit of both. So, I mentioned, all the that we're trying to onboard partners to the platform so they can add value. And one of those partners, just as an example of what you're talking about, is Rogers Corporation, and Rogers is laminates, right? So, so Rogers data is already coming into our platform so that you can, kind of in that sort of like sphere of the laminates and so forth, you can look at that stuff. And it's
Sure.
definitely our intention that we will bring more laminate suppliers into that. And in fact, one of the things that we're not doing it today, but in the future, we will offer people through Altimade the ability to get not just the full assembly, but say, I just want to get the bare board. And we have a lot of customers, especially startup customers, who like to assemble their own boards when they're simple. So getting that laminate and not just dipping it in the old acid bath in their garage, but having a professional bare board to work with is important to them, and they don't always want to get everything pre-assembled.
Yeah, and believe it or not, that still happens. The garage etching wet process in the garage thing happens.
I can't claim that I'm doing it in my garage, but I have plenty of customers who I've gone to visit and had the opportunity where they show me around what they're doing, and even say, hey, come over and let me show you my lab, my workshop, and literally roll up the garage door, and you see that.
That can be real fun or real scary. We're both in the same experience. So and also the 3D route or the routers that have come about. We see a lot of makers routing laminates, but there's challenges with a 2-layer scenario or a single-layer scenario. But let's move on, because we really these makers, designers, you're making it so easy with Altimade to just connect to many suppliers who might be the best in-class supplier for the task at hand. If it's a prototype, if it's a simple prototype, the point is they're connected, and they can simply output the design or the data and get it to the supplier and get accurate quotes pretty instantly. Yes.
Yeah, accurate quotes, accurate lead times, so they kind of know what they're working with. And the other thing that we thought was important is that you want to have an experience that's less like, a taxi cab from year 2000, where you say, hey, I need a ride. And they say, I'm going to be there in a half hour. And then 35 minutes later, you're still sitting there saying, well, where is he? Is he coming? Is he, has he gotten lost? Did he pick up another ride? What happened? You don't know, right? It's a black box. And largely that can be the case after you order a board, right? So part of this connection that we want to make sure that is there is that you're getting feedback to know that, okay, he's ordered my bill of materials. He's got the bare board from whatever fabricator, we're working with on that. He's got it on his pick and place machine. He's got it in the reflow oven. It's being, tested, et cetera. So you see, it's much more of an Uber experience than it is a taxi experience, if that right, analogy makes sense.
Your metaphor includes up-to-date status of where the product is in each step of the process.
That's right. Yeah, I want to see that car driving to my house, right? And same thing, I want to know where's my board between my hand and that factory, what's going on.
Right. And then very soon we'll have them delivered by Amazon Air, and they'll just show up right at your doorstep.
Well, we have that DJI.
Oh, I didn't let any cats out of the bags, did I?
Yeah, somebody's going to win that drone, and they're going to provide a delivery service for all that.
Yeah. Well, very good. Anything else that you'd like to cover that we might have missed?
I guess not necessarily. I mean, I think not that we've missed anything here. I guess I just I'm really excited that we're now kind of like taking the covers off of a lot of things that we've been working on over several years now, and you start and getting it to the point where it's ready for customers to experience and to use. Altium 365, Altimade, Nexar for our partners, and you see even at AltiumLive, there's many more partners now. I think we've got about 3 times more partners and sponsors at this event than we did a couple of years ago. And Nexar plays a big role in that, because they don't just show up and have a booth, but they literally can connect their solutions to ours for the benefit of all of our design community. Because what we're really trying to do, connect things, but the end goal is, let's make it easier for them. Let's take away the things that are really just painful and a nuisance and kind of grunt work, and make it easy for them to do the things that they really enjoy doing, which is innovating, making new products and making cool things.
Yes. Well, as a designer myself, I just appreciate all the progress that's been made throughout the years with the Altium tools, and this is something to look forward. I'm very excited about it, and I'm sure our viewers are too. So. Why don't we let you get back to work? With me's been Ted Puella. How do you say your last name? Puella.
Oh, well, yeah.
I'm so.
And before you let me go,
Puella.
I've got one question for
Oh,
you
sure.
too, Kelly.
Okay,
So
okay.
I heard a little bird told me that this sort of hip hop song that we have in the theme here, that you had something to do with that. So is that actually your voice? Are you singing that?
I am. I did. I don't do it often, but when we were genning up ideas for this hosting promo gig, I had mentioned that I spent some time in Seattle with a board supplier, and Sir Mix-a-Lot, Anthony Ray, if I can name drop, was a customer of the circuit board supplier who would visit the office every once in a while, and I was fascinated to find out that he's a board designer too. He designs his own circuits. So I threw that out there and I said, I've rubbed shoulders with Sir Mix-a-Lot. Maybe we could do a rap. So that was the challenge. The gauntlet was laid down, and I started. It's pretty easy for me to take content, and I start rhyming at night in my head, and we put this down, and it seemed to work out. I think it was well received.
I think not only was it well received, but I feel like just by association, you've made me really cooler than I am. So thank you for that.
Well, and as I mentioned on our last segment, one of my goals of coming to the shows here, I wrote down goals, and one of them was to make friends and connect with new people, and I think we've done that here, and I really appreciate that. May I mark you down as make new friends. I've got Ted now on my list. I think you're number 20 now. I think my goal was to get 20 new friends and acquaintances.
All right. Well, I'm glad I helped to hit the milestone, but actually, since I'm number 20, I consider myself the milestone. So,
fist bump, right on.
all right.
Okay, hey, it's been a pleasure, and we're really looking forward to Nexar and Altimade spreading out and helping our viewers. So,
Absolutely. Let's get out there and design some cool stuff.
Okay, right on. Again, with me has been Ted Puella, Chief Ecosystem Officer and Head of Nexar Altium, and this has just been a pleasure. It's so fun to meet and connect with people at these shows, even though we're a little virtually, we're broadcasting live, and we're hoping that's helping your experience. So for now, until our next segment, I'm Kelly Dack for AltiumLive 2022, and we'll catch you soon. Oh, wait. I've been informed that we need to pump the next segment. Thanks for rolling with us. Yeah, at 1 o'clock, we've got 4 presentations coming up that deal with the topics of simulation, simulating high speed, and how you can streamline your design processes with Samtech and Altium, a well-known name in connective devices. Also, we'll name drop a little bit. We've got Robert Farnack coming up, a well-known user and instructor of design tools, and he's going to provide I'm sure it's going to be a very good presentation. He's just a warm and friendly, and it's easy to connect with Robert as he presents. And also we got Zach Peterson. I've heard that is going to be out there too. So make sure he's very dynamic, and make sure that you catch their presentations also. So again, for AltiumLive 2022, connect, Kelly Dack, and I'll see you next segment.
Hey man, you gotta come check this out.
I'll be right there.
Take a look at this.
Whoa. This is going to change everything.
Invite Alex. Hey, are you seeing this?
Whoa. This really did change everything.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and feel alright, digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Hi, Kelly Dack back at you on the IPC Apex show floor for AltiumLive Connect 2022, and we are in the midst of the IPC library. All things IPC standards can be found here, including, I ran into Chris Moyer, an IPC instructor. I don't. What is your exact title over there?
I'm an instructor with the Education Foundation side of IPC.
Okay, and currently teaching some of the IPC classes?
Yes, I created and teach all of the printed circuit board design classes for IPC. Everything from fundamentals of how to get started with board design through advanced subjects such as design for military and aerospace, embedded components, printed and wearables, flexible circuits, and so on.
So very comprehensive, and thank you for doing that, by the way. We need lots of educational materials out there, because as a design instructor myself for the CID program, we get emerging students and we get old timers that are still coming in and have never visited a board shop and are not familiar with the IPC 22, 21, or 22 specs. Why don't we talk about those and the importance of the specifications? I know you used to serve on some of the committees, and you're spread thin with busyness now, so
Yes.
It's understandable. But talk to us about those things.
So the standards were developed in order to ensure that any board you design is both manufacturable and will meet all quality and design requirements and be producible any board shop you go to. So it was a way to standardize the industry so that all board shops would build your boards the same way and you would have the same level of quality and reliability.
And how are we doing as far as keeping up with technology? It's always been a challenge. The technology is changing so much. I know there's new committees that have been formed to keep up with some of this. Talk to us about that.
All of the committees, whether new committees or for existing standards, we have a fairly regular update cycle. I want to say it's about every 3 years or so that we update all of our standards to stay current, to stay consistent with the latest technology, trends, capabilities, and so on.
Yeah. Well, let's take a look at a few go-to standards. I always recognize the orange book, IPC A600, and that is covering. It's called an acceptability standard. This one happens to be in French. I grabbed the French version, but that's okay because you know what? The book is loaded with images, images that will tell us what's acceptable and acceptable.
Target, acceptable, and defect.
And defect. In French, it's objectif. Oh no, this is the objective, right?
Right. That's the target. That's the target or objective is what the goal that you're trying to get to. Acceptable is here's the minimum level that isn't 100% to the target, but is acceptable, and then the defect, which this one has multiple acceptability levels. Then you'll have a defect level, non-conforme in French, that says, nope, if you're at this amount, it's rejected.
And we do have the English versions available over here. I just happened to pull the French one out by surprise, live. We're live.
No worries.
But, I mean, you do such a good job of illustrating, you know, picture's worth 1,000 words.
Exactly.
So this covers all things fabrication. Let's move over to the other side because I think I saw the yellow book over here.
Yep.
The yellow book is IPC A610, and look, we've got it in French. No, except these are all English. Very good. Yeah, again, very descriptive, and it looks very updated too. Updated 2020.
Yep.
How wonderful. So the classes that you teach, I'm sure, are use a lot of these examples in your instructions, and I know the CID classes use the same examples. Might need a little updating, but let's go with it. These books are invaluable for a designer to understand the target conditions.
Correct.
Right? So from a design standpoint, what designers need to know as far as design standards, we go over to another specification family.
Yes,
of
it's the 2220 series. Right, which includes the...
Take us over there. Let's see.
I believe it's around the back side.
Woo, come on.
Yep. So over here, so we have the 2221, the 2222, and so on. And the 2221 is the generic standard that all bare boards must be compliant to. Then we have the sectional standards, 2222.
Well, let's dive deep. Let's take a look at some of the go-to things in the 20.
Right, so some of the go-tos here, like section 6 on electrical. This is where we've got our charts that tell you what's the minimum spacing you need in order to not have arc over or break over events based off of the voltage on your traces and conductive features. We have the equations here shortly after that for controlled impedance, for your signal integrity lines, for your different controlled impedance structures here. We have sections further back in the standard here in section 9 that talk to how to design the size of the hole in the board and the land pattern size. So we have over here, we have the minimum land pattern size you need for a given hole, including all of fabrication allowances, minimum annual ring requirements, and so on. So we have...
And it's important to understand the classes, designer.
Well, there's both the classes and the producibility levels. So the classes describe the type of product being built, where class 1 is your consumer goods, where operation is desirable, but downtime can be tolerated. Class 2 is your like your industrial controls, elevator control systems, things of that nature, where extended operation time is desired, downtime is not a failure, but is not needs to be minimized,
Kind of
and
dedicated
service equipment.
yeah.
And your class 3 is your high reliability, your medical, your life support, your aerospace, your military weapon systems, where the product must work the first time, every time, and downtime absolutely cannot be tolerated.
Yeah, or somebody could get hurt, so it's really,
Right.
really important.
It's very important. Then on top of that, we also have the producibility levels. Within any of the classes, we have the producibility levels, which says after you've designed to the class, have this amount of allowance to ensure that your fabricator can fabricate the board with no special processing required. That's your level A. Your level B is okay. We can pretty much do it, might make a little tweaking, and your level C is pretty much your leading edge, where a lot of extra engineering hand-holding needs to happen.
So having gone to work myself for a EMS provider as a circuit board designer, I thought that more designers knew a lot of these constraints, and I gotta say, I was very surprised to find customer after customer bringing us boards that got automatically sent out, in this case to offshore, sometimes local, but how many, we call them EQs, engineering queries, would come back because they could not. I mean, we had one board with 3 mil lines and 2-ounce copper specified.
Yeah.
You know, designers will have to need to know how all these things work together.
Correct.
And these are great guides for
Right.
that.
Yeah, exactly. You need to know the standards, and IPC has developed a series of training classes specifically to teach all the standards and methodologies and techniques. Those are the ones we were talking about earlier, where I go over all of those interactions in my course, where it's not just the electrical clearance you need to understand, but the manufacturing clearances, the manufacturing limitations, processing limitations, and so on.
And I've seen the IPC advertising for the classes. They are mostly or all online.
They're 100%. They are 100% online, and
How does the scheduling work? Is it over a certain amount of time?
Yes.
It's not
All
concentrated
but-
3 days.
right. No, it's all but one of the classes are 6 weeks long. They all meet 2 times a week for 2 hours at a time. So 4 hours a week, either morning or afternoon, and either Monday, Wednesday, or Tuesday, Thursday. And during that time, I very much do it as like you would a university course, where there's a first day of the week, we have some lecture, present material, and then we do a hands-on work in a leading CAD tool to demonstrate those. So it's a very hands-on, very interactive course. They're not a canned webinar. It is live instruction, where you log in and you're able to ask questions and interact, and so on. And it is a very, very much a hands-on, interactive approach to teaching the material.
Yeah. Well, I can tell you're a great instructor just by being able to thumb through the guides and explain, boom, just like that,
Yep.
what we're covering. Plus, you're not a soft talker. You're not an instructor with a day job that is too tired to teach your class.
Exactly.
You're dedicated instructor.
Absolutely.
We appreciate that.
Thank you.
Appreciate it much. Tell us about, we just went through the design, for the first time in a long time, we've seen a designer competition here on the show floor. We saw that yesterday, and it started about noonish.
1:30.
1:30, and went through, and it finished at 6?
At 6 p.m., yes.
So tell us more about that. How did that go for our viewers that might have missed it?
Yes, so it was actually 2 heats. So we had last year at the end of the year in November, we had a first heat where we opened it up to everybody in the world, a longer duration where they had to do the entire design from, we presented a PDF schematic and bill of material. They had to create the libraries, the schematics, do the placement, routing, the whole 9 yards. Of that, we graded those. There was a group of judges. We graded against a rubric that we had developed, and we invited the top 3 competitors back. We provided them a starting point project in a given CAD tool. So the playing field was level, everybody's using the same CAD tool. And they were then responsible for the final placement and routing of the board to route it to completion. I think it went very well. There was a lot of excitement from people watching on the show floor. The competitors seemed to be having a lot of fun with it and said that it was very enjoyable. And was very eye-opening and like exciting for someone. One of the competitors yesterday was relatively new, been maybe routing boards for 6 months compared to some
The word on the street was that he hadn't used the software before.
Never used the software
and through
before.
ease of use, he was able to pick this up and enter a competition.
Run with it and go. And yeah, he basically said how enjoyable the competition was for him, and that he very much looked forward to doing more design work.
Very good.
And so on.
That is just a wonderful story.
Yeah.
It was good to see that happen. We'll read more about it in the trade publications. We're recording here too, so I think there'll be ways to look back and get the information. But you know, outfits like iConnect are also cover that intensely, and I'm sure you'll be reading articles from iConnect through that. We'll give them a little bump for being so connected with us and helping out. Anything else, Chris? Any message you'd like to get out?
Just that I look forward to seeing as many folks that are interested in learning board design. Please come to the IPC education website and sign up for the courses. I think they're a great way to learn both the standards as well as the practical hands-on technique and methodology, and see, like you said, how all these standards work together to ensure the highest reliability, highest quality, and most successful board designs.
Right on. Well said. Thank you for being with us. Chris Moyer from IPC. I'll shake your hand. I'm Kelly Dack for IPC Apex Expo show floor, but we're broadcasting for the AltiumLive 2022 Connect. It's late in the afternoon. You can tell I'm getting a little slow at speech, but I'm going to pump it up here. I need a cup of coffee or something. We're coming back to you probably quite a few more times today, so stay tuned and please enjoy what we have for you playing on the other website stages. So we'll see you for now.
We've got to get less wasteful, we've got to get better at what we're doing, we've got to be just generally more effective as an industry and kind of leading the way.
Everything that we've been talking about is based on improving the practice of engineering. But now we are bringing the business of engineering onto the platform.
When you talk to factory operators, they want to run their factory at about 90% utilization.
And what are they actually running that mission?
62.
The process through which I communicate manufacturing information and intent to a PCB manufacturer has not kept pace with the tools that I have for designing PCBs. Altium Designer, which is the primary tool I use for designing PCBs, the capabilities of that tool have grown immensely, and yet the process through which I ultimately develop a release package and get it to a manufacturer has been completely static through that entire time.
So what we end up with now is really a supply chain that's very brittle and reliant on offshore manufacturing and mostly offline, right? So it's a very difficult environment to be truly responsive and agile when you're trying to build new product and innovate.
By far, the biggest obstacle that I frequently encounter in getting boards done correctly and quickly comes down to communication.
When we send something to manufacturing today, what's the very first thing we do? We create a package of data, and that package of data is not in the original format in which we created it, and it gets translated into a standard, and there's always something that's lost in that translation.
I'm able to generate all this detailed design information, but then ultimately it still just gets distilled into this like 40-year-old format that I send over the fence into a black hole generally. There's a lot of lack of transparency in this process that has enormous room for improvement.
There's been a lot of talk in the industry about creating a digital thread, the link between the design and the manufacturing. With Altium, they've been focused for years on digitizing the design, creating more capabilities to capture more about the design. At Macrofab, we've been focused for years on digitizing the manufacturing side of the business. So what we're now doing today is connecting those two.
I've released this design up to the Altium 365 cloud. And this is a board that we use in our factory to do some simple motor control for some assembly steps. But now I'm going to go ahead and send it over to Altimade to get fabricated.
With Altimade, the designer is going to be able to sit there right in the Altium design tool, and as they're working, the Altimade tool will contact the Macrofab platform and update pricing in real time as they make changes to their design. That means the designer, through Altimade, will get real-time feedback on the true cost to produce their design and any issues with it that might impact manufacturing or supply chain.
We are okay with the price, so at this point it's basically just as easily as saying, here's my credit card, make these boards. I'm really excited about changes in the manufacturing pipeline that will allow me to capture the far more nuanced and detailed design documentation that I already make in Altium Designer and get it to my fabricators and be able to close the loop on that.
People just expect things to work for them with the minimal amount of investment from a learning curve perspective, this kind of stuff. I think people expect this from engineering software today. Why should it be any different? They want good user experiences. They want to be able to put in the minimal to get the maximum out. They want to spend their time being creative, doing the things that matter, not jumping hoops through a system.
By having that digital thread of connectivity all the way back to the designer, we've seen products go to market in as fast as 60 days that would have taken 6 months previously.
Sometimes I just have an idea, I want to see it realized in reality, I want to make it happen as quickly as possible. Altimade has been the most efficient way to make that happen quickly and to get prototypes in my hands.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip, we're in partnership with the folks from the IPC. Stakeholders unite and we'll feel alright, digging multi-show synergy. So let's all connect, come on people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine, check us out, virtual attendance, yeah.
Hi, Kelly Dack for AltiumLive Connect 2022. Hey, we're still out here on the show floor and there's still tons of stuff to see. Hey, we've just pulled over to check out Test Research USA with Steve Marks. Steve, glad you could talk to us. We've also got David Chu here. Thanks for letting me see your badge again, David. Well, we'll do elbow bumps, right?
Thanks for dropping by. We appreciate the opportunity.
Yeah. We saw some pretty interesting things. We see a lot about optical inspection here, X-ray inspection, so many types of inspection, which is so important in the board industry, because this is something I always preach and teach about, that we as layout designers, we should be following processes and take note of the manufacturing engineer, where manufacturing the companies, the processes, because everything is checked. A process is done and it's checked. A process is done and it's checked. You know, that should inspire us as designers to do the same thing with our design rule checking, and I hope it does. But let's talk with Steve and David about their machinery, or we'll just turn them loose and let them educate us on more on optical inspection. Sure. David, you want to start?
Yeah, sure.
Okay. Let me scoot around here real quick.
Okay, so do you want me to hold it?
No, I'll
okay, you hold it. Yeah, so from our perspective, Test Research Incorporated, TRI, we're in a unique position in the industry because we can offer our customers the test and inspection that they need throughout the entire process. So here we're looking at what we call our solder paste inspection machine. So what happens is when the customer wants to build a new product, a bare board goes into what's called a paste printer. And so we drop solder paste onto the deposit of solder paste onto a pad. And that pad ultimately gets components placed on it and run through a reflow oven where the solder flows. And then you have another inspection process, and we have that covered by the next machine that we'll talk about. And then it goes through the wave solder in a lot of cases, and then that takes us to the other machine on the end, which will be the 3D X-ray. So
I like that where this is going. I like where we start because it's very visual and graphic. We've got photography going on here, and by the time we get to the end, I love the outcome, and we'll wait and see how that works.
So really what we're doing here is we use what's called fringe pattern technology. It's a technology that's been around for many, many years, was developed back in the 70s, maybe even earlier than that, first adapted to medical products. We've now adapted it to our inspection processes, but what we're doing here is we're inspecting the entire board, and as the machine is running, we're able to capture the area of the paste deposit, we're able to capture the height of the paste deposit, and from those two measurements we can extrapolate volume. So in the manufacturing process, volume is king. If you have too little volume, you could have an open later in the process. If you have too much volume, you could have a short. So what we're trying to do is we're inspecting this at a very high rate, and that's one of the key features that we offer is speed. You know, we have customers that are manufacturing 1 million boards a month. And in order to keep up with that process, you have to have something that runs pretty quickly. The other thing is we focus on accuracy, repeatability, reliability, and also, just as important, ease of programming. Okay? So we are using the fringe pattern technology, which we have 4 what we call digital fringe pattern projectors, and those will broadcast a fringe pattern, so a known pattern, across the board as we scan it. And as we hit something that's not flat, in other words, higher than the surface of the board, those lines get deflected. And as we measure that deflection across that particular solder paste deposit. And from that deflection, that's how we get area and height.
I would imagine that's very accurate.
Well, with this machine, our XY placement accuracy of the optics is 0.5 micron. It is the best in
Say that again.
0.5 micron. It's the
Right
most
on.
accurate machine in the industry.
Amazing.
So the other piece of this puzzle is, as you can see, we are able to see the progress of the boards. So we're tracking the last 10 boards, and obviously we want to show failures at the show. In a production environment, we want to see these with green check marks. So one of the interesting things about SPI is we're actually able to communicate to the screen printer, which is where the paste is being placed. So if we see something that's not right, in other words, maybe there's not enough solder paste going down or there's too much solder paste going down, our machine will automatically tell the printer, go clean the squeegee or adjust the squeegee pressure, things of that nature.
And this plays into the theme of the show, our CFX, where we're taking data, and we're pulling data out of the process and moving it down the line and affecting other processes. This is wonderful. Tell us more about that.
Yeah, so that's part of the process. That's one piece. And that's why with TRI being in the unique position of having the entire manufacturing process covered with test and inspection, we kind of have a leg up because we've been doing smart factory for 25 years. So
very nice, very nice.
The other piece of this puzzle, and also as important, is our SPC tools.
And
so
let's explain for our viewers. We have a lot of emerging engineers who
Okay.
may not be familiar with the acronyms that we have out there. Statistical process control. Just
Correct.
A brief overview of that.
Yeah, so basically, if you have a piece of inspection equipment or a piece of test equipment, as you just said, what we're trying to do is gather data and improve the process. If you just say pass fail and you don't have any data behind it to do some investigation, all you're saying is this passed or it failed. What this gives us the ability to do is go back and track in real time how things are going, and gives us a chance to maybe make some adjustments at the printer. Maybe they realize that the solder paste that they chose for this product is not the appropriate composition, for example.
Sure.
So this gives us the ability to go back and look at archived data as well as track the process in real time. So for example, if we had micro BGAs on a board, and that's one of the most critical components, we can actually say, hey, if we see this failure 3 times in a row, stop the line. Make an engineer come over here and take some action. Let's get this thing working correctly. And so we're able to save this data for as long as our customers need, and they can always go back at a later date and they can query the system and see.
So very clear and very readable as far as accuracy. I see out to four digits.
Yeah, so David can drill down onto any one of these failures. You can stop the machine, David, if you'd like. And we archive not only what the measurement results were and what the failure was, but we also store images that can be exported into a database. And that's very important for customers, you know, mil-aero, medical, anything that's mission critical. They need to keep data for a long time. And
Sure.
just having something that says, oh, you know, we didn't have enough solder paste isn't as believable as if you can see the actual numbers and the picture.
Absolutely. Yeah, numbers, graphics, depending on where you come from, you know, there's people, designers really relate to graphics, but I can imagine that inspection people will appreciate this too.
The other part of this is that we can track what your top 10 defects are. So in this case, you know, we have under solder or under paste, so the height was too low, or maybe we have over paste, the height was too high. So as you're going through this process, sometimes if you're introducing a new product into the factory, they may go back and redesign the stencil to correctly put down the right amount of paste. So this machine is very important in helping you get the process started.
Started and dialed in, or that comes later?
Because as I said, if you have too much paste, you could get a short. If you have too little paste, you could get an open. Now, the other important factor for people that count the money is that if I can find a defect at this machine, it costs me 10 times less to repair it than if I catch it further down the process.
Absolutely, I've heard those numbers. Yeah, catching defects up front.
Right, and so it just goes from, you know, low cost, because if this board fails, I take it and I wash the board, and I go back and I put it in the printer and I test it again. Absolutely. As opposed to pulling, you know, a $200 BGA off a board, risking burning the board and scrapping that material. So this is a great place to really start your process off and make sure things start to get dialed in correctly.
First process, paste, check your paste.
Correct, correct. So once we go through this process, as I said, we then go to the pick and place machine. And we're not a pick and place company.
Of course.
But that would then take us to our
so
AOI platform.
And once the board is pick and placed, and we've seen some placement machinery, we've seen the reels, and we've seen how the boards get stuffed, so to speak.
Correct.
And but the solder joint has to be completed with reflow, correct?
Now, in some cases, we have a platform that we would put in front of the reflow oven where we would see what the pick and place machine did in terms of, did it place the right part? Was it in the right polarity? Is it even there? So that gives us an extra check prior to going through the reflow oven. Because as you can imagine, if I have to desolder something and put it on, again, I take the risk of damaging not only the board, but potentially putting on good parts.
Yeah, every time we apply heat again in rework, I believe that's called a thermal excursion. Exactly. That's a 25-cent word, but right. It's one to remember. Right. We don't want to be popping that board.
Right, and it can affect the reliability. And as you can imagine, if you're in an airplane, you want to make sure that everything's soldered correctly.
Absolutely.
After we do the reflow, then we come here, and now we're really focused on, again, presence, absence, polarity. Things happen in the factory. Maybe a component gets knocked off or something. So we are doing essentially what we did at the pre-reflow AOI, but now we're also focused on solder joint integrity.
Is this where different angles or more 3D will come in to play?
Yes, this is exactly where the 3D AOI would sit. And so, again, we use 3D methodologies to verify. In this case, you can see here, we're verifying that we have a flat surface, some solder, the pin, and then it goes up to the body of the component. And so that's part of what we do with 3D. We also check for coplanarity.
Why don't we get right in? May we move into this corner, and
sure.
That'll allow me to switch microphone arms. It's late in the day.
Okay,
my shoulder muscle is going to be bigger on this side, hopefully.
So, are we running or running the board? Yeah. So, the way that our system actually works, I would show you. You can see inside, but it's covered by a big black cover. But underneath that big black cover, is a top-down camera. We have what we call 4 side view cameras. So we're looking from the left side, the right side, front and back. And then we have these 4 fringe pattern projectors, which are the same thing that we have over here. So that's a 3D SPI. This is 3D AOI. So we use the same measurement type technology on this machine as we do here for 3D. And then we augment and increase our fault coverage by also implementing 2D methodologies on this machine as well.
Okay.
So it gives us a very robust test coverage, and it allows us to make sure that everything's soldered correctly, it's in the right polarity, it's in the right coplanarity, because sometimes what happens specifically with, let's say, a BGA, if you have a BGA on a board, sometimes you get little components that fall underneath it. And so when you go to reflow, the BGA is slightly off coplanarity, and you need to rework it. So that's one of the other added benefits of 3D as well.
The term coplanarity for some of our newer engineers or designers, that just means that there are 2 surfaces, 2 planes that are perfectly or are in parallel, and we need to measure how much out of parallel they may be.
Correct.
We're looking for that.
Because, you know, the whole manufacturing process is, we have rules that we follow based on IPC standards. So we are allowed to have a little tilt here and there, and that is acceptable. But if you get to a certain percentage where it's not, you know, in coplanarity, or it's too high or it's too low, those are the things you want to rework and look at.
Very good. Glad you mentioned the specs. We were over at the IPC library a little earlier and checked out. So the first book I opened was the IPC A610 acceptability spec. A bit funny story. I picked it up to show our viewers, and I happened to pick up the French version. So I know a little French, but we were going through the target conditions and things, and I was trying to make the translation. It was quite...
Certainly not in English. Understood. So from here, we would, with most processes, even today, we're still doing what we call the wave solder. So for through-hole components and so on. And once we've got the board completely built up, we can come in with this X-ray machine. So now what we're doing is we're actually...
To rehash, we've had several processes. The paste deposition, the solder paste deposition, we measured it, and then that went off to a placement machine, which is out of line, but that's what we do. And then we go through the reflow process, and then we inspect the solder joints from from different angles in 3D, and then from there, now we're going over to...
So we have one process after that, which would be wave solder.
For the through-hole components, in case there are any
through-hole components. And then to inspect those and everything else that we've already put on the board. This would be your final optical inspection, but in this case, it's X-ray. So with AOI, you can't see underneath a BGA. If you can't see it with your eyes from straight down or from an angle, you don't know what's happening underneath it. And the only way to do it is to shoot an X-ray through it and penetrate it and look at the joints.
Yeah, let's take a look at this, the X-ray.
We're looking at just 4 BGA balls or solder joints, and we're using computed CT imaging, and we're able to get a full 360 degree view of that, and we can cross-section it as well.
So question is this, are these images typically, is it a snapshot or is it dynamic where if the board moves around or tilts, or the camera tilts, we could actually see what's going on?
Everything we do is on a flat plane. Okay. We don't tilt the board or anything like that. This is completely automated. So from the paste deposit from the screen printer all the way through the entire process, these machines are in line. They communicate with conveyor systems through SMEMA, which is an industry standard protocol to say trigger the conveyor, let it go in the machine, so on and so forth. So we don't do anything with tilting the board. That's more of a failure analysis thing. We're really in the production environment. So the boards would come in and we would shoot the X-ray through, and we would capture images from multiple cameras or multiple detectors. Those cameras are set off at specific oblique angles, and then we digitally recombine those oblique angles, and we can separate the top side components from the bottom side.
I like where this is going, and it culminates into an image that looks like a board you're holding in hand.
Exactly. Is this true? Roberto, can I ask you to show on the screen the 2D image and then a 3D image? So basically, anytime you see a BGA on a circuit board, it's going to be, this is what you would see with a traditional 2D X-ray. 2D X-ray means I shoot from the top straight through the bottom, 0 degrees. And as you can see, there's capacitors underneath. This is going to be very difficult for me to inspect if I cannot separate the capacitor underneath from the BGA on top. This would be a short.
Right.
But because our system is able to capture those multiple oblique angles and then digitally recombine them, through the software we know the focal plane of the top side of the board and the focal plane of the bottom side of the board. When we inspect, we capture top side, bottom side, 2D images, 3D images, and the CT images in one single pass of the board.
Amazing.
So now you see Roberto has switched from the 2D imaging to the 3D imaging, and this is where we've taken multiple oblique angles, a minimum of 15, and we digitally recombined it, and the focal plane automatically went to the top side of the board. And that's how we're able to test top side and bottom side without having any interference from components on either side. This is a
very good.
A very unique methodology, and it's something that has been in the industry for a while, but as technology has improved, the results that we get on the X-ray process is vastly improved as well.
Absolutely fascinating. This is definitely, you know, we see different flavors of the equipment, and this is very enlightening here, what you've got going. Thank you for demonstrating for us. So how would we summarize this whole field trip that we're on? What can designers do? We have a design audience here that needs to understand how the inspection process works. Maybe you can pump for us the importance of the IPC specifications and the acceptance criteria,
Right.
610 or something like
Sure.
that.
The standards are all built around manufacturability, testability, and things of that nature. So if you're able to follow those design rules, it'll make a product that's not only functional, but one that you can manufacture. I'm sure that we've all come across something in our lives that was functional, but was not something that was really usable and was something that we probably couldn't reproduce millions of times a month.
That's the key.
That's what the design rules help us to do.
Well said. Well said. That summarizes it very nicely. Well, Mark, it's been a pleasure talking with you. I mean, Steve, Marks.
Hey, I get called Mark all the time.
Well, Mark, I'm so sorry. Steve, it's been great. I really appreciate your time.
Anytime.
Thank you so much. Your machinery shows well. Did the show floor go well today for you?
We've had some very good leads. Yeah,
Okay.
it's been great.
I'm excited. I work for an EMS provider, and I'm excited to bring this information back to them. And I hope you designers out there who may be involved, some of you have equipment and lines at your company. This is great information to share. They can get a hold of you at Test Research USA. What are we calling it? A TRI Innovation.
TRI.
You're online. We
are TRI.com.
You LinkedIn?
I'm on LinkedIn. Yes, I am.
All right. We'll look you up.
Well,
Thank
the
you
only
very
other
much.
thing that we offer as a company is in-circuit test and functional test. Unfortunately, those machines are on a boat in Long Beach, but that's the very last process, which is actually what we call electrical test.
Well, if they happen to arrive tomorrow, we'll stop by again, because that a picture out front caught my eye of, wow, we haven't done anything yet for electrical test and test probes.
Right.
So.
If not tomorrow, I'm sure we'll be here next year. So.
We'll look forward to that. Thank you very much.
I look forward to it myself.
Yeah.
Thank you so much.
All right, we're going to walk through here.
Okay.
We've got some announcements to make for our show.
Wonderful.
And very, very good to meet you. Thanks.
Nice meeting you.
Okay.
Thank you so much. Have a great day.
All righty. Yep. This is what it's all about. Making connections and learning. I learned quite a few things talking to Steve. I'm so sorry, I called him Mark. Steve Marks. Anyway, I want to remind you that tomorrow is going to be start our keynote at 8:30, and we've got who do we have on board here? We've got, oh yeah, that's important. We've got our VP of Sales and Marketing, Lawrence Romine, who's going to be giving a keynote and making some announcements, and we're really looking forward to that. It's going to be called our AltiumLive Connect event, as always. I'm winging it a little bit here. I'm sorry, it's this afternoon, but we're very glad you could join us today. This is probably going to be our last segment until tomorrow, so we want to remind you to tune in at 8:30 in the morning Pacific time for AltiumLive Connect 2022, and we hope to see you there.
As the complexity and demands of electronics continue to increase, the need to improve digital continuity throughout the entire electronics development process is more important than ever. This is the journey towards digital transformation, and while many companies are investing in technology to support this, they're encountering one major hurdle in the last mile of this journey: the inability to digitally connect ECAD to the rest of the enterprise. This means that the value chain still remains isolated and process disconnected. But with Altium Nexus, this all changes. Nexus provides a digitally integrated solution that overcomes this last mile in the journey towards digital transformation, making it not only possible, but easy. By digitally connecting your ECAD into PLM, MCAD, simulation tools, and other technologies, processes are automated, organization-wide visibility is enhanced, and resources are optimized, leading to accelerated design time, lower costs, improved quality, and most of all, a competitive advantage. Explore Altium Nexus now.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip, we're in partnership with the folks from the IPC. Stakeholders unite, we'll feel alright, digging multi-show synergy. So let's all connect, come on people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine, check us out, virtual attendance, yeah.
Hey, Kelly Dack here on the show. Sorry, I guess I need a mic. It's early this morning. It's pre-show, not dark 30 or anything here at the Altium Connect Live Connect 2022. We're on the IPC Apex show floor. Things are really quiet now, so I thought I'd get out the guitar as we often do and just strum a little bit and make a little noise in this dead air before the show. We've had great time interviewing and walking the show floor, meeting people and connecting with people, and it's just been a delight. The show floor, or the show, both shows have had quite a bit of challenges, needless to say, and I think all the teams that are working, all the crews, all the vendors and the setup crews have come together and put this thing together to really feel like a normal trade show, and we're really grateful for that. Coming up, we have AltiumLive starting on stage, and we just want to push that message out to you early this morning. It's going to start at 8:30 this morning Pacific Standard Time, so we want you to know that. And let me just reminisce a little bit about some of the things that we've gone through or been able to see here on the show floor. The theme this year for AltiumLive is Connect, and we wanted to bring you to the show floor. We wanted to introduce you to the machinery, the people, and the processes that really make the printed circuit industry run. We're mostly a design community here, but we're very passionate about connecting with manufacturing. So we thought, what a great idea to get you on the show floor, bring you along with us if you can't be here yourself, and introduce you to some of the stakeholders, the real stakeholders, and the machinery that make the processes happen. So we've gone from some of the solder suppliers and the metals suppliers. We've seen how a wave solder machine works, and what are some of the important aspects of wave soldering and what designers can do to perhaps make that better. We've gone through some materials. We've looked at some stack ups and some laminates. We were over at Co-Young here. We've learned that a lot of the vendors, a lot of the suppliers have their own manufacturing constraints and specifications in their own publications that they send out, so that designers can use this information to plug into their constraints, their design constraints on the boards, and actually design a manufacturable product. So important. I was going to say transgressed. We did not transgress the aisles, but we walked along the aisles. I'll pick a new word. We walked along the aisles and ran into some pick and place machinery. We call it placement machinery. We've seen the reels and the incredible speed of the pick and place nozzles that use vacuum to pick up parts, large parts, small parts, all the way down to parts about the size of dust. These machines can place now. It's just absolutely amazing. And because we missed this show last year, it's so great to be back, and it seems like the technology's taken a jump. It's amazing. So we've got a lot of video that we broadcast, and that video is also, we want you to know, is archived on YouTube, so you'll be able to link in and catch up if you missed a day. And let's see, what else did we do? We met up with the IPC, the Standards Committee. We talked to some people who are heavily involved in creating standards for the industry, so that everybody knows where the expectations of design and manufacturing capabilities. The idea is to get design, the upfront design people to understand the capabilities and know the constraints of and specifications of the entire industry. So IPC's done an outstanding job of documenting this in their IPC specifications, and we learned that they're updated. We talked about IPC A600, that would be the orange book, and we thumbed through that and showed, we were showing target conditions and what pictorially, what designers will see after their boards are assembled, or after their boards are fabricated. And then we went on and looked at the yellow book. I call it the yellow book, the IPC A610 acceptability spec, and that shows just about every assembly application or assembly scenario, again with pictures of acceptability, pictures of not acceptable or failure, and also talked about the classes of boards. There's class 1 and class 2 and class 3 acceptability levels. So if you happen to miss that, you can catch up with that. That's so important for the designer to know these things. Yeah, we've still got a lot to look at. We're gonna be doing that today. There's still a lot out there, and there's still a pretty good show buzz out here on the last day of the expo. But it's not the last day of AltiumLive. So we'll be on throughout the day, and we want you to tune in to the event that starts this morning, again, Pacific Standard Time at 8:30, and we'll hope you'll join us, and we're really looking forward to it. So until then, I'm going to sign off here a little bit, and we will see you shortly.
And to any customers out there that are not using this, I couldn't imagine not using these features. It would be very difficult to go back. Let's put it that way. So. I'm Jeremy Waller. I'm the senior electrical engineer at Quantel Laser in Bozeman, Montana, and that's part of a global company called Lumibird, and we have many design centers around the world. There's 18 mechanical engineers, about 22 electrical engineers in Lumibird that are part of the Altium 365 environment. It's pretty easy with Altium 365 to expand our environment. We research, develop, and manufacture solid-state laser systems for medical and scientific defense-related industries. Yeah, I mean, our mantra, I guess, would be we're rugged, reliable laser systems.
I'm Lane McNeil, the Senior Mechanical Engineer at Quantel USA. This is one of our newest, and it's a fairly high-power, high-rep rate laser system. So it operates with diode-powered input, but it's water-cooled. But the circuit board components of it, when we got going, we have some covers here that we put together, and they're kind of interesting. We have a number of circuit boards that sit inside the system. There are some fairly high-power diode drivers that we use, coupled with some control electronics, and then we have some other electronics that are used for regulation of nonlinear crystals that we use to convert the laser output to different colors. Before we were using CoDesigner, basically we would get a DXF file is what we would receive. We would then take the components and we'd have to go ask them, okay, how tall are these? How tall are these components? And then we'd have to extrude the materials up to get an idea, because we have some very tight fit applications that are going on. So
a collaboration tool like CoDesigner just really allows us to transfer back and forth easily. Not only does it help us design the space, but it makes for better assembly drawings so that people can build and manufacture this, so I mean it changes a lot of the picture here.
It's an amazing step forward now to be able to have all the exact physical geometry completely understood and known. Being able to see that allows us to prevent problems that we were having in the past. We have an example here of one of our lasers that was a collaborative process using Altium CoDesigner and SolidWorks.
Having the collaboration tool like CoDesigner in there helped us with this board in this particular design. How did we get to this board, I guess, is a good example to go through. This is how it started a project usually. I mean, you just have a rat's nest of components and in this case, we'll just pull a few of the important ones that we need to find location on right away. Because I need to get Lane involved and give me a board shape that fits in the space, show me where the mounting holes are, and we just got to establish an area where we can do components. So I'm just going to push it over to him for the first time so that Lane can receive it on his end, and he's going to do all the work for me, thankfully. It takes all the risk out of the process.
Did you get that pushed, Jeremy?
Yeah, it's got it pushed over to your direction, so I've got it in there. You can switch over to your screen.
Okay, so I'm pulling it in here. Right, this. So basically one of the first things that comes in with these is gives us the opportunity to come in here and define the physical size and shape of the component. So that is the physical size of the circuit board that we wanted to work with. And then basically what we're able to do, I can position the component So with that kind of placement, then I'm able to come in and add cutouts to the circuit board. But one of the things that we often do is we will go in and add a feature on the board that's going to define all the keep outs. So I'm just going to define a new part at the moment that I will define as the keep out zone.
These are the features that are difficult. They're pretty obscure, random shapes and everything. The thing is, this usually is a lot of back and forth, but since this is a board that we've already went through this process, what you're getting to see is like, weeks worth of back and forth and arguing over shapes and space.
But it's going to have a lot of this information is going to show up in one shot and be pretty well done so that Jeremy would be ready to work with it as soon as we're complete with this. Okay, so I just pushed it at this point. So what you're going to see is Jeremy will now have the opportunity to pull the system into Altium when the push is done. It's still in the process of collecting. There, it's done.
It's already there. All right, so it is fast. I mean, this is great. I would comment too, even when designs are pushed and updated overseas, our server's not even in this part of the country, so it's been really good performing product. But I want to view the changes, see what Lane did on occasion too. So it's going to give me a list of the preview of what he did. So if I like everything that I see, I can just hit apply and it's going to pull everything in there. Okay, so here you go. Here's all the changes he made. It's got everything I need to get started for the most part.
It would be impossible for a single individual focused on designing electrical circuits to be able to also at the same time envision all the detailed mechanics, because they don't have access to that information. And so this allows the mechanical engineer to effectively assist the electrical engineer in basically properly positioning things to achieve the most compact or the most reliable connection without a bunch of iterative problem solving and back and forth mistakes and fixing. I understand his challenges, he understands mine, and we work together to come up with a solution that works for both of us. And that's the thing that didn't happen in the past nearly as easily.
We're more competitive in the market now because we're able to get smaller. So now we're taking advantage of better PCB design technologies like micro vias and buried vias, and getting our circuit boards smaller and smaller. And at the same time, the space that we're working with in Lane's world is getting tighter and tighter. So it is definitely added to the quality and performance of our laser systems. And so it's worth every bit of time invested in learning the tools to allow you to provide those better products for your customers.
Well, gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and feel alright. Digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catch it how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Oh, thanks. Hi, Kelly Dack here, live from the Apex, IPC Apex show floor. We're glad to be back with you. We had a little technical glitch, as you know, live streaming does. It's amazing what the technology is allowing us to do. And I'm here with our cameraman, Michael, on the show floor. And we want to make sure and let you know that on the other stage, our keynote stage, we've got Dr. Eric Bogatin, talking about how to keep your board from screaming like a banshee. I just love the title of that presentation. So make sure and check him out. And in the meantime, we're going to walk the show floor, and we've met up with quite an interesting process, quite an interesting materials. And I'd like to introduce you to Ken Martinez. I'll fist bump you, Ken.
How are you?
Very, very good to.
You mind if I take my mask off?
You may. I will keep mine on, and especially mine happens to be a Stentech mask.
I'm loving that. I am absolutely loving that.
I'll be the poster child for Stentech.
And it fits well, doesn't it?
Yes, it does. It's very comfortable.
Well.
May I keep it? Yes.
Yeah, absolutely. It's yours.
Okay. We're having a blast here, and I'm very happy to find this technology, stencil manufacturing technology, and again, as has happened along the show floor so much, as we walk after missing a year, the technology just seems to be jumping out at us as far as how small things are getting, how fine-pitched things are getting.
Absolutely.
Ken's going to tell us about Stentech and some of the capabilities for manufacturing stencils and what designers need to know about solder paste deposition. So Ken, take it away.
So listen, the first thing I would say is that at Stentech we offer the broadest array of stencil technological solutions. So from laser cut stencils to coated stencils, we happen to have the very best coated stencil on the market. Our advanced nano brand outperforms every other coating on the market. It will actually improve the transfer efficiency of your print deposits as much as 20% over the competitive products. So it's important that you have the full range of solutions. When you work with our CAD engineering and customer support team, you're going to find that they're going to evaluate your Gerber drawing, whatever kind of drawing that you prefer to work with. They're going to quickly evaluate what's required. They're going to assess that particular design. They're going to get to an area ratio, and they're going to recommend a solution that absolutely fits with what you're trying to do. And it matters. The most important thing is the communication you provide to our company, to our CAD engineer. If you're using a prototype, then we're going to provide a solution that's going to work in terms as a prototype. If you're wanting a high volume solution, that's critical to know, and we're going to get you a different solution. So the key is the partnership we have with our customers is absolutely critical, the communication, and as you can imagine, as you're going through engineering design cycles, we want to be part of the continuous improvement process. So we as a customer, we're different as you work with us, because our CAD engineering folks will work with you and focus in the areas that you need to improve. There's nothing more important if you're a process engineer or a manufacturing engineer than to improve throughput, efficiency, yield, and that's what we want to be able to partner with our customers on to help improve their overall performance. We deeply respect the customers we work with, mostly process engineers, manufacturing engineers. The number one issue that they deal with is improving yield and throughput. And the very front end of that process is the stencil, and it's important that it's designed effectively for what that engineer needs to accomplish. So that's the difference in terms of working with Stentech. Our number one focus is the partnership with you to optimize your results. If you do well, we do well. And that's really the key to it.
Yeah, Ken, thanks. Well said. Well said. And our mostly designer audience out there, let's talk about what a designer needs to know, because, surprisingly, designers, I feel like we get into halfway designing the paste mask areas. It's very common for us designers to create a 1-to-1 ratio between all of our SMT lands and send that to our stencil manufacturer. But then sometimes we do modify them. We may shrink them. We may hold up our thumbs and go, well, I think we should shrink this about. But what we're doing here is talking to a bona fide stakeholder, a stakeholder in the process, and this is what we're trying to introduce our viewers to, is our stakeholders. So tell us about, designers don't have to know everything about solder deposition. That becomes maybe more of another stakeholder, the EMS supplier, the manufacturer of the assemblies. It's an assembly operation, and depending on the parts and the leads or contacts of the part, the job is, we're in the business of creating solder joints. Absolutely. Stentech is here to help the EMS manufacturer mold these designs, the Gerber files, through your CAM departments, the CAM departments out there, to deposit the appropriate amount of solder. So let's talk about that. Let's look at some of the stencils. Let's go on a field trip.
Yeah, let's go. So let's start.
I'm going to start over here.
Yep, so let's start. I want to just talk to you about some of the technology improvements. First and foremost, the laser technology we use to produce laser cut stencils has improved dramatically. But most recently, the most significant development in the industry is our coating. This is what we call the nano slick coating. This is not just a wipe-on kind of coating that you often see out there. We have a proprietary process that actually applies the coating to the stencil and actually gets into those laser cut apertures, smooths those apertures, and improves the release. So, and as I mentioned, it can be as much as a 20% improvement in release. And as you're aware, it's at the front end of the process, so that design needs to be perfected. Our team will actually advise on that, right?
We have looked, we have been across the show floor and we've seen some of the automated optical inspection equipment. That's an inspection point. After the paste is applied, it's all about the release. And let me tell you, I am very familiar with the benefits of the release. I always check the box to put on your nano coatings because I know it's going to help. Some folks think they'll go on the cheap, and they have their AOI picks up. Hey, this is a weird structure. How can we fix it? Nano coatings. So the release, and you'll if you look at some of the optical inspection views, you'll see a nice block of neatly stacked solder balls, and it's due to some of these coatings. So thanks for mentioning that.
Yeah, the geometry of the fillets after you release that stencil is absolutely critical. And you're right. We have the technology to see that, right? And what I would encourage people to do is stretch a little bit, spend the $100, $150 to get the coating. It gives you the engineering margin to ensure that you're going to get better produced bricks or fillets. That geometry will be better. It's a combination of a lot of variables. You got to have the right solder. You have to have the right print parameters. But if it all comes together and we're all working together, you're definitely going to get a better, more reliable product, a more consistent production process, but most importantly, you're going to get the proper yield and throughput. At the end of the day, that's what the executive team at your company cares about. Are you lowering costs, improving margin, and meeting customer requirements by hitting schedules? So
let me ask a question. We're starting to talk about release. We're talking about the walls of the laser etched or chem etched materials.
Yes.
We're talking about nano coating, and at the point of geometry, you know, some of our boards are very normal, 1206 chip capacitors, 0603s, but then, you know, we're getting down to 0805s. As we go down the scale, we're getting into some quite small packages, and I am looking here, and I was very impressed with some of the micro detail now that we can get with into some of the metals. Tell us about that.
So this is an example of the capabilities of our electroform technologies. You can see the fine features that are created, some of the solutions we can offer using electroform. This is the area that we're gonna make a significant investment in our company to take the electroform technology to the next level. It does some things well now. It needs to do some things a little better. But I can tell you, customers around the world love the performance of this technology. But, you know, we can cover the full range. So oftentimes with the simpler components, PhD stainless steel stencil, perfect.
Let me pause you there. We've got a lot of emerging engineers, and I will always pause our interviewees when we shout out acronyms, because we are very familiar. We've been in the business for quite a while, and we use a lot of acronyms. Explain PD.
PhD. Well, that's typically the what we call the standard foil that's used across the industry. It's a very unique foil with a very tight grain size. When the grain size of the foil is small, you have a smoother aperture when you laser cut it. So that's the first starting point. There's different kinds of foil quality, and then there's the tension on the foil itself. So
typically we're talking stainless steel, mostly.
Stainless steel product, absolutely. So you want to get the highest quality stainless steel that you can as a starting point, and then how that foil is stretched matters as well.
All right, so we if our viewers haven't seen a stencil and a frame, I don't know if we have a picture of that, but we did see. Oh, here we go. Some of the frames, and these are I've seen large frames with tubular 2-inch metal. Okay. Oh my goodness, here's exactly what I'm familiar with, except this happens to be like 5 feet long.
This is for you know, an LED solution.
This, come on over. Come on over.
This would be for an LED
Step in
solution.
here and this is a
So,
yeah.
so one, you can typically, your standard frame is 29 by 29. Tubular, we offer any range of frames that you would require for your printing solution. Typically, the most cost-effective is a standard 29 by 29 aluminum frame. We can either put your stencil in a frame. We can do it frameless. We call those either frameless or dropout. You can also, we can reduce your cost by allowing you to take our printed stencil and put it into a frame that will replicate that. We can ship it in a packet. It's off to you. You put it into the reusable frame. We have several solutions around that, so that's another area to take a look at. They come in the 2-inch. Some are thinner. We have what we call a space saver frame. Everybody has lots of these stencils around and they need to store them. They need to be able to find them, put them into use. The thinner space saver frame is a real advantage. So
I worked at companies with racks
You've
and
seen it,
racks
haven't
of, yes, and what's really interesting and what's striking me here right now is the length of the stencil, which means there is a very long, large board, probably an FR4 related board out there, and we know that with materials like FR4 or any materials, they are subject to stretch. And I'd like you to talk about because I've asked your company and asked your cam operators about stretch compensation, because we send you one-to-one artwork as a designer. We send out a SMT paste mask layer artwork. That's the raw data that comes into a cam department.
Absolutely.
The cam operators will take that and take the material, or actually the fabrication vendors can measure how much the material stretches, and they can either output a stretch compensated file to send to STENTEC. Do you can you do the stretch compensation on site too?
We certainly can too, yeah. We typically call that feature of the stencil the run out. But basically that it's measuring that stretch, right? So we try to accommodate for that. It's something we work very closely with our customers on. So that is a critical element to the process. And as you use that stencil over time, it's going to change a little bit. So it's critical that as you're using the product that you're accommodating some of that use and some of that minor change with your printing process.
Right. Excellent,
right.
excellent.
So there's a partnership.
Yeah, I'm glad we got to bring that up because it's a capability. It's a supplier capability.
Absolutely.
And it needs to be considered because there are many times that a designer will take on try and take on all the roles of the stakeholder and say, make it per this artwork.
There you go.
And that can cause problems down the road for your EMS provider, wherever it's being built. You need to allow them perhaps to have that nominal Gerber data output and send it to their supplier, who can stretch compensate for the process.
So one more thing we can add there, I mean, that partnership, they need to think of us as an additional resource on their team in the design as they deliver this to production. And so we're when we take a look at their file, we're capturing in their profile for that unique customer all their specific edits. And again, it's about making it easy for that engineer, that process engineer, that manufacturing engineer by having the profile. We keep that. We need to keep their life easy, so we capture it, we apply it. They're going to let us know if there's a requirement that's different from that. But the other thing is when we give them the check plot file that they would approve in our partnership, they also get a paste deposition file that gives them a feel for how that stencil is going to perform. Not everybody does that. At STENTEC, we do.
Right on. Again, we can. Correct me if I'm wrong, but we may emphasize that as a designer, we can spend a lot of time creating stencil detail or paste mask deposition detail. If you can zoom up, Michael, here, and we see what is called window painting for a large surface mount pad so that we don't get too much solder. But companies who do the solder or do this paste mask stencil, as Ken said, as Ken said, we they will do that for us. They do the
Absolutely.
compensations.
Absolutely.
So it's a service.
That's
you are
right.
the guys. You are the stakeholders.
Absolutely.
You're best qualified to do it.
Yeah, we're a partner in it. We have their back. We need them to have our back. We're moving quickly. Listen, at Stentech and like most of our competitors, the earlier we get a design in the morning, the better the planning between us and the supplier, the more quickly we can get it out. We will take a requirement. It could be as late as 2 in the afternoon. And our team is committed to taking that design, turning it around, getting it in production, and getting it shipped out that next day.
What time frame are you in? Are you still central?
Well, we're across the U.S. We've got 4 operations in Canada. We've got 9 in the U.S. We've got 5 down in Mexico. So we have extremely good coverage of the U.S. And one of the strategic advantages you're always going to have when you have a stencil supplier is being close, right? Freight is expensive. It's crazier than ever. So being close, if you can establish a relationship with a supplier who's close, you may be able to just stop by that supplier to get that stencil. And we understand the pressure they're under with their customer to get those things turned around. So proximity is important. We have a lot of locations. We're not a giant company, but we understand that part of delivery. We keep it simple: quality, delivery, and service.
Right on. It
really is that simple.
Anything to wrap this up? Anything to summarize? Anything we left off, maybe?
Just to mention the other thing that we do, and I'll just show you real quickly. At our company, we also can provide tooling and fixturing to go along with our stencil designs that will add to the reliability, the consistency of your production process. When you work with our guys, once again, they'll work with you literally on the phone, take a look, and we're only limited by whatever they're able to communicate. They will take your requirements literally on the phone via a Zoom meeting or whatever, put a 3D design up in front of you so that we can ensure that first article, the very first unit, is visually going to meet your expectations. It oftentimes creates questions and collaboration that might have been missed with just the file.
Checking and handshaking is a really good thing in our industry, and we make the point often to the design community. They have design checks set up in the software, but you can't check enough, and we need to follow the manufacturing industry, which does a great example or shows a great example of checking the process every step of the way, because you don't want to create scrap.
And the standard rule is that most people are more effective visually than they are with all the other tools. When they can visually see something, immediately it kicks into their brain, they can see, and that just increases the collaboration. So being able to work right there, them communicating to us, them seeing and adjusting the design as we go, asking questions, you can't imagine how many problems that eliminates on that first article delivery.
Right on. Well, thank you. Oh, go ahead.
I'm just going to say, and we're going to get that done in maybe as much as 2 to 3 to 4 days upon completing and seeing that visual review. So it's quick turn as well. Everything we do is we try to do quick turn because we know the time pressures people are under. So
amazing. Well, thank you very much for spending time with us. This is
Absolutely.
very exciting.
Good to meet you, Kelly.
We walked the show floor, and we I don't know, there's so much to see. We happened to hear, and I go, ooh, I know Stentech, and let's talk to Ken.
Yeah, thank you.
Thank
I'm glad
you
you
very
stopped
much
by.
for the opportunity.
It's very good to meet
I'll
you.
fist bump you.
Yeah.
And with me has been Ken Martinez for Stentech Corporation. Check them out. Website.
Please do.
Get some of their guidelines and learn more about the stencil manufacturing process and the stakeholders that are so critical to making it all happen.
Yeah, we want to partner with you.
We're live on the show here. We're gonna walk. I'm being told we're going to walk.
All right.
Thanks, Ken.
Good to see you.
Great.
Thank you.
Okay. Yeah. So, how exciting! I am always amazed, like I mentioned, about how the scale of things is shrinking to the point of to be able to accommodate our new technologies. So for now, I think we're going to take a little break, but we want to remind you that over on the one of the main stages, we've got the keynotes, our keynote speaker, Dr. Eric Bogatin, speaking about signal integrity, and the title of his presentation just catches my ear. It's called How to Keep Your Board from Screaming Like. So please tune in, make sure and tune in and take a look at him and his presentation. Thank you very much. Kelly Dack live on the show floor. We'll be back at you very soon.
Altium 365 lets you hold the fastest design reviews ever. Share your designs from anywhere and with anyone with a single click. It's easy. Leave a comment tagging your teammate and they'll instantly receive an email with a link to the design. Anyone you invite can open the design using a web browser. Using the browser interface, you're able to comment, mark up, cross-probe, inspect, and more. Comments are attached directly to the project, making them viewable within Altium Designer, as well as through the browser interface. Give it a try and get started with Altium 365 today.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip, we're in partnership with the folks from the IPC. Stakeholders unite and we'll feel alright, digging multi-show synergy. So let's all connect, come on people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine, check us out, virtual attendance, yeah.
Well, hello. Thank you for joining us again. Kelly Dack for Altium Live Connect 2022. And wow, what a day we've had on the show floor. I'm still amazed, still reeling from how fast they tear that show floor down and roll up the carpets and go. So I've been here with our cameraman, Michael, and he was kind enough to drive us over to Altium headquarters here in La Jolla, California. And we're here on a nice sunny day, just a beautiful view of the skyline here, the San Diego skyline. It's the other side of where we started, out on the bay, and the skyline down in the beautiful San Diego Bay. So just a wonderful experience, kind of old home week for me here. I used to live right down the street and made many good connections here down in the San Diego area. Wonderful businesses and companies here. Business seems to be booming, so we're very good about that, glad about that. I'm hoping that you've had a wonderful Altium Live experience so far throughout the day. I need to remind you that at what time is it now? Is it 4:15? We've had 4 more presentations start, so the day's not over. These should be very exciting, so please don't hesitate to go on into the other stages and pick a presentation and go with it. So very good. We have some things in store, some housekeeping here. I guess not housekeeping, but we like wrapping up the day. We like talking about all the wonderful things that we've gone through, all the things we've gone through together. And again, it's been a pleasure. How about the show floor? How about so many of the things we were able to, the equipment we were able to see. I can't stop talking enough about how the inspection equipment that's on the show floor has changed and, to the point where it's able to recognize the micro features on these new circuits, the smaller, densely packed circuits. It's wonderful. We've got coming in pretty soon, we're expecting a call from Altium Tech Marketing Engineer Vince Mazer. So we're hanging out a little bit, waiting for Vince to come on the line, and we want to talk to him and review his talk today. So in the meantime, I'll talk to you some more. And I'm happy to, because this has been it seems like it's been such a supercharged last few days with our Altium content. There's Vince right now. Hi, Vince. Let me just finish up here. Our Altium content and so much that's going on, and it's just a miracle effort that was put together here for the technology to come together so that we could bring you live on the show floor also, and we've really tried to combine the two events to the point where you feel like you're here. So hopefully you do. And I got to say, guaranteed live. We're live right now, and we have the pleasure to speak with Vince Mazer, technical marketing engineer, who gave a presentation today, and we thought it'd be a good idea, because some may not have seen it, to kind of fly back over it. Let's circle around and fly back, Vince, and you can tell us about the presentation and the high points, some of the points you hit, and full transparency, I didn't get to hear it, so I would love to hear about it, and maybe I'll have some questions for you too. So take it away.
Okay, well, it was entitled Avoiding Supply Chain Issues with Variance and Live BOM Part Choices. And variance and live BOM part choices are characteristics or capabilities that our products support. And basically, I started off with a review of electronic part supply chain fundamentals, talking about the difference between a manufacturer part number and a supplier part number. Talking about product discontinuation notices, product change notices, how you can sign up with those directly with your silicon vendors. We also talked about, just decomposing part numbers. I'm sure that was review for many people, but the idea of, that manufacturer part number and how it's made up of a lot of different codes, typically separated by dashes or not. We talked about the product life cycle definitions and referenced some research that was done on that and published in the IEEE. The life cycles being like pre-released, recommended for new designs, volume production, not recommended for new designs, end of life, and then the final obsolete. And then we transitioned into talking about some of the environmental initiatives that are tagged, that components are tagged with. I mean, we've all heard of RoHS, but there's also REACH that impacts some designers, as well as conflict minerals.
Sure.
And such. So that was, I can continue, or if you have any other questions on that so far, let me know.
I think that's a great overview. The questions I would have are, did you delve into and are these topics relevant to how hard it is to get parts right now, and I think it ties right into the systems now that we have in place to go find those parts. We enter data. I'm getting that we enter data, and we have search capability, and knowing knowing the pieces of the puzzle as far as part numbers is really important. Talk to me more, and talk to our audience more about that.
Yeah, I'll just continue through the agenda because I've only went through some of it. We do get to all of that in the presentation. We talk about, adding part choices to your components and such. But, we also introduced what I thought was, I don't know, I thought it was the more intriguing part of the presentation, at least from producing it. We talked about design architecture and the trade-offs, whether you use a board with a lot of daughter board connectors or, DRAM module chips, that type of modularity and the trade-off that has on sourcing. We went down a layer of abstraction, and we gave an example of where you can use an integrated, 8-pin SOP switch, or you could design that same switch for this specific application using a discrete implementation with about 5 resistors and 2 transistors. And as it turned out, that IC is in short supply and about $5 a part, even in quantity. And of course, the discrete implementation was pennies. So we talked about how design architecture can impact sourcing.
Being able to manipulate the variance to come up with solutions that are procurable is the deal, right?
Exactly. I mean, we're all familiar with the idea of using an alternate part, but what about an alternate implementation? And our tool set has been adapted to that for at least a decade, probably even more, with our reusable design blocks. So you can actually, you can proactively anticipate what kind of issues you're going to have. And indeed, that's, what we went into. We had a section on early planning for critical blocks and components.
Some of the design challenges that we face as people who lay out boards and are fed schematics and need to find these parts, sometimes there's a strategy out there of actually designing in multiple footprints to the circuit, which can get real clumsy, and you end up with a lot of copper patterns or combining copper patterns. Do you feel that that's a good strategy, or is it a necessary strategy? In fact, what that would mean from what I hear is that we have maybe 3 patterns that we've designed into as alternates, and but even those 3 alternates may need, you wouldn't put them in without several sources. You stack the requirements. What do you think about that?
Well, I mean, it depends on the application. I mean, the idea of having, multiple footprints may work very well. I gave 2 examples in the talk, one being a beeper, one that had it was the pins were in line with the sound port, and the alternative part were rotated by 90 degrees, and we just built in a footprint that would accommodate either one. Now, there wasn't any kind of EMI issues or crosstalk issues. It wasn't a critical situation. Exactly, but there's that trade-off between how you might impact the performance of your design and the idea of being able to get your design done. And, a really fundamental point that I made is, you got a choice. You can either not produce your board, and again, we gave an example of a crystal, an SMT mounted crystal, or you can take the time or pay the cost to solder in an available through-hole crystal in its place. So these are just the kinds of things that we have to, design, or think about now. And it's the idea of, maybe having some just in case designs ready to deploy if that's the way you need to go.
Absolutely, and we always it makes me think as a designer, we always need to be conscious about the technology. You know, it'd be nice to have alternates, even if it's an alternate shaped SMT footprint that's interchangeable with a different style SMT footprint. When you mention that, you know, if we have to punt and the only available part is a through hole part, so we design a pattern for that. We have to know and really communicate with our assembly stakeholders that you know, if we go that pinned route, what that's going to cause a whole different manufacturing process change, and everybody's got to be aware of that and how to address it down the line, right?
Yeah, absolutely. And I know with our capability that, you know, we allow, you know, commenting at the schematic board level. There's a lot of collaboration and capabilities. You know, like when we define these what we call variants, which are a variation of a design. You know, a simple example being, say you have a processor board that gives you a choice of either 4 meg or 8 meg, or I guess I should say 4 gig and 8 gig memory. You can make that choice at assembly time. The BOM automatically updates and reflects that. Any documentation you've designed automatically reflects that. So what's forwarded to the manufacturer is exactly what they need to build, and also exactly what parts they need to procure.
Right. From a volume standpoint and choosing parts for volume, you know, again, the challenges out there right now are significant. We're relying on the relying on the system now to tell us what's available through multiple sources. Is there any human interaction at that point, or is it just the software going out to the web and collecting data from the web? Is there any value in calling up on the phone personal sources that can say, oh, but I have a secret source? Do we even consider that, or is that way out of the realm of the?
I think you can consider it. There's no doubt. It's just like when they talk about travel and hotel rooms. There's always hotel rooms available. They always allocate a little bit. I would maintain, though I can't say I have direct experience, that there's probably always some parts available. So let me answer your question in a couple of parts here quickly. The key is to be able to have early warning that you have a problem. You may have already selected a part, you're looking good, and you find out mid-cycle, just like airline tickets, you can't get those parts. And so, again, what we showed in this talk is how our products are instrumented, if you will. The awareness of what supply chain issues are intrinsic to the product. When you're placing components from your library, you get a flag if you have an issue, a stock issue, an end of life. When you're looking at the component parameters and you select that on the schematic, you're flagged on that. It's all throughout the product, because that's an important aspect to have that early warning. Now, if you're really in a bind, and especially if you have some decent volume, I mean, one of the dynamics that I've seen in this last couple of years is if you're a small person, small company, buying maybe thousands of parts, you're probably going to get bumped. When you buy parts, it's not like at the meat counter where you pull a ticket and you're guaranteed to be called at that number. You will be bumped.
I thought I was good at metaphors and analogies. That was a good one.
Yeah, I mean, I've been bumped, so I'm really sensitive towards this.
Yeah, absolutely.
But so that's when the call could be important. That's when the relationship with that component rep is important. You know, sometimes companies are trying to get a product out the door that can mean a lot and can even mean more business for that semiconductor company. And so making that case and seeing if you can get an earlier position in the line could be a really good thing. I mean, the personal relationships can come in very handy. Having said that, I find when I do my design and such that I am relying on that instant connectivity to this component cloud. It's just quite amazing. And it's just is really something how quick things can change. I know I've given demonstrations before. I prepare for it and everything. Everything looks good. And on the demonstration day, I've got parts that are out of stock. It's just the way it
it's
works.
Inevitable. Yeah,
yeah,
it is. But the good news is you're using the tool and you're using technology and you're using data to make intelligent decisions. But the first thing I think about, being old school, I got this gray stuff going on here, is, you know, are we making the workflow, a digital workflow, a stakeholder in finding availability of parts, which in a sense is kind of replacing the personal stakeholder, the supplier management group or the purchasing group or the people that service and provide the components. I think in summary, what we just discussed is, you know, maybe we need a little of both, right? We can't forget that human stakeholder out there that really is pulling the levers. Would you agree, or
yeah. I think one of the things that's going on in many aspects of design is a lot of awareness is being required to be moved earlier into the process. So most designers don't usually worry about sourcing components, but you have an opportunity to help your companies if you are aware of that. And just to use another metaphor from, you know, the national security aspect, is if you see something, say something. Even though it's not your job to order parts, you know what, if your company can't ship its products, you know, that's not good for anybody, down to the person that cleans the offices in the evening. So there's an and the other thing is that, you know, imagine trying to do design work without the internet today. I mean, you can do it. We did that before. You know, I used to have to sort of beg for data books, you know, those things were expensive. But imagine trying to design now. So what happens as more people adopt this digital infrastructure of supply chain information, you're just going to be at a disadvantage. And we've seen many areas in our technical space where that dynamic is played out.
Yeah, because it's instantaneous now. We have instant access to knowledge. I was going to make a silly comment about, because it made me think about back in the 80s or the 70s of, you know, if we had had the internet then, how great that would have been to be able to use it to order more tape to tape up our artwork.
Right, exactly.
we had no idea this was coming. We had no idea
Bishop
this
Graphics
automation
comes to mind.
Yes.
Bishop
Let's
Graphics.
name drop a little bit. and we did it back at, you know, 10-1 or whatever.
Yeah.
The old days. Yeah. So it was really amazing. You know, one thing, we signed off today off the show floor, and we I didn't have a chance, or it didn't come to mind at the time how cool it is. I think I'm going to write something about this. How we've gotten to the point where now we can use Altium tools, and we can bring in step files, and we can create these wonderful designs that, you know, we hit a button and we're in 3D mode, and we can rotate these parts around before any parts are ever assembled or cut, or any materials ever ordered. We have a design, and we're flagged if some of the components in the assembly are not available. You know, we have all this data. But what was really cool on the show floor is to walk through all the processes, and I had an aha striking moment, that because we talked to an assembly supplier, and we get down to the end of their assembly processes, and what do they have at the end of their assembly process after it's gone through pick and place, after it's gone through the reflow ovens, it's been stenciled and everything. But we get to the end, and we get to an inspection point, and we get turned on to 4D inspection. They're calling it, where they're snapping pictures on top and around, and they create a 3D image. and this is a pictorial 3D image that's been created photographically of the actual parts that have been created by all the processes. And so it's almost like we could put this one image up of the Altium 3D view of what is to come and the end view of what was actually made, and I think they look really similar, and it's just, that's amazing to me. I think we live in a great age.
Yeah, the optical inspection in general, you know, they can read component values in some cases and look at solder joint quality, and you know, thankfully that's come along as technology has escalated as far as density, speeds, etc.
Absolutely. So back to ordering real quick, and then, you know, I know you're busy. Talking mostly about components, but, you know, availability issues at the previous level, at the bare board level. Did your talk happen to touch on availability of materials? Because this can be an issue out there too, or is that part two, or you know, a previous part A or B?
Well, I think we didn't touch on that, and I'm assuming that by materials you're talking about bare board materials.
Yeah, laminates, for instance.
Yeah, exactly. Because I was talking to a major fabricator based in the Chicago area, and in the conversation, I said, "Hey, by the way, you having any issues with these supply chains? What are you seeing from your customers?" You know, and they say, "Well, we're seeing a lot of board revisions because people are redesigning around alternative components." That's understandable. But the thing that she said that I never really thought about is she says, "You know, we had this pre-preg that we could get in 2 days. It's a specialized pre-preg. Now we can't get it for 6 months." I mean, that's really a bummer when you can't even get your board fabricated.
Yeah, just throwing it out there, floating that balloon that maybe, you know, could the same process, the same alerts come up with for stack up, when engineers and designers are creating their stack ups. That, you know, that gets back to stakeholder awareness. Who are the people that really tell us who can build this board and what is available? You know, that may be another story for another time, another chapter in solving this problem of awareness. You know, maybe in the future that can be worked on as
that's a great idea.
Created.
I mean, it's the same thing. You need a certain material and you need to know whether you can get it or not. I mean, fortunately in our existing solution, you know, a lot of the mechanical parts that you would use, whether it's battery brackets, screws, standoffs, things like that, those can all be instantiated in your design and made part of that awareness. And, you know, that's the reality about this whole electronics gig is, and you got to have all passengers on the plane before that thing can leave. And you can have you can be missing an insulated washer you can't get, and you can't ship your product, or you have to do something crazy. So it's all important.
Yeah. I think there's many of our viewers online here who can relate to those stories. I know I can, and you know, it's a challenge out there, but we're here to solve them. And
exactly.
Very, very interesting talking. You know, I'm definitely going to watch your presentation. We've captured them here, and we can call them up at will. So that's wonderful. Vince, it's been a pleasure catching up with you and meeting you. We haven't met before, so I really appreciate the opportunity, and that you've leaned forward and you're presenting valuable information.
Well, thanks a lot. Nice meeting you too.
Yeah, great. Well, I think it's a good time to tell everybody good evening. I don't know if we'll come back in tonight, this evening or not. Here it's what is it, about 5 or going on close to 5 Pacific time. So for any of our viewers out there, we'll probably not be back this evening. Yeah, and we'll be back, I have a feeling. What's that? We will be back today, I'm told. Okay, so hang out. I'm glad we'll be back today. I love talking to you. And Vince, thanks. It's been a pleasure. Thanks so much. And to our Altium Live Connect 2022 audience, stay tuned.
Okay,
We've got some
take care,
sessions
Kelly.
coming up. Yeah, thank you very much, Vince. Real
Have
quick,
a good one.
Yeah, thank you. We've got a couple sessions, a few sessions coming up at 4:15. Is that right? They may have already started. We've got high power subject matter. We've got what is target Z, and how does that affect things? And we've got a microfab platform subject matter that you'll like to tune into, and footprint mistakes and how to avoid them. These are all very relevant topics, and again, I'm Kelly Dack for AltiumLive Connect 2022, and we'll see you next time.
Hello? Hey man, you gotta come check this out.
I'll be right there.
Take a look at this.
Whoa. This is going to change everything.
Invite Alex. Hey, are you seeing this?
Whoa, this really did change everything.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip, we're in partnership with the folks from the IPC. Stakeholders unite and feel alright, digging more show synergy. So let's all connect, come on people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine, check us out, virtual attendance, yeah.
Hi, Kelly Dack here, live at the IPC Apex Expo. Hey, look who I ran into, Mr. Charlie Capers, a good friend from, how long have we known each other? Forever.
Way back.
Yeah, since boards,
20 plus years.
Boards were made of phenolic or something like that. So, met Charlie on the show floor. Charlie's from Zentech, EMS provider. And I'm sure you're coming down here to do a little shopping and sniffing things out here. You know, it's first day. We're walking around. We caught you walking around, so we thought we'd walk. And
All right.
you know, when we when we walk by machines like this, what does it do? Let's pause here for a second. What does it do? We haven't been in touch with the manufacturer here, but we're on the show aisle, and tell us what you think about some of this stuff. What are some important assembly things to look for an EMS provider, and how it processes and handles the boards that are designed? Tell us all about it.
Well, you know, the things that we're looking for nowadays are more not necessarily pick and place, because if you're in the EMS business, you have plenty of those. But we look for other items such as testing and inspection and things of that, solder paste inspection, things like that. So those are the big things that we like to look at.
Right, because you need to ship quality. The boards are presumed to be quality components when they get to you. Correct. And you combine them together with the other quality components, and you're using solder. We talked to a solder supplier here. Let's keep moving. Yeah. We talked to a solder supplier a while back, and he described some of the issues, outgassing and bubbling and all things that can happen. And they also, then we talked right away to optical inspection, X-ray supplier. So very interesting. It's a critical process, right? What happens when a board gets shipped, or what happens when there is a defect? How do you determine how you're going to resolve that defect? Are you going to Is it correct your line, correct your process, correct your materials?
If it's a systemic defect that keeps on happening over and over, then you've got a processing issue, and you've got to analyze that and drill down and figure out what is causing this problem. Is it a design issue? Is it a fab issue? Does the designer, did he create the part correctly? There's all kinds of things, but for us, we have to kind of drill down and figure out what it is and determine if we need a design change or if we just need to change our process up a little bit.
How often can problems be fixed by design? How often is it the designer did the right thing, designed the best they knew, and when there's a problem, they give you the response that, well, the other guys had no problem with it. What's your response to that?
We've heard that many times. If it really is a design issue, it really is a design issue. If they worked around it, that's great. But, our job is to identify the issues and possibly, hopefully, correct it for future builds, right?
Yeah, and you have to be savvy about how to communicate. You never, I learned in EMS, working in EMS, I still am, that you never want to call the customer's baby ugly, right? No. But there is a lot of issues. In fact, this is one of the purposes for AltiumLive Connect, is to connect our design audience with manufacturers so that they can start this communication, so that no ugly babies get created.
You know as well as I do that us old school designers, we know how to design circuit boards. The guys that are doing it these days, they're engineers that have never designed a circuit board. So they have to depend on the tools to help them do what us guys used to do, because we're just artistic.
Another good reason for AltiumLive Connect. It's a matter of bringing our emerging engineers. We have the tidal wave of emerging engineers coming out of the schools. We just met one this morning after the keynote, and these are the folks that they're quick studies, right? They can learn software and the layout tools really, really fast. Yes. But like a kid running with scissors, the potential for injury or injuring somebody upstream with a poor design.
Kelly, you know as well as I do, if you don't know anything about the fabrication process or anything about the assembly process, then what good are you? You have to understand the whole process in order to design a board correctly.
Yeah, it's no longer can we design in a vacuum, especially now. We've said that the term DFM has been around for years and years and years.
Are here to find your defects.
Yeah. So what do you think about technology and the way it's going? Because I'm sure you're seeing customers that are bringing you challenges. I mean, it's the next level, the next dense package that you've got to put on. Either you're going to figure out if you're going to tool up for it, or deal with it some other way. What do you think about what's coming and what the designers will have to do in order to incorporate DFM? In fact, let me make my question crystal clear. Is there coming a point where design for manufacturing has been so almost outdated and we're going to have to start designing with manufacturing?
I think that is a great way to look at it, and yes, because, you know, if you're the type of company that just finds the cheapest guy to do the board because you're trying to save a few bucks here, yeah, maybe that's not your best bet. You know, you got to work with your partners and get to where they understand what you're doing and you understand what they're doing, and it's going to help you design, and it's, you know, it's going to help them manufacture, right? So it's a collaborative process, and that's the way it should be. Even your fab guys, don't just throw it to the cheapest guy because that may not be your best guy.
I'm learning a lot. You know, in the last 6 years, I've gone to work. I've gone to work for a bare board supplier, a well-known prototype supplier, and then moved on to an EMS provider in Pacific Northwest. And this is where my eyes were opened, because I started seeing board designs coming in from all parts of the world, and we were having problems with them. We have to, part of the job is to pre-engineer them or digest the design and evaluate it for not only for our assembly line, but for our bare board manufacturers. Where are we going to send this board to be manufactured? And at that point, it's disconnected from the designer. We have to find an assembly vendor who will fabricate it, or a fabrication vendor who will build it. And we get to the point where we send out for quotes, and guess where we go? We go to the cheapest for volume, because if you can save pennies, you can save millions on a design. So
true, but if conversely, if you have defects, then you're going to spend millions more.
But and it's presumed that we won't have defects. We get the boards quoted from the point of, yeah, without defects, please. We didn't sign anything that said you're going to ship them with defects. So here's the experience. Here's what I learned is we send out to 3 or 4 suppliers, and we get, they send us a quote. The lowest bidder wins it, you know, or whoever we have the best relationship with. And then 4 weeks later, we order zillions of them. And then is when the magic thing called an EQ, an engineering query, comes back from the supplier and says, oh, by the way, we can't do your 2.5 mil wide line in 2-ounce copper. Could you please switch it to, you know, they quoted it already. Right. So this is a big frustration that EMS suppliers have to deal with.
Yeah, and we usually have to take those EQs or TQs, whatever you want to call them, and work with the fabricator. It's not even our design. Yeah. And then sometimes we have to go back to the customer and say, you did this, you answer this. So, you know, there's no such thing as a perfect design, but I think if you work at it, you can get really close.
Right. And then, you know, to circle back to where we started the conversation is that, you know, that's where the response comes in. It says, well, our supplier before had no problem with it. And you ask, well, who did it? And it was a prototype supplier onshore who custom built the fabrication atom by atom, you know, so that they could get the clearances done.
Well, you know, sometimes if it's something very trivial, we'll take care of it ourselves. So they'll never know. It'll be transparent to them. But that's not always the case. So, you know, I guess to reiterate, you got to work with your relationship if you want to build good product and build it consistently. So
absolutely. Well, I really appreciate the walk and talk with you. This has been fun to, you know, it lets our audience see some of the things going on. Look, we got a robot going on here. There's so many robots. They're taking over.
Pretty good crowd here. Not exactly normal, but all things considered, it's pretty decent.
Yeah. Well, I tell you what, we're going to give everybody a rest here. Charlie, elbow bump or whatever we're doing these days. I really appreciate the opportunity to chat with you.
Thanks, Kelly.
Zentech, Charlie Capers, you know, you can find him on LinkedIn and ask more questions. Also, don't want to forget that we have a Q&A section here on our website. Make sure if you've got any questions that you'd like me to answer or ask the experts for answers, write them down, send them in. We'll look forward to that. So until then, for our next segment, is Kelly Dack for AltiumLive 2022 with Charlie Capers.
All right, thanks, Kelly.
We've got to get less wasteful, we've got to get better at what we're doing, we've got to be just generally more effective as an industry and kind of leading the way.
Everything that we've been talking about is based on improving the practice of engineering. But now we are bringing the business of engineering onto the platform.
When you talk to factory operators, they want to run their factory at about 90% utilization.
And what do they actually run in that mission?
62.
The process through which I communicate manufacturing information and intent to a PCB manufacturer has not kept pace with the tools that I have for designing PCBs. Altium Designer, which is the primary tool I use for designing PCBs, the capabilities of that tool have grown immensely, and yet the process through which I ultimately develop a release package and get it to a manufacturer has been completely static through that entire time.
So what we end up with now is really a supply chain that's very brittle and reliant on offshore manufacturing and mostly offline, right? So it's a very difficult environment to be truly responsive and agile when you're trying to build new product and innovate.
By far, the biggest obstacle that I frequently encounter in getting boards done correctly and quickly comes down to communication.
When we send something to manufacturing today, what's the very first thing we do? We create a package of data, and that package of data is not in the original format in which we created it, and it gets translated into a standard, and there's always something that's lost in that translation.
I'm able to generate all this detailed design information, but then ultimately it still just gets distilled into this like 40-year-old format that I send over the fence into a black hole generally. There's a lot of lack of transparency in this process that has enormous room for improvement.
There's been a lot of talk in the industry about creating a digital thread, the link between the design and the manufacturing. With Altium, they've been focused for years on digitizing the design, creating more capabilities to capture more about the design. At Macrofab, we've been focused for years on digitizing the manufacturing side of the business. So what we're now doing today is connecting those two.
I've released this design up to the Altium 365 cloud. And this is a board that we use in our factory to do some simple motor control for some assembly steps. But now I'm going to go ahead and send it over to Altimade to get fabricated.
With Altimade, the designer is going to be able to sit there right in the Altium design tool. And as they're working, the Altimade tool will contact the Macrofab platform and update pricing in real time as they make changes to their design. That means the designer, through Altimade, will get real-time feedback on the true cost to produce their design and any issues with it that might impact manufacturing or supply chain.
We are okay with the price, so at this point it's basically just as easily as saying, here's my credit card, make these boards. I'm really excited about changes in the manufacturing pipeline that will allow me to capture the far more nuanced and detailed design documentation that I already make in Altium Designer and get it to my fabricators and be able to close the loop on that.
People just expect things to work for them with the minimal amount of investment from a learning curve perspective, this kind of stuff. I think people expect this from engineering software today. Why should it be any different? They want good user experiences. They want to be able to put in the minimal to get the maximum out. They want to spend their time being creative, doing the things that matter, not jumping hoops through a system.
By having that digital thread of connectivity all the way back to the designer, we've seen products go to market in as fast as 60 days that would have taken 6 months previously.
Sometimes I just have an idea, I want to see it realized in reality, I want to make it happen as quickly as possible. Altimade has been the most efficient way to make that happen quickly and to get prototypes in my hands.
Well, gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and we'll feel alright digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Hi, Kelly Dack, back to you live from the Apex show floor for AltiumLive Connect. Our cameraman Michael and I have been roaming the show floor in between breaks. We kind of set up a few people to talk to so that we can bring to you some interesting technology on the show floor. Let's go around the corner and see what we can do here. With us today is Takamura Hara from Japan. Are you from Japan?
Yeah, from Japan.
Really?
Yes.
So tell us about your products here.
Okay, yeah. So our main product is a string gauge.
What is your company name, by the way? I'm not seeing it on the...
Yes, my company name is Kyowa.
Kyowa.
Yes, and I'm part of Seiko Machinery's booth.
Okay.
Who they are contractor in the western side of USA.
Okay, very interesting, and you caught our eye because, you know, designers, we need to get in touch with what else is going on in the industry once our boards are designed, and this caught our eye as interesting technology because once a circuit board is laid out, once it goes off to the bare board manufacturer and off to the assembler, there's plenty of stresses that can go on to a circuit board, and one of them is post-assembly handling or installation or automated handling can stress the boards. So tell us about board stress, some of the common stress modes, and how your products handle it, measure it, record it, document it.
Okay, yes. So our main product is a strain gauge. So this is a strain gauge, which is a very small and a compact size sensor. This is very important part for deformation, compressive or expansion stresses happening on a PCB or any kind of material. So strain gauge has been used for fatigue analysis and stress analysis of all industry.
Oh, okay.
Yeah.
So I see some of these strain gauges are already connected, and then they're providing data for your software here to show, explain this.
Yes. So this is a strain gauge. This is actually bonding on a printed circuit board test pieces.
Okay.
So setup is very easy. We can apply the strain gauge onto the target by adhesive glue within a few seconds, 30 seconds. And the strain gauge is connected with a data amplifier, signal amplifier here. This is a PCD400A signal recorder available for 4 analog channel input. And we can stack up multiple units, maximum 4 multiple units. So this is available for 16 measurement channel.
So one per sensor?
Yes.
Okay. Now, these sensors are attached to many boards, or typically one board under test in a run, or for specific circumstances. Say, you know, this board, I see a couple mounting holes on here. You know, a common problem in assembly is the next assembly or post PCB assembly, where the board is going to get installed into an enclosure which may have warped. What happens to the circuit board when the fasteners are tightened down?
Yeah.
It can cause these stresses. So tell us about how this works at this point, and what you see on some of your meters here.
So one of the common failure we have seen is crack happening on the CPU ball joint alley. So the common solution is applying the strain gauges onto the multiple corner onto the CPU board. So here you can see a triaxial strain gauge with a 3 axis of the strain gauge. Yes. So by using our software and the data recorder, we can catch up the strain with a real time.
I was dying to do that. I wanted to ask you for your board so I could flex it, and I didn't know if it was the right thing, so I'm glad you did it.
Yeah, so we are seeing the strain value from the 3 axes. And this software is supporting rosette analysis for calculation principal strain in the real time. So this is the most advantage of our software and our strain gauges.
Now, does this data, can we record this data for?
Yeah.
Very useful for analysis and trading analysis or documenting conditions that aren't intended, but you may have to prove for some reason or other.
Exactly, yes. And right after recording process, this software can generate test reporting document, including every strain data of every sequence. And our software called PCAS 1000A series. This is a parse number for the software and a data recorder complete package set. Yeah.
So this comes as a package, PCAS 1000A, strain gauge recorder or sensor and recorder. Okay. Well, it's been very interesting. The show has just started, and I see it was hard to get some of your time here because people are definitely interested. So we're happy to bring you to our audience, and we hope our audience appreciates it.
Yeah,
I'll give you an elbow bump. Takahiro Hara from Sika Machinery Incorporated. Check these out, and don't stress your boards. Thank you very much.
Thank you very much.
In the meantime, let's stroll on over. We'll walk the show floor here, and we'll check the availability over here at Ko-Young. They have a ton of very interesting assembly equipment. We've been talking about boards and bare boards and what happens to them. So let's see if we can meander in here and make a connection. Ooh, hello. Hi, Kelly Dack, Josh, Joel or Josh? Joel, sorry.
How are you today?
I'm doing very well. With me is Joel Scotchfield.
Look at that,
We
the
haven't
first
met
time.
yet.
Yeah, most people don't get that right the first time. So look at you.
I try hard.
You're
I try
very
really
good at
hard.
phonics, if anybody remembers what that is.
Well, Brent hooked us up. We were strolling the aisles, and we're with AltiumLive Connect 2022.
Okay.
We're live on the stream. Viewers here who are, of the printed circuit design audience, and our goal today is to put them in touch with the other stakeholders in the industry, the assembly stakeholders. We just talked about some stress gauging over here. We've talked about solder, how solder is applied to the board. And now we're at in an assembly environment, and you've got a ton of machinery here that puts the boards together. It puts it all together. So we're hoping you can tell us about that. And from a designer standpoint, what can we show designers? Capabilities, and maybe some potential problems or things that our designers could do to improve the process flow as they go through your machines. We can walk.
How about that?
Okay, we can start there.
From an inspection perspective, and that's what we do. We are the leader in this space for inspection technology for PCB applications, and that covers everything from solder paste inspection at the very front of the line to pre-reflow inspection, where we can now verify polarity, part markings, missing, et cetera, pre-reflow, which reduces the cost of repair, and certainly in cases where we have customers that cannot repair, right? It's an edict, right? You scrap that board if there's a defect. That's big, right? It also provides a lot more process feedback into the process itself, right? Maybe I've got an issue that I need to address with my pick and place. Eventually, we'll be able to self-heal with that feeder, spindle, nozzle, right, as well as XY. We then moved to post-reflow inspection, where now we're looking at all aspects of the solder joint, in addition to if you're not doing pre-reflow, polarity, part marking, et cetera, et cetera. So the added element there, of course, is the solder joint itself. And so I was jokingly saying no bottom side terminations, right? You know, that's something that you really, for the most part, need X-ray for, right? We are using structured moire lighting in a 3D context, where we're collecting up to 32 images per field of view to rebuild a 3D rendered image that we can take volumetric and height measurements from. So
I tell you what, as a designer, we like to visualize things. And I have a saying that a picture is worth 1,000 words, but checking out the actual part is worth 1,000 pictures. Would it be possible if we walked down some of your line here and we could get a glimpse of the machinery and you could tell us what's going on?
Well, I've got a couple things I can do for you. In fact, let me start right here. So we've got a couple of opportunities that we're actually giving away here at the show. We've got something called the Printed Circuit Assembler's Guide to SMT Inspection. Now,
put out by iConnect, I recognize this. They do a wonderful job.
Sure. Yeah, it's not a designer's guide, but it is an assembler's guide, and there's definitely value in that. So we've created this to help our customers understand the entire inspection process, and some of that does cover design for inspection, design for test. Likewise, we have this is our version 9 demo board, and we, with this, basically simulate all of the various challenges that exist for assembly, right? And again, it's been designed into that board itself, so we can.
What would the acronym we're familiar with is DFM, Designed for Manufacturability. What's the acronym for designing for maybe failure? DF squared or something.
I think it's really more of a design for test. So what we do in here is we go through and of course inspection is a form of test, right? So we go through various elements of that process, and we talk about actual cases of tests that have been done, let's say, and things that people need to be thinking about, probably more so when they're testing 3D technology and inspection technology in particular. But yeah, these are very much available.
Both of these publications look really comprehensive. May I thumb through this just for a sec? I'll give you this one just for a sec, but this is the beauty of coming out on the show floor. And for those who can't during this time, can they contact you if this looks interesting? I mean, may I show some of the detail here? The detail of what some common failures, not only a textual description, but look at the detail of photos and diagrams in here. Highly suggest that you contact Co-Young and perhaps get a look and check more out.
CoYoungAmerica.com, all one word.
There's also, I recognize this and I'm familiar with the iConnect 007, or the iBooks they call them. Here's yours on SMT inspection, another, it's packed with information.
It is, and we've actually put together a 12-part series of videos that kind of break this down, right? And myself and another one of our engineers who's focused more on the MES Smart Factory side kind of go through it and talk about the specific elements that are embedded. So yeah, it's very educational, very informative, and as a designer, if you understand the process more completely, you're going to be in a much better position to design effectively for your assemblers. And being someone that started out on the manufacturing side many years ago, and sitting in those design reviews before we had all these fancy tools that automate a lot of it, it's a big deal, right? It really is. I mean, you have to understand what your manufacturers can do, can't do, what are challenges to them, what makes life easier for them. The better you understand all that, the more solid and robust your product's going to be.
Absolutely, and not just for now, but for the things to come, because I'm sure you're forward looking, and you're not only checking out technology now, but what is coming and how are we going to address it, how are we going to help the industry and the assemblers out there to adjust.
Yeah, the interesting thing about our business is because we are number one in our space, and we do work with the who's who of manufacturers globally, both OEMs and EMS companies. We get brought into those conversations very early for what comes next. You know, you can certainly understand that there are some large, without mentioning names, one particular mobile phone company that doesn't build anything themselves, right? But they want to ensure that the people that are building for them have the capabilities to handle, you know, what comes next from their perspective, right? So we get pulled into those meetings, and the benefit of that is that everybody wins, because we don't do customized applications, right? We build that into our software, and everybody can share in that capability once it's released. So.
Well, like I said, I don't want to put you on the spot, but picture's worth 1,000 words, but the actual parts are worth 1,000 pictures. Would you walk us down our line, or could you? I know it's very busy, and there's a lot of sales going on right now.
See if I can find a demo board that we can pull out of the machine and maybe look at a little bit.
You. Sure, we don't want to lose you. Come along. This is what we do on the show floor. Sometimes you got to work to get your information, but you can see that there's plenty of people that are more than willing to help us learn. Here we go. Let's get learning.
We'll take a look. We'll take a look at our demo board here, and that'll give you a little bit more insight, maybe into what we put together here. But yeah,
Fabulous.
Yeah. As you can see, you know, we basically run the gambit, and this is just a comprehensive collection of spacings and geometries for the most part, and we're basically looking at stressing the test environment, right? We want to make sure that our customers understand that when they're evaluating a piece of equipment like this, they absolutely need to push the limits of that piece of equipment and ask the right questions, right? So, you know, we've intentionally designed in a lot of that complexity that we know exists in the.
This is interesting because in the pictures in the book, I'm not wearing my glasses, but I presumed that these were failures already on the board that you were going to look for, but it appears as that this board was designed with pushing the limits, weird angled, designed components into weird angles. I get it now. Importance of the physical part.
Correct. No, you're absolutely right. We actually have another sample that is exactly what you just noted, which is it's an identical board. Half has defects built in, and half is known good, right? So that allows us to then, you know, first show the capabilities from the known good, and then verify that, showing how it catches those defects and you know what they would potentially look like. So again, it's important. You know, it's important for customers to understand, you know, the capabilities of the system, at the far ends, right? Not necessarily in the sweet spot, particularly as we talk about, as you alluded to, future-proofing, right? Yeah, you're buying this piece of equipment, it needs to last 10 years or more, right? It really does, and that's what we're doing.
Okay. Well, I really appreciate your time talking with us and showing us the wares. It's so valuable.
Appreciate the opportunity.
With us has been Joel Scutchfield from Co-Young.
Yes.
This has been so wonderful, a very good interview, and you have so much more to see, but I know you have limited time and you've got to get back to your
We
your
run
folks.
the gambit, but you can find it all at coyoungamerica.com.
Okay, very
Easy as
good.
that.
Look them up and get these manuals or these texts.
We'll be happy to send them your way.
Very good. Thank you very much. Elbow bumps.
You got it. Okay, man.
Take it easy. Thank you. Well, this is just another example of some wonderful, wonderful information that you can receive here on the show floor. And for our audience who couldn't make it this year, couldn't make it to Altium, again, our goal here is to bring the show floor of the IPC Apex Expo to you prior to the AltiumLive Connect show, which begins tomorrow, kicks off tomorrow, where we're going to have tons of topics and speakers to explain a lot more of this stuff, explain theories and methodologies and things to consider for board design that are going to help your boards run through the assembly areas, so folks like Cole Young won't have to find any defects. I've been out here on the show floor, I don't know how long we've spent, but it's been a good time. We're going to try and come back to you on the hour or the half hour, so keep an eye for us, peeled for us, and we will sign off for now and see you next segment.
As the complexity and demands of electronics continue to increase, the need to improve digital continuity throughout the entire electronics development process is more important than ever. This is the journey towards digital transformation, and while many companies are investing in technology to support this, they're encountering one major hurdle in the last mile of this journey: the inability to digitally connect ECAD to the rest of the enterprise. This means that the value chain still remains isolated and process disconnected. But with Altium Nexus, this all changes. Nexus provides a digitally integrated solution that overcomes this last mile in the journey towards digital transformation, making it not only possible, but easy. By digitally connecting your ECAD into PLM, MCAD, simulation tools, and other technologies, processes are automated, organization-wide visibility is enhanced, and resources are optimized, leading to accelerated design time, lower costs, improved quality, and most of all, a competitive advantage. Explore Altium Nexus now.
Well, gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and we'll feel alright. Digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Hi, Kelly Dack, back to you on the show floor of the IPC Apex Expo for AltiumLive Connect 2022. Hey, here we are. This the place seems to be buzzing. It's got a little vibe. It's the first day. A lot of people are at classes, but the suppliers are geared up and ready to go. We snuck in here a little bit yesterday, and we were able to see some of the setups, and we tried to get some reaction or some comments, and a lot of them were so busy they just couldn't at the time. So we're hoping to bring you with us to watch and take a look at the show floors and introduce you to some of the suppliers who have worked so hard to set this up and show off their wares. These are the manufacturing process stakeholders. These are the people that our emerging engineers will need to understand how their machinery works and their capabilities. We talked a little bit about that last segment. So follow me. Let's go along here and see if we can talk to some folks at a solder company. Here we have Jeff Giles. I'll give you an elbow bump, Jeff.
How are you?
So glad to
that you.
No, I'll handle it. But we prearranged a little bit. We wanted to make sure it was okay with Jeff that we talk about his company, Metallic Resources Incorporated, and we've got some questions. We want to talk about solder and what's important. What are the important features of solder, and how will the solder affect the way that our circuit boards, how the attachments are welded.
All right, very good. It's I'm happy to do it, Kelly. I'm happy to be on your podcast or what it might be. Metallic Resources, we are one of the largest solder materials manufacturers in North America. We supply globally just about any electronics manufacturer that you can think of. We supply a lot of different types of products. We supply bar solders, pastes, fluxes, and specifically the circuit boards. We do mostly, we supply HAL products, and what that means is hot air leveling products, so that you can coat your board so that parts can be adhered to the board. And we supply all different types of solder materials, tin silver solder, tin lead solder.
Let me explain for a second or ask questions. You know, we have many finishes for any new designers out there. We have many finishes on the circuit board. This circuit board happens to be what we call electroless nickel immersion gold, but there's immersion tin, and then as Jeff mentions, there's a hotter solder level, and there's all different kinds of coatings which serve to preserve the copper, the bare copper that's etched on the board, in order to keep it fresh so that and unoxidized, so that it can go through the next assembly process.
Correct, and the solder coating will prepare the circuit board for the adhesion of the components that are so important to electronics, right? And our solders are high melting solders, low melting solders. We pride ourselves in developing solders that will create better vias or through holes and better wetting, so that the components will adhere more securely and more fastly, right? So, and we're very proud of that.
So, did we talk about pastes at all, or is this solid solder you're typically providing?
Now, this is solid solder. We do provide pastes. We provide a Type 3 and a Type 4 type paste, and that has to do with the size of the sphere. So we're not into the very, very tiny spheres. We can do BGAs and those sorts of things, and we can make products. We have an in-house staff that we can make products to our customers' specifications.
Wow! So you can make custom mixes of solder paste.
That is exactly right.
This is something new. Very, because I work for a manufacturing company who, you know, sometimes we're getting down to components, you know, that are, you know, 1005s, you know, they're dust. They're basically dust. They're picked in place, but they behave a lot differently depending on the solder composition than other larger parts.
Right. So we work with our customers to make sure that the adherence of the solder component works to their satisfaction, and we might help them with some of their design ideas and manufacturability ideas.
Excellent. What can I ask you about? You know, there's so many electronics. Electronics has exploded. We've got some challenges, you know, slowing down the manufacturing process, like availability of components and things. But in general, how much solder is used a year? I don't want to put you on the spot or anything, but I know it's a lot.
It is a lot, and I think one of the concerns with the electronics industry today is the availability of tin. Tin is actually at the highest rate that it's ever been price-wise ever. And there are only so many companies that can produce tin legally and safely. And that's one of the other things that Metallic Resources can offer. All of our products are 100% recycled material. So all of our materials is made from folks like you giving us their used boards, used material. We recycle it and put it back out into the industry.
Fantastic.
And we're very proud of that.
Very good.
If you have supply chain issues, we can help you with that by cutting out that need for raw materials out of the earth, tin and stuff like that. We keep stuff out of the landfills, and we supply our customers with 100% recycled tin.
You're our first interview. The show floor just opened at 10 or so, and we came by and talked to you to ask if we could talk. And you know what? I learned something. This is, boom. First, I learned about solder, and this is why the show is so valuable. Why walking the show floors is valuable to designers, because we need to understand the components, the processes, and the people. And check them out, Metallic Resources Incorporated. We're so happy to talk to you. I'll take my board and give you another fist bump.
All right, thank you
Jeff.
very much, Kelly.
Thank you. Let's move along. We're walking the aisle here. This is our first aisle at the show floor, and we're going to go down to inspection company. That's another thing. You know, we design our bare boards. But we need to understand, once the solder gets onto the boards, the components. We're going to talk to some assembly people this afternoon, I have a feeling, go down the assembly lines. But once we'll jump ahead, we'll skip ahead. Once the boards are assembled, inspection plays a critical role in how boards, the quality of the boards. You know, boards can go out in the field. If they're not inspected, we can expect failures, right? So I'm going to be talking to some gentlemen. Let's see if we can sneak in here. Are you gentlemen available to talk to our audience? Great. This is how it's done. You walk the floors, you meet the people, you fist bump them. Boom. Thank you. David White from PDR Rework, PDR X-Ray. Tell us about your company and how you're involved in helping circuit board quality.
Sure. Well, our company was founded, we're celebrating 35 years in business. PDR is the founder of the infrared systems for the rework of printed circuit boards, a number of patents in place. And we also have our X-ray systems. They're 100% built in the USA, exceeding all the safety standards globally. Our X-ray systems have the ability for non-destructive testing. And at this particular show, we are focused on being able to detect failures in the manufacture of printed circuit boards.
Can I pause you for a second? Our audience needs to know what are some of the common failure modes out there that your machinery looks for. It used to be, you know, we had a inspection line and we had people with magnifying glasses, and now technology has changed so that we can't see the solder joints anymore, and that's where X-ray comes in. What are some of the most common failure modes?
Yeah, so there are many, wide and varied, but in particular what we is the components. And let's say in the example of a bottom terminated component, a BGA. So when the BGA goes through the reflow process, whether it's in a rework system or in a reflow oven, right, there's failures that could occur in that process. One of those failures could be what we call solder sphere voiding. And what that essentially is the chemistry, such as flux, outgasses in the process. Then little bubbles could be formed and then trapped in that molten sphere of solder. Too much voiding in that particular sphere is cause for failure and suspect. And so we have automated systems in our X-ray systems that will scan the component, measure the density of the solder sphere, and determine what the void percentage, either cumulatively or sometimes it's just one big bubble. And that bubble would eventually lead to failures. There'd be mechanical failures and the ability for the electrics to pass through that piece of metal. So that is one common aspect of X-ray failure analysis with our equipment. There are many, many others, head and pillow. We also take a look at the die bonding of the particular IC. to determine if all the wires within a printed circuit board are attached and as they should be. So that's one of probably 100 different, but those are common and understood. We also the ability to be very flexible in our X-ray in the sense that we design and manufacture, and most importantly, we use our secret sauce in the algorithms that we use in the software, which enhances the image clarity that the operator will see, and ultimately the machine vision sees and interpolates and is able to detect the anomaly.
So you mentioned it. You mentioned automated optical inspection. So your X-ray machinery is such that it can take a board like this or a very high density board assembly, and it can cruise through and automatically identify these voids or problems that we're talking about. About how long does that take? Does that happen rather quickly?
Well, there's a lot of variables that go into it. It depends on how much the focus needs to be, if it's an extremely tiny object versus a heavy mass object, etc. But typically, once the system is set up, the automated routine can go to pre-programmed teach mode, go to various different components or subjects that you want to take a look at on the printed circuit board, and then shift the X-ray detection, so on and so forth, to all these various points on the printed circuit board. And in that process then is developed the failure analysis mode, where we can detect different failures automatically. So it really depends on that throughput, what the speed is going to be.
Sure. That makes sense. I see a sparkly item here. The sparkly items catch my eyes. Tell us about that.
Sure. So in our rework systems, I think I mentioned, the founders of infrared rework for the entire industry over 35 years ago. Our rework systems use focused IR, which is a visible IR, so we can see where that component, where that heating is being generated for that component to reach temperature so that the solder becomes liquidous. All kinds of special algorithms going on to consider it a microwave oven in a crudest sense, but you have the basic controls, and you can set power levels at 70%, 60%, depending upon the mass of the printed circuit board. Well, this has been recognized by the industry, and that's why we're so proud to have this Global Technology Award. This one is for our rework systems, and this is an award that many engineers and peers in the industry review different rework systems. And now PDR is 3 years running as taking the global award for rework systems in the industry. So we're very
right on. Well, congratulations for that. And again, our audience, they're interested in technology, but part of our purpose here is to also guide them to the people that make it happen. So we're glad to hear about that. PDR, what does PDR stand for?
Okay.
I don't want to put you on the spot.
As many organizations, they have founders, that get things going. So PDR stands for Peter, David, and Roger.
Right on.
You guys way back in the late 70s, early 80s that thought, hey, this is a pretty good idea, and developed it, and rest is history. We operate in over 50 different countries, and I have been with PDR for most of that 35 years.
So for more understanding, you have a lot of shots of your equipment here. We're going to be walking down the aisles later and looking at some more assembly areas. Will we see any of your equipment necessarily on the show floor, or equipment like it?
Well, it's kind of you'll see some competitive equipment. The technology is usually based on a hot gas type of delivery heating system. Whereas there are primarily three technologies. One's laser, not so prevalent. One's hot air forcing a mass amount of hot air onto the printed circuit boards. Then you have IR. There's a lot of principal advantages with the IR method. You can imagine that you're heating up a printed circuit board and you've got large mass objects such as a super BGA, a connector, etc., then adjacent to it, small little caps that are barely visible to the eye, some of them in their smaller package sizes. And when you force the hot air onto the system, right, that air's got to go somewhere. You have reflow of these adjacent components, and then that airflow would blow like a lawn vacuum blower, etc., the components off. And so with the IR, it doesn't deal with the hot air. So even though you have a component that's adjacent to a larger mass component that reflows, it will not move off a registry, creating more work and confusion for the operator to get a printed circuit board back online.
So for our heads up, you mentioned the three processes. We've got IR reflow, we've got hot air, and
there's laser systems that are available. They generally tend to be very more expensive and less flexibility in the range of work that they can tackle. And of course, whenever you have a laser system, there's more safety requirements involved on it.
Okay, Dave, let me elbow bump you or fist bump you. We really appreciate you taking time to talk with our audience, talk with me, and we hope and wish you success at the show here. So okay, we're going to ramble on.
Website, it's www.pdr-rework.com. Lots of great videos, useful aids for industry partners, and I appreciate you stopping by today.
Very good.
Thank you so much.
All the best. Okay, let's move on. Thank you, gentlemen. We can walk the aisles here. At this point, we're going to probably, it'd be a good idea to give us a rest, and we'll give you a rest. That was a lot of information to digest. So we'll plan on coming back to you at least on the half hour. We have our full screen up when we sign off, so hopefully we tend to aim toward the half hour or even the quarter, so watch for us. And in the meantime, watch out, look the people we've contacted up, give them a look and see what else you can ask them. The key is get in touch and connect. So I'll sign off for this segment. Kelly Dack for AltiumLive 2022.
And to any customers out there that are not using this, I couldn't imagine not using these features. It would be very difficult to go back. Let's put it that way. So. I'm Jeremy Waller. I'm the senior electrical engineer at Quantel Laser in Bozeman, Montana. And that's part of a global company called Lumibird, and we have many design centers around the world. There's 18 mechanical engineers, about 22 electrical engineers in Lumibird that are part of the Altium 365 environment. It's pretty easy with Altium 365 to expand our environment. So we research, develop, and manufacture solid-state laser systems for medical and scientific defense-related industries. Yeah, I mean, our mantra, I guess, would be we're rugged, reliable laser systems.
I'm Lane McNeil, the senior mechanical engineer at Quantel USA. This is one of our newest, and it's a fairly high power, high rep rate laser system. So it operates with diode powered input, but it's water cooled. But the circuit board components of it, when we got going, we have some covers here that we put together, and they're kind of interesting. We have a number of circuit boards that sit inside the system. There are some fairly high power diode drivers that we use, coupled with some control electronics, and then we have some other electronics that are used for regulation of nonlinear crystals that we use to convert the laser output to different colors. Before we were using CoDesigner, basically we would get a DXF file is what we would receive. We would then take the components and we'd have to go ask them, okay, how tall are these components, and then we'd have to extrude the materials up to get an idea, because we have some very tight fit applications that are going on. So
a collaboration tool like CoDesigner just really allows us to transfer back and forth easily. Not only does it help us design the space, but it makes for better assembly drawings so that people can build and manufacture this, you know. So I mean, it changes a lot of the picture here.
It's an amazing step forward now to be able to have all the, you know, exact physical geometry completely understood and known. Being able to see that allows us to prevent problems that we were having in the past. We have an example here of one of our lasers that was a collaborative process using Altium CodeDesigner and SolidWorks.
Having the collaboration tool like CodeDesigner in there helped us with this board in this particular design. How did we get to this board, I guess, is a good example to go through. This is how it started a project usually. I mean, you just have a rat's nest of components and in this case, we'll just pull a few of the important ones that we need to find location on right away. Because I need to get Lane involved and give me a board shape that fits in the space, show me where the mounting holes are, and we just got to establish an area where we can do components. So I'm just going to push it over to him for the first time so that Lane can receive it on his end, and he's going to do all the work for me, thankfully. It takes all the risk out of the process.
Did you get that pushed, Jeremy?
Yeah, it's got it pushed over to your direction, so I've got it in there. You can switch over to your screen.
Okay, so I'm pulling it in here. Right, this. So basically one of the first things that comes in with these is gives us the opportunity to come in here and define the physical size and shape of the component. So that is the physical size of the circuit board that we wanted to work with. And then basically what we're able to do, I can position the component So with that kind of placement, then I'm able to come in and add cutouts to the circuit board. But one of the things that we often do is we will go in and add a feature on the board that's going to define all the keep outs. So I'm just going to define a new part at the moment that I will define as the keep out zone.
These are the features that are difficult. They're pretty obscure, you know, random shapes and everything. The thing is, this usually is a lot of back and forth, but since this is a board that we've already went through this process, what you're getting to see is like, you know, weeks worth of back and forth and arguing over shapes and space.
But it's going to have a lot of this information is going to show up in one shot and be pretty well done so that Jeremy would be ready to work with it as soon as we're complete with this. Okay, so I just pushed it at this point. So what you're going to see is Jeremy will now have the opportunity to pull the system into Altium when the push is done. It's still in the process of collecting. There, it's done.
It's already there. All right, so it is fast. I mean, this is great. You know, I would comment too, even when designs are pushed and updated overseas, our server's not even in this part of the country, so it's been really a good performing product. But I want to view the changes, see what Lane did. On occasion too, so it's going to give me a list of the preview of what he did. So if I like everything that I see, I can just hit apply and it's going to pull everything in there. Okay, so here you go. Here's all the changes he made. It's got everything I need to get started for the most part.
It would be impossible for a single individual focused on designing electrical circuits to be able to also at the same time envision all the detailed mechanics, because they don't have access to that information. And so this allows the mechanical engineer to effectively assist the electrical engineer in basically properly positioning things to achieve the most compact or the most reliable connection without a bunch of iterative problem solving and back and forth mistakes and fixing. I understand his challenges, he understands mine, and we work together to come up with a solution that works for both of us. And it's the thing that didn't happen in the past nearly as easily.
We're more competitive in the market now because we're able to get smaller. So now we're taking advantage of better PCB design technologies like micro vias and varied vias, and getting our circuit boards smaller and smaller. And at the same time, the space that we're working with in Lane's world is getting tighter and tighter. So it is definitely added to the quality and performance of our laser systems. And so it's worth every bit of time invested in learning the tools to allow you to provide those better products for your customers.
Well, gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite. You'll feel alright digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Hi, Kelly Dack here, back for our next segment, AltiumLive 2022. We're on the show floor with Patrick Crawford. Hey, Patrick, this has been wonderful. We just watched the introduction to this long-anticipated design competition where we have 3 finalists. Tell us, for those that may not have seen what we were able to kind of sneak in and do.
Yeah.
We didn't even ask. We should have.
It's okay. Invited anytime. Yeah.
Tell us about it. Tell us, you know, how it's working and what has led up to this portion of the event.
Sure. So we have the finals heat of our PCB design competition. Earlier, I shouldn't say earlier in the year, later last year in 2021, we had 14 individuals from around the world submit complete board designs. They were judged, and we whittled it down to 3 finalists. Those finalists are joining us here today, at least virtually, and they are going to be completing a routing competition. So it's only going to be routing and some component placement, and they have 4 hours. So it's pretty tight, but we're excited to see what they can do. We have their design tools, Altium Designer. They're all using Altium, piped through the house here. So it's exciting. I'm looking forward to see what they can do in only 4 hours.
It has been so long since I've seen a design competition in the industry at all, and so glad that you've resurrected this. Yeah. And do you mind if we kind of let's walk and talk and tell us about what's going on? I mean, we're actually seeing the software, and we're seeing the designer working on it. This is unique.
Yeah. So we thought it would be really we thought it would be really fun to. Of course, thank you. We thought it'd be really fun to not only watch what they're doing, but also, of course, to make sure we can see them as well. So Zoom worked. I think Zoom works for everyone these days. That's kind of the de facto space. So it's pretty simple. We just are watching them design, making sure we can see their bright and shining faces. And I don't know. There's not much more to it. It's just a simple way to get everybody involved, I guess. It's fun.
You think it's simple, but this is a very complex arrangement here to make all the connectivity work. To be able to display what people are working on to an audience, the pressure's got to be incredible for these designers. What do you think? Have you sensed any anxiety, or are they, at this point, they're all pretty well versed in it?
I think at this point they're all pretty well versed in it. Elliot Wakefield joining us here. He has the least experience, I think, and he self-professed, so I don't think I'm not disparaging him in any way, but even he has been incredibly confident. It's been very fun to watch him kind of grow as a designer in the last few months. So everyone is just super happy to be here. I think it's very fun. So it's a positive experience for everybody.
Very good. Well, thank you very much for talking with us. We're going to come back, or we'll probably come back and check on our contestants throughout the day. But again, thank you and IPC for organizing this, and it's really good to see. It's really exciting. We'll see how they do. When is the deadline?
6 p.m.
Today?
Today.
They got to get a board done by 6 p.m.
Yes. Don't worry. We'll be grading on partial credit. We know it's a little bit of an ask, but that's the point. Got to sweat a little bit, right? Sweat a little bit.
With the tools involved nowadays, capturing all those constraints, getting them fed in is a lot different than 10 years ago and 20 years ago. That seems to be a lot easier. So we're looking forward to that. Look at this. It's fascinating.
I've always found watching this happen, if you look at a tutorial or something online, like a design tool tutorial, I almost just want to watch just like a time lapse of the design happen, because it's just art. It's very cool.
On this tool, you can record?
I don't know about the tool specifically. I mean, we're using Zoom to record. I might turn that into a time lapse. In fact, I think I might now. But maybe, yeah. But it's exciting. Yeah.
Excellent. Well, thank you very much. I'll elbow bump you. You've got a yellow mask. That means caution.
Oh yeah.
You remember that your color? I'm kidding.
This is just the.
I don't know what black means.
What is that in football? Was it black flag?
Yeah, the black flag. Who knows? Who knows? Or
soccer, I guess.
Yeah, in the 1800s, a black flag was not a good sign.
Right.
Yeah.
Maybe we don't want to.
Well, thank you very much,
Well,
and
you so much.
best to you, and best wishes to all the contestants here.
Yes.
We're really looking forward to it. And for now, I think we've darted in, and now we'll dart off for just a little bit. And with me has been Patrick Crawford, you're managing design standards, but you're also the MC and coordinator of this event.
I didn't think it was fair to put it on anyone else, so I took it for this year. Maybe next year I'll find someone else.
And I think it's our first time meeting, so thank you.
Yeah, I think so too. Of
Yeah.
course. Yeah, great to meet you. Great to meet you. Thank you so much.
All right. To our audience, we'll see you soon at the next segment. We try and aim for the half hour or the hour to be on, so check back. Thanks.
Altium 365 lets you hold the fastest design reviews ever. Share your designs from anywhere and with anyone with a single click. It's easy. Leave a comment tagging your teammate and they'll instantly receive an email with a link to the design. Anyone you invite can open the design using a web browser. Using the browser interface, you're able to comment, mark up, cross-probe, inspect, and more. Comments are attached directly to the project, making them viewable within Altium Designer, as well as through the browser interface. Give it a try and get started with Altium 365 today.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and we'll feel alright, digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catch it how design and manufacturing combine. Check us out, virtual attendance, yeah.
Hi, Kelly Dack, back here for our next segment. for at the IPC Apex show floor. I'm talking a little quiet because there's a really major event going on right now for the IPC Designer competition. And we thought it might be nice to let you come with us. And Michael's going to just take a general shot, and I will go up to the speaker so you can hear, and we'll just let you see what's going on. Again, Kelly Dack for AltiumLive 2022. Listen up.
Let's do it. Okay, and while they are off to the races, we have a few interviews lined up for. Oh, hello over there. We got are we getting boosted through the house? What's going on over there? All right, awesome. So we have a few other events we're going to have here in booth 3209. We're going to have a conversation with some of the judges and progenitors of this competition. After that, we're going to have a live interview with CONNECT. They're going to be doing a little bit more of a structured interview with our judges and volunteers. Then throughout the afternoon, we're going to have 15-minute live interviews with the competitors. And finally, at 3:30 p.m., we're going to have an interview with IPC Education regarding our PCB design education courses and IPC education in general. So thank you. I hope we see some more people here to watch, and we'll go ahead and invite up the judges who are here, want to participate for a conversation about how we got here. We'll go ahead, let's give it until 1:50 if you guys want to head up, and we'll talk to you then.
Hello? Hey man, you gotta come check this out.
I'll be right there.
Take a look at this.
Whoa. This is going to change everything.
Invite Alex. Hey, are you seeing this?
Whoa, this really did change everything.
Well, gotta act fast, sign up for the broadcast of the Altium Altium Live 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite. You'll feel alright digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Hi, we're back with you again, Kelly Dack for Altium Live Connect 2022. We're still out here on the show floor. We had a little chance to put some nutrients back in our bodies, so we got refreshed, and now we're back down here, and we've walked by the Allied High Tech Products Incorporated booth, and we've got Gary, sorry, Lychee, and Pablo Mendoza. I make mistakes even when I'm on people's names, even when I don't have a mic in my hand. It's time to get to know you. So here we are, and they've got some interesting products here that have to do with circuit board inspection. So what happens at the bare board stage when your artwork gets sent out to the fabricator and they plate it and etch it and plate it and need to know or measure their processes? What do they do? It appears that you guys solved that problem. Thanks for talking with us. Let me scoot over here.
Okay.
We'll get in your booth. This will be our first in booth.
Great.
Tell us about Allied.
Well, we're a private company. It's been in business a little over 35 years, and we're located near Los Angeles, California. And we manufacture and distribute products for sample preparation, and one of that elements for circuit boards is for the high volume microsectioning applications. So for compliance with IPC 9242, and which I believe prior to that was TM 850. So we manufacture a number of products for doing that.
So with the plating processes, I'm pretty sure our viewers are clued in. It's a design community and more out there. A circuit board will be drilled or processed such that the plating has to get from one side of the board to the other or to the inner layers, and it does that through holes typically. And those holes and the plating needs to be inspected for the specs Gary mentions, and it's a matter of when the boards are complete, they'll go ahead and cut these boards, called a cross section, and they'll encapsulate them with some resins, and then show us what happens once you get these, how to prep these core samples.
Sure, yeah. You extract the coupon from the board, and then from the coupons, if we want to come over here to this side.
We can walk. We're good at that.
Yeah, I can stand behind here, and what we have set up here, this is a pin insertion apparatus where we take the pins, we load them into the feeder, and then we basically step with these spacers, and we step and create spacing between the coupons, and we create a stack, and the stack is then placed and positioned into a mold cup, and then capped with a rubber seal top, and then we pour acrylic or any kind of resin that you want to use to create an encapsulated stack. And then these encapsulated mounts are then taken out. Let me step around.
This is where it gets interesting, because this is like a polishing machine, and it's amazingly quiet. I love quiet equipment.
So this is a jig for holding all of the microsection mounts, and these are held in with little magnets, and they have carbide stops that basically allow you to grind to specific locations within the through hole based on the geometry of the coupon. So you would grind to one stage and then do a secondary grinding operation, maybe a third if you need to, and then do maybe a 2 or 3 step polishing process, basically to polish the samples into a condition that they could be examined under a microscope. So
from a material standpoint, we have copper foil that goes horizontally in the board structure, that is not, it's not on an inner layer, it's not plated, it's raw copper foil, that has to be connected with the plated barrel, and that is, tell me if I'm wrong, that's the point of interest.
Yes.
We have to find out if that's subject to cracking or if it has cracked. I see some micro section views over there. Can we look at those?
Yeah, absolutely. Come on over. So once the samples are polished, they're going to examine them for defects and make sure the integrity of the board. Yep. And so what we have here is a motorized microscope that we put the microsections onto a stage insert, and then we have a program that goes in and scans multiple areas on each of the barrels, and then we can do automated measurements of all of the foil layers. We can do measurements of the plating on the barrel, on the knuckle itself. And all of this information then can be tabulated into a report for automatic database reporting for quality control.
Very good. And what are some of the challenges in the inspection now? I mean, with things getting so small, are you scalable here? Is all your equipment scalable to where you're going down to these super microstructures? I mean, the talk out there now is with the additive technologies that are coming about. We're adding microcircuitry, which may, who knows, may be plasma drilled and plated. You're able to inspect all these, right?
Yeah, there's defect analysis, and then there's statistical SPC control, where for quality control they're just taking measurements and making sure it's a pass-fail condition. But then there's also defects that are smaller than a lot of the geometries of the through hole. And so with a microscope like this, you can change the objective to a higher magnification, and you're able then to better identify and document those defects or artifacts. Some of the other things that you have to be careful about in the sample preparation area is to make sure that there are no scratches that can interfere with the automated image analysis. Those are artifacts generated through grinding and polishing that you want to try to avoid.
So this is more behind the scenes technology and process that designers don't normally get to see unless you ask. And the link between this process and before a board ever goes out for fabrication is probably a note in the note section of the fabrication drawing, which will state that test coupons must be provided, or samples, these same core samples could be provided as inspection points and inspection criteria for the boards, right?
Yeah,
so
protocols are written into the standards, and the customers stipulate what they want to see.
Yeah, so this is the link. So as a designer, it is really good to get your hands, go to your inspection departments, and you might rub shoulders with them and ask if you can see some of these core samples. And now you know the people that are doing them. So very, very good talking to both of you. Thank you very much. I'll give you a fist bump and a fist bump. I've been with Allied High-Tech Products, and we're going to keep moving down the line here and learn some more. Sounds good? Have a great show. Thank you so much. Come on, follow us down here. We asked if we could maybe get together with the iCape folks. You know, a lot of people went to lunch, and I think they're coming back out. We got Matthew Frazier here. Fist bump with Matthew. Did our contact come back yet?
He's here. He's here now.
He's with a customer.
He's with a customer, a very important one too.
Okay, well that's good news. We certainly don't want to interrupt that. How long have you been with iCape?
I've been here since the end of July, actually, of last year. So yeah,
and
this guy right here.
Oh, hey, this is Mark.
Yeah, Mark, how are you?
Mark Kelly Dack.
Get you on camera and do some interviews about iCape.
All
right.
Yeah. We're live right now. We're
live.
Yeah, we're live. we try and let you know that before you start talking, but you know this is live broadcast, and we're going out to our audience, the AltiumLive Connect 2022 audience. The show actually starts tomorrow, but we're working together with the IPC in partnership to get the viewers, the design sector, connected with the manufacturing sector. So wouldn't it be nice if all the designers could come down and walk the show floors? So for those who can't, we're trying to fill that gap for them and talking to fine people like you and iCape, who I know of. I'm connected in a sense with iCape. I've worked for companies that partnership with you, who are having success steering their products to the appropriate capabilities. Tell us about that. How you do that?
Well, I mean, we've been doing that for over 20 years now. Do you want me to hold it? Okay.
The only way I can keep control.
I get that. I get that. So no, we've had definitely successes doing that for over 20 years now. We started in 1999. We've grown, organically over the last 20 years. Starting in Europe, business started in France. We expanded in Europe. Then we opened our big office in China, in southern China, where most of the procurements and quality inspection, technical question, and all these things are done. Then we had a big move, a big expansion in Southern and Northern America, in the US, in Brazil, in Mexico. And we've kept growing over the last 5 years. We've done a lot of acquisitions last year, 5 new companies, one PCB manufacturer in South Africa called iTrax. Two companies in France, one in the Netherlands, a new one this year in Germany. So we are growing very rapidly. As you can see behind me, we have also a brand new logo, new colors for the group to help us grow in the coming years. So a lot of very exciting news in the iCape world, I would say. Of course, we also acquired DivSys back in 2018, which is great. We have that gives us, more and more options in the US market. DivSys is located in Indianapolis, Indiana. We have a big laboratory over there. As you can see, we are advertising lab testing. So a lot of tests that we can do on bare printed circuit boards and as well on assembled circuit boards. Cross sections, obviously, install durability tests, roughness, high pot, 2D dimensions. We have a brand new 3D X-ray that can help us, X-ray BGAs. We have a rework station for BGAs as well.
You're really spanning the technology. You've got a lot of technology, and it sounds like you've got a lot of capability. Do you mind if let's walk over here and look at some of these? Why don't you lead me in there?
All right. So here we have. A few samples of what we do as in terms of printed circuit boards. Once again, nowadays we cover the whole spectrum of printed circuit boards. On the top here you have a few samples of multi-layer PCBs. Today we can do up to 64 layers printed circuit boards, so quite very complex boards. Here in the middle you have obviously flex and flex rigid circuit boards. Same thing here. We are doing some very complex boards. For example, last year we did for one customer in Massachusetts. We did 8 layers flex rigid PCB that we manufactured in South Korea with a very with a very advanced manufacturer of ours. Right here, as you can see, we have metal core PCBs as well. A lot of those PCBs we produce for the lighting industry, automotive, street lighting.
Look at this real quick, because some of our designers may have not been exposed to the metal-backed printed circuit, which is not traditional glass epoxy FR4. This is a film material. Can you tell us about that? That has a copper layer and that is bonded to the aluminum surface here, which provides an excellent heat sink for components that get hot, like LEDs.
Once again, it's mainly used in the LED industry to dissipate temperature. Of course, you can use different types of aluminum back with different dissipation rates. It's been around now for over 10 years, 15 years, and it's becoming really very popular in the lighting industry for sure.
Yeah, very good. Now, does that get that gets processed and delivered as a iCape part number, correct?
Correct.
And do you own the technology, or do you but you guide it to the proper technology of strategic partners and keep control of it. That's the most important part, and you're very successful at it. You have
One big element, one thing we did last year is originally we were basically manufacturing PCBs or other products based on our customer requirements. So they would send us their Gerber file. We would make sure that all the important elements of the design of the circuit board itself are within the Gerber file. And if not, we would propose solutions, to size of holes or things like that we would like to drill. But one thing we started doing also last year is we created a new company, a new branch in the group that's called DeepSys France, that does full design of products. So today, we are able to create Gerber files for our customers. So basically take our customer's ID from their brain and turn it into a Gerber file, a bill of material, eventually a mechanical drawing, 2D, 3D drawing. So we are able now to offer this full service, do things as well like reverse engineer. We have some customers. I have one customer in mind. They are doing elevator controls, and they've designed their boards in the 80s.
And this engineering design capability, that's located in France, or
right now it's located in France, but it's open to all our customers worldwide. The team that takes care of this for us does speak perfect English, so they are able to follow our customers wherever they are. And if that segment, obviously, of our activity expands in the future, there might be a dedicated team here in the US. That's a big possibility as well.
I get a chance every year we're here to talk to some of your IK people, and like I say, it's a very pleasant experience. As a designer myself, I am not in direct contact. I put out a design, and I base the constraints, or I base the output on certain constraints. But one thing that designers are missing a lot of times is we don't know where the board's going to be built. So if, as a designer, if we get in touch with our supplier management group and coordinate with them as a stakeholder, we can find out where they're partnered with. And certain technologies, certain boards have a good chance of heading toward a company, iCape, or a company like iCape, that has known constraints that a designer can meet. So if we send a board technology to you, we know how to design it. We know your limitations, and if we don't, we can contact you. That's a very important link, right?
That's exactly how it works. I mean, we basically help you designers, build your boards. We have several locations where we can build boards in Asia, in Europe, in South Africa, here as well in the US. When you work with us, everything is transparent, meaning we will tell you exactly where your board is going to be manufactured. Of course, all the manufacturers we use have been fully tested and audited by our own service. You have access to our audit reports, so you don't necessarily have to audit those manufacturers by yourself. As you know, traveling to Asia right now with COVID is extremely difficult. So the advantage of working with us is we have a team of over 250 people that are already working over there, that know everything there is to know about the manufacturer. So that's really the service that we offer for you. And then of course we test, we qualify your PCB, we make sure they are manufactured up to the IPC standard. So yeah, that's basically the service we are providing to our customers.
Well, Mark, we really appreciate your time. Check out iCape, Mark Lost. I'm going to try this. Je suis heureux d'avoir vous rencontré. Yeah?
Le plaisir était le mien.
Ah bon. Merci. Thank you very much. This has been Kelly Dack. I'm looking around to see if there's something we can dart into, but we might be better off cutting it off for a few minutes here and coming back to you. We like to give our interviewees a little warning before we dive in on them. So that's what we'll do, and we'll see you soon. Kelly Dack for Kelly Dack for AltiumLive 2022.
We've got to get less wasteful, we've got to get better at what we're doing, we've got to be just generally more effective as an industry and kind of leading the way.
Everything that we've been talking about is based on improving the practice of engineering. But now we are bringing the business of engineering onto the platform.
When you talk to a factory operators, they want to run their factory at about 90% utilization.
And what do they actually run at that mission?
62.
The process through which I communicate manufacturing information and intent to a PCB manufacturer has not kept pace with the tools that I have for designing PCBs. Altium Designer, which is the primary tool I use for designing PCBs, the capabilities of that tool have grown immensely, and yet the process through which I ultimately develop a release package and get it to a manufacturer has been completely static through that entire time.
So what we end up with now is really supply chain that's very brittle and reliant on offshore manufacturing and mostly offline, right? So it's a very difficult environment to be truly responsive and agile when you're trying to build new product and innovate.
By far, the biggest obstacle that I frequently encounter in getting boards done correctly and quickly comes down to communication.
When we send something to manufacturing today, what's the very first thing we do? We create a package of data, and that package of data is not in the original format in which we created it, and it gets translated into a standard, and there's always something that's lost in that translation.
I'm able to generate all this detailed design information, but then ultimately it still just gets distilled into this like 40-year-old format that I send over the fence into a black hole generally. There's a lot of lack of transparency in this process that has enormous room for improvement.
There's been a lot of talk in the industry about creating a digital thread, the link between the design and the manufacturing. With Altium, they've been focused for years on digitizing the design, creating more capabilities to capture more about the design. At Macrofab, we've been focused for years on digitizing the manufacturing side of the business. So what we're now doing today is connecting those two.
I've released this design up to the Altium 365 cloud, and this is a board that we use in our factory to do some simple motor control for some assembly steps. But now I'm going to go ahead and send it over to Altimade to get fabricated.
With Altimade, the designer is going to be able to sit there right in the Altium design tool, and as they're working, the Altimade tool will contact the Macrofab platform and update pricing in real time as they make changes to their design. That means the designer, through Altimade, will get real-time feedback on the true cost to produce their design and any issues with it that might impact manufacturing or supply chain.
We are okay with the price, so at this point it's basically just as easily as saying, here's my credit card, make these boards. I'm really excited about changes in the manufacturing pipeline that will allow me to capture the far more nuanced and detailed design documentation that I already make in Altium Designer and get it to my fabricators and be able to close the loop on that.
People just expect things to work for them with the minimal amount of investment from a learning curve perspective, this kind of stuff. I think people expect this from engineering software today. Why should it be any different? They want good user experiences. They want to be able to put in the minimal to get the maximum out. They want to spend their time being creative, doing the things that matter, not jumping hoops through a system.
By having that digital thread of connectivity all the way back to the designer, we've seen products go to market in as fast as 60 days that would have taken 6 months previously.
Sometimes I just have an idea, I want to see it realized in reality, I want to make it happen as quickly as possible. Altimade has been the most efficient way to make that happen quickly and to get prototypes in my hands.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip, we're in partnership with the folks from the IPC. Stakeholders unite, and we'll feel alright, digging more show synergy. So let's all connect, come on people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine, check us out, virtual attendance, yeah.
Hi, Kelly Dack, back at you with AltiumLive 2020 Connect. Hey, we are still out here on the show floor, and I have some people I want you to meet. Great stakeholder interface folks at Downstream Technology. I ran into them earlier. I always look for them every year. We've got Joe Clark, and we've got Ray Fugit, right? Yes, see, I said it right. We've known each other for years, but on a first name basis. So, gentlemen, thanks for speaking with us. I tell you what, why don't we, you want to take a seat or let's stand?
Let's stand.
How do you want to do that?
If you want to sit, though, you've been probably walking. And,
well, as long as you'll sit there.
Yeah.
Let's do that. Because we need to be together for this interview. Yep. Ray, come on in, and we're going to be talking, and I'm going to be rocking the mic.
As you always do.
As we do, yeah. So it's a matter of, I'm going to stand up because I need to be close. Yeah, it's end of day, and speaking through these masks, you know, for us who are interviewers, we certainly don't want. Yeah, you're good. We like to keep them on, so that's what we're doing. And I have to talk louder, otherwise I get muffled out. Yep. But let's talk about Downstream Technologies. You're here every year. Yep. You're supporting designers and manufacturers with your software that's been evolving throughout the years. You've been around for how many years now?
22 years now. It's hard to believe.
I remember.
Yeah, we were Pad Software originally, you go way back, and then we were part of Innovator, and we spun out with the idea back in 2001 that the whole domain of design for manufacturing verification would move upstream, meaning not just done at the end of the line when you hand the data off to the manufacturer and then for them to come back and say, oh, you got a problem. The tools would evolve to be inline upstream for the designers to use. Very analogous to what happened with signal integrity tools.
Sure. So it's a matter of the older tools didn't include a lot of the design for manufacturing checks and things like that. Let me say hi to Ray real quick.
Yep.
And Ray, you do a lot of customer interface, and you when you're working with Downstream, Ray publishes videos and how-to videos and tips and tricks, and teaches extensively classes. And it's tell us what some of your customers are. What are some of the biggest challenges your customers have?
Well, it's that whole idea that you don't want to wait until you get these scrap boards to see if you had a problem. So originally it was educating our designer customers that they needed to do these types of checks, and they've all gotten it these days, and they are realizing that they need to do some sort of analysis before sending the designs out to be manufactured. So a lot more people are doing it. We've grown the product from the Barricam 350, and we now call it DFM Stream, some of the higher end analysis tools that we have. We have about 150 different analysis we'll run on a design. So now we've incorporated rigid flex analysis. So we've constantly evolved the tool over the years.
Let's yeah, I know. I knew you'd give it back. I trust you. If you don't mind, let's move around front here so we can, first of all, so we can get a good view of you folks, because
I think one thing just for your audience, just to understand where we fit into the new product development process. Our tool suite, we call ourselves the PCB post-processing. We take that virtual design, analyze and prep it including documentation for the manufacturing process, PCB fab, assembly, internal or external, and that's where our tools fit into the puzzle. So now let's take a look at, walk around and take a look at.
Because, sorry, I don't mean to turn my back to the audience, but traditionally design layout tools for electronics have not included the function of drafting, which sounds simple, but it can be, if it's not done properly, the source of so much confusion as design moves out to the next stakeholder, which is usually fabrication. If fabrication does not understand a process note or a material specification, that is where problems begin, and that's where a design may be released and sent to a vendor or supplier, and it'll be a month when the board actually starts to go into production that the phone calls will start, and so much time will be lost.
Documentation helps remove that ambiguity, right? It's the Bible. Now, the fabrication drawing is one thing, where the great complexity is on the assembly side. Now I'm dealing with assembly variants, assembly panels. I need to extract the centroid information for a stepped-up panel. That might be a flip panel. It can get very, very complex.
Yeah, so we didn't even get there yet. We were talking about fab, and I was thinking fab drawing, but this is important. Downstream is providing documentation not only for fabrication, but assembly, and helping smooth that out. Now I'm going to step into the middle of you guys, okay? And Ray, why don't you tell us what's included in a normal fab drawing?
Well, we're looking at one of our newer releases here, and one of the key things here is we've actually provided stack-ups for all the flex and rigid sections of a rigid flex design. Something that, as a fabricator, it's kind of a throw it over the wall a lot of times, and then you've got to really reverse engineer it to get it into something buildable. So by using our blueprint tool and intelligent formats, you can bring that information in and automatically create these various stack-ups. So if you have buried and blind vias, here's something that near and dear to me. You can separate each one of them into its own drill chart and in its own view. When I was a fabricator, I was responsible for going in there and verifying all of that information. So when the traditional way of lying to it, 8.1, 8.2, 8.3 vias, then you're really kind of lost, and you got to go out and try to figure out which spans those go through. Whereas this tool, you can just have that automatically shown to you in fabrication. And then,
shows well.
And then, as you mentioned, one of the other things that we'll do in our blueprint tool is assembly panel drawings, not to be confused with the fabrication panel. This sometimes takes days, and we've bypassed the traditional way of going out to a CAM tool like our CAM 350, and you can actually create the entire drawing inside a blueprint. And do intelligent score and web route merges and add your own mill tabs and all the things that people like to do to assembly panels. We can automate that for you as well.
And the whole key, what's really become nice with a lot of the tools, and I think Downstream led the way, is by leveraging the data within the design database. So you don't have to export, which surprisingly many companies are still doing. They're still exporting their data out to a third-party drafting tool and creating DXF, and then documenting it there, and the link is broken between the source data, and it may be scaled wrong, or there could be another problem, but this seems seamless.
And the biggest problem there is ECOs, because if you do it the method you just described, when there's an ECO, you have to do that entire method over again. With our tool, you just bring in the new data, and everything automatically populates.
Joe, let me get back to you. As far as here, let's trade places. We get along really well. Yeah. I've been working on the cattle ranch for a long time, and I have to herd the cattle, around, get them to work. So that's
now I'm a cow.
That's what I just did to you. Sorry, that was my bad.
Yeah.
So tell us about where Downstream's going from here. How the live shows are opening back up, and designers designers have a lot of new challenges with even smaller scale
Small scale
designs.
rigid flex is the biggest, and embedded components are the biggest challenges that designers are facing now.
And I noticed also, you know, the layer stack-ups and the materials, and I saw somewhere a really good view of, it's that one back there.
Of the 3D?
On your wall. A 3D view that is used for documentation. That's so outside of the box. I mean, we're used to stick drawings.
Well, but the technology now allows us to look at things in 3D, so why not? Not only the PCB, but also the stack up itself. So, you know, that's all part of the documentation side. Our recent releases all focused in on addressing the challenges with rigid flex, again, which, as I said earlier, is the biggest technical challenge customers are dealing with today. And of course, all this is enabled with intelligent design formats, ODB, and specifically the IPC 2581. Because without that, we wouldn't be able to reconstruct and build 3D models of the PCB. We can also do this in the DFM Stream tool with just Gerbers. So we can actually take your Gerber files that you might choose to send off to your fabricator and show you the actual physical PCB. This is what you'll get back from the fabricator.
Outstanding.
That green thing. So.
Outstanding. Yeah, very nice.
Where are we going? Yeah, you know, we'll continue working with customers to address the challenges of rigid flex, embedded components, and more. But you know, now everything is moving to the cloud. So we're looking for, you know, cloud-based tools. This is the direction we want to take going in the future for collaboration and so on. So our viewers will be probably the first step we take in that direction. And, you know, continuing to develop this kind of technology, how we deliver it to be determined.
This is so on message with both of the shows. AltiumLive's theme this year is connect, and we're seeing that designers need to connect with all of the other stakeholders, and the cloud is one thing that's going to enable a lot more of that. But interface tools are essential. Also,
absolutely,
yeah. So we're looking for
technology's there, so we can, you know, we'll be able to do that. Yep.
Absolutely. Well, thanks so much again
Thanks
for talking.
By.
Yeah,
Great to see you.
This is a walk and talk. It's different than the sit down interviews. They're all good.
Next time, let's do it on your ranch.
Okay, it's a deal. You guys had too much fun last time you visited. So, yeah, we've been with Joe Clark and Ray Fugit. Downstream Technologies, and we're going to move down the row here because we can. Okay. So thanks for talking with us.
Thank you so much.
Okay, let's go, viewers. We're going to head down to Sunshine Global Circuits and to Jimmy Fang.
Yes,
Jimmy,
hi, Kelly.
thanks for taking time to talk to us about your company and your capabilities. Tell us about SGC Circuits.
Okay, SGC stands for Sunshine Global Circuits. We're an offshore manufacturer. We're not a middleman or a broker. We're a direct manufacturer. And we have a strong team of sales and tech support here in the U.S. that makes it very easy to do business with us. We can do same-day quoting. We have a group of FAEs or field application engineers, and we have direct salespeople that are very experienced in the PCB business. Now, we build bare boards only. We don't do assemblies. We don't do design. But we service a lot of big-name OEMs and contract manufacturers, and we have a very broad set of capabilities as displayed by some of the products on the table here.
I can see that. So,
I'll tell you quickly. So, we range from, say, double-sided through 30-plus layers. There's some examples, 34 and 36 layers here. Blind berry vias, micro vias, stacked micro vias, conductive or non-conductive filled epoxy vias, it's called, or plated or filled vias. We have examples here made with Rogers materials or hybrid materials for RF microwave applications. We have flex and rigid flex. We build both flex and rigid flex. We build aluminum backboard.
Wonderful.
Many of these for LED applications. So anything with a heat sink or some kind of a thermal management issue, we can help you. We have some different options and solutions for you.
This is great. Now, the substrates are the laminates for the thin film that's applied to these boards. Does it come in different colors, or do you apply solder mask to these?
What you see here on the surface are different colors of solder mask.
Okay, so they're
Obviously green, yes, green or blue is very common, but you have white and black for difference. So these have aluminum for the heat sink, but a thermally conductive dielectric is very thin. You can't quite see it. And then the traces, and then we apply the solder mask. So these are fairly simple. Some of these boards are very complex, though. For example, some of these boards have a copper inlay or copper heat sink that's pressed in for heat sink.
Wait a minute. I've heard of this. You press in a slug, so you'll mill out a section of the board underneath the component.
You can get it close in on that. You can see this H-shaped copper inlay, which is a heat sink that's been press fit into that board. And this board also very interesting. It's got about 20 copper T-shaped copper inlays that are pressed in for a telecom application. So not only in terms of the broad technical capability, but we accept very small orders, but also very large orders, and we do prototypes as well as production. So we try to be kind of an all-in-one solutions or one-stop shop for whether you're an OEM here in the U.S. or a country manufacturer.
Thermal dissipation now with so many of the components and all of the LEDs that are being used is huge, and I gotta say I have not done that technology in any of the designs, but I'm aware of it, and it's fascinating, and I've always thought of it as quite a cost adder. What do you think?
It is more expensive than standard. What I usually tell customers who are dealing with heat dissipation issues, copper is your best friend. Copper is not only conductive, it's already in the circuit board manufacturing process, but it has the highest thermal conductivity out there.
And it fits within the footprint. I've seen so many frustration our designers have is that we have an LED and we look at the spec sheet for thermal dissipation, and sometimes it needs 2 inches of layer 1 copper that's exposed to dissipate the proper amount of heat. Who's got that kind of real estate? But if we can put we use
thermal vias to move it vertically, and then ground planes to move it laterally.
Yeah, that's another solution.
Right, or you try to move it out the back and maybe attach this to a housing or some heat sinks.
I'm just explaining that's what the customer or the supplier data sheet says is just use 1 layer of copper and just make it up to 2 square inches. But this is far more efficient use of space for sure.
Okay, so we have 2 factories in China, one in Shenzhen, the other in Zhejiang, large campuses. Our company has about 2,600 employees, and we have also a prototype shop in Germany that services the German and European market, but also we've done some prototypes from Germany for the North American market. But anyways, we would love to partner with you. Check out our website, www.sunshinepcbgroup.com, and reach out to us. Also link with us on LinkedIn, Facebook, Twitter, and Instagram.
And you're happy to supply your capabilities, which designers must know before they start a board. We
believe it's very important to be involved with the designers early on to help them with the material selection, design rules, design guidelines, impedance, simulation, and stack-ups. So to avoid problems that will come later on. A lot of the problems I've seen later on actually comes from the design. And if you're trying to remove cost is obviously a very important factor. Oftentimes you have to start at the very, very beginning with your material selection. And the number of layers, the size of your board, the panelization. So we're here to help you to do that.
Thank you very much. It's been a pleasure learning about Sunshine Global Circuits.
Thank you.
We're walking the floor and happened upon you, and your booth is showing very nice, and your examples of fabrication are stellar. So
Thank you.
We
Again, on our
really
website,
appreciate it.
we have the names and contact information of our various sales managers. We have sales managers based in California, Arizona, Texas, and the Northeast.
Very good. Well, thank you. this has been a great aisle for information. So we're going to keep moving. We're going to go line up some more interviews, and stay with us, check back with us. And for Altium Live 2020 Connect, this is Kelly Dack, and we'll see you next segment.
As the complexity and demands of electronics continue to increase, the need to improve digital continuity throughout the entire electronics development process is more important than ever. This is the journey towards digital transformation. And while many companies are investing in technology to support this, they're encountering one major hurdle in the last mile of this journey: the inability to digitally connect ECAD to the rest of the enterprise. This means that the value chain still remains isolated and process disconnected. But with Altium Nexus, this all changes. Nexus provides a digitally integrated solution that overcomes this last mile in the journey towards digital transformation, making it not only possible, but easy. By digitally connecting your ECAD into PLM, MCAD, simulation tools, and other technologies, processes are automated, organization-wide visibility is enhanced, and resources are optimized, leading to accelerated design time, lower costs, improved quality, and most of all, a competitive advantage. Explore Altium Nexus now.
Well, gotta act fast. Sign up for the broadcast of the Altium Live 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and we'll feel alright. Digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Hi, thank you for joining us again for Altium Live 2020 right here on the Apex, IPC Apex show floor. As I mentioned in our earlier set, we had a little time to unwind. This is the unwind portion of the show floor. If you looked behind our camera, you would see lots of people being well served with libations and hydrations and a little food too. So it's quite the thing. So this is Andy Shaughnessy and Nolan Johnson. We like to get together at the end of the day and we bring out the guitars and we try and tear it up. So it's mostly enjoyed. We did have a complaint the other night at the hotel though, right? Didn't we? Yeah. So let's give this a try. We just, it's like a jam, so it's not a performance or anything, but if you'd like, join us and sit back and relax and listen to us strum. It's been a great pleasure being your host today, and we'll be back tomorrow, and lots in store, so please tune in tomorrow morning. For now, I'll sign off vocally on this mic, and we'll set it down and see if the sound will pick up. All right, let's try it. You guys come with a set list? We do. We really do. Well, here we go. Oh. Hey, shake it up, baby. Shake it up, baby. Twist and shout. Twist and shout. Come on, baby. Come on, baby. Work it on now. Work it on out. We know you twist so good. It's so good. You know you twist so fine. It's so fine. Come on.
like that.
What do we do next?
How about Margaritaville?
Oh.
That's always a fun one.
Okay.
Do it to me. Just D, yeah. D,
This
G,
might be
and
an
A.
Andy solo.
Oh, it's pretty easy. It's real easy. It's just
DG.
D, G, A.
Okay, we can do that.
First word. Oh, shit. Damn it. What is the first fucking word? What is it?
We're live. Blew out my flip top.
The first
blew
word.
Out, blew out
No,
my
no, the very
flip-flop.
first word is, shit.
Andy, we're
Oh,
live.
you recording this?
We're live. We're live.
Is this recording right now?
And recording.
Man, I
Yeah.
know-
So this happens often. You know, we
know 1,000
love to get
songs.
together and jam, but yeah, there's a phenomenon when you get together and you need to perform something or pitch something, and it's like, what do we play now?
We sing this song every weekend.
And again, this is not a performance, so we sit by and jam. Charlie Capers is right behind us. He stopped by. Charlie, what's your pleasure? Shout out a song and maybe we'll know it. Yeah.
Oh.
What do you think? Nibbling on sponge cake. It's really hard to think after a day out on the show floor. Okay, let's try this. Andy's gonna try and sing this. Here we go.
Nibbling on sponge cake, watching the sun bake. All these tourists are covered in oil. Coming my sixth string.
Hey, you are.
On my front porch swing. No, you're not. Well, the trip they were ready to boil. Was there wicked in Margaritaville? But for my sicker soul, where's the salt? Where's the salt? Where's the salt? Some people say there's a woman to blame, and I know in my own damn fault. Don't know the reason. Stayed here all season. Nothing to show but this brand new tattoo. It's a real beauty, a Mexican cutie. How they got here, I haven't a clue, no clue, y'all. Wasted wicked in Margaritaville. That's for my lost shaker of salt. Where's the salt? Where's the salt? Some people claim there's a woman to blame, but I know it's nobody's fault. I'll play a little guitar. Now goes to G. And stop. Something like that. Step down and up time. Put on my flip-flop. Put on flip-flop. Since I hear that it cruise on back home. Put this booze in the blender. Soon it will render. Taylor! Frozen y'all to hear that again. Some people say that there's a woman to blame, but I know it's my own damn fault. What's going on with time? Because that sounded good. Wasted Margaritaville. Heck for my lost chicken soul. Some people claim that there's a woman to blame, but I know it's Nolan's fault. It's Nolan's fault. We'll try it in that. Very good. Here we go. Caleb. Thank you very much. Come on over here real quick. Come on over here. We met Caleb earlier in the day. Caleb is a friend from. Oh, I've been directed to use the mic. Caleb, we've got to know. I introduced him this morning as one of the emerging engineers from a couple years back, and he's also a really good guitar player. So I might even put him on the spot here. Would you? You're going to join us, right?
Sure.
Yeah, pull up a chair, and because I like to whip out the harmonica, and I can't play both at the same time. I'm not like that.
All right.
Why don't you sit right here, and I'll go get a chair, and I'll talk to the fine folks as we do that. Woo woo. You use a pick?
Sometimes.
Okay. Andy, can you talk to the people for a minute? The fine people about
All right, we are here at the iConnect 007 booth, and got Kalen and Nolan here. We're doing the jam that we like to do, and I don't know what can we do. Let's what was I just looking up? Hold on. I was just looking up some songs.
I'm gonna come right back here behind you.
Okay. Here, you hold this.
I will. Okay, we're gonna rock the mic. What's a good harp song?
Oh, let's do.
Come on in here. Sure, let's do Last Dance. If I can think of the harp that we used.
It's an A minor, so that means it's really C. So should it be G? Should it be?
Well, let's try that. Let's put it out here. Okay. I'm gonna have to
A minor, G, D, A minor.
That's it. It's a G.
Yeah.
Okay. Let's try this.
Okay.
Oh, go ahead. Go around a couple times.
Okay.
Well, she moved down here at the age of 18. More lights sing. And we both started grooving. I said, thank you, baby, but I got to keep moving on. Gotta keep moving on. Here comes the hard part. I've been told, never slow down, never grow old. I've grown up, tired of going down. I'm tired of myself and I'm tired of this town. Oh my, oh hell yes. Had to put on that party dress. It was too low to cry when I woke up home. I hit my last number and I woke up home. That's Mary Jane. One more time to kill a pain. Well, I feel someone's creeping in and I'm high much time again. Pigeons down and mark it. Yeah, you haven't said that, right? I will. Okay. I'll play harp until I remember the last verse. Pigeons, yeah. Oh, there's pigeons down in Market Square. She's standing in her underwear, looking down from the hotel room. Nightfall will be coming soon. Oh my, oh hell yes. Gotta put on that party dress. Well, it's cold fly when I look up alone. I hit the last number again, walked up home. Last trip for Mary Jane. One more time to kill the pain. Well, I feel someone peeping in and I'm tired of this town again. There we go. Thank you. We got a little applause off of the side there. That's always satisfying. Oh, Johnny Cash. Okay, here we go. We're going to try some more of our favorite Johnny Cash. I hear that train coming, it's rolling round the bend. I didn't see the sunshine since I don't know when, but I'm stuck in cold prison. Time keeps dragging on. The train keeps on rolling on down to San Antonio. It was just a young boy, my daddy told me, son, always be a good boy, don't never play with guns. But I shot a man in Reno just to watch him die. Yeah, hear that whistle blowing, I hang my head and cry. I'll cry, little Larry. Okay, you crying. Ever since I was a young boy, I played that silver ball. So hoed down to but I ain't seen nothing like him in any amusement hall. That deaf, dumb, and blind kid shot the mean pinball. If I live here tomorrow, will you still remember me? There's a place I got to go, a place I got to be. If I stayed here with you, girl, things just wouldn't be the same. 'Cause I'm free as a bird, and as a bird you cannot change. Well, I bet those rich folks eating in that fancy dining car. They're probably drinking coffee and smoking my cigars. But I got what I had coming. I know I can't be free. But that train keeps on rolling, and that's what tortures me. Well, they freed me from this prison. That railroad train was mine. I bet I'd move it all a little farther down the line. My Folsom Prison, that's where I'd rather stay. And I'd let that lonesome whistle blow my blues away. I'll do the ending.
Nice. Nice.
Thank you very much.
Andy is a major song ender. You know, sometimes it's trouble ending a song when we jam. We're talking business. That's good. That's good. Yeah.
You're the flex guy, or no, additive. You do additive stuff? Yeah.
Here, let's tip it around here, Andy. We can keep playing. We don't have to talk business.
How about I do dead flowers, or do well, can't you see?
Can't you see? Okay.
Yeah.
What do we do that in?
D. I'm gonna go get a beer. I'm gonna get 2.
Okay.
Someone else brought us in. I'll get 3 if I can.
Okay, yeah, get as many as you can. Okay, well, this is the part where we sang a couple songs and everybody decided they need to go get refreshments, so they left me hanging, and that's okay. Yeah. So we got a little different camera angle here, I noticed. Thank you, Michael. Kind of lets us see what's on the show and people milling about. Again, there's some post-show business going on here. That's good to see. Intermingling, connecting, people having fun. But I have a feeling that Andy's going to be a while. Well, he's in line, and I don't know if we want to eat up all your airtime. What time is it, Michael? Yeah, it's about that time. So, you know, why don't we hopefully your ears aren't bleeding yet. We're going to do this again most likely tomorrow night. We'll be back, maybe even spontaneously, and we'll be meeting a lot of suppliers, a lot of vendors here on the show floor as we've done all day today. And it's just been an absolute pleasure. So we hope to see you again tomorrow. Please tune in, especially for our main event kickoff, AltiumLive Connect 2022. And we will kick this thing off and just have a great time with all the presenters and keynote speakers. There's lots in store. So please join us back here, and we'll sign off for the evening. Good night.
And to any customers out there that are not using this, I couldn't imagine not using these features. It would be very difficult to go back. Let's put it that way. So. I'm Jeremy Waller. I'm the Senior Electrical Engineer at Quantel Laser in Bozeman, Montana. and that's part of a global company called Lumibird, and we have many design centers around the world. There's 18 mechanical engineers, about 22 electrical engineers in Lumibird that are part of the Altium 365 environment. It's pretty easy with Altium 365 to expand our environment. So we research, develop, and manufacture solid-state laser systems for medical and scientific defense-related industries. Yeah, I mean, our mantra, I guess, would be we're rugged, reliable laser systems.
I'm Lane McNeil, the Senior Mechanical Engineer at Quantel USA. This is one of our newest, and it's a fairly high power, high rep rate laser system. So it operates with diode powered input, but it's water cooled. But the circuit board components of it, when we got going, we have some covers here that we put together, and they're kind of interesting. We have a number of circuit boards that sit inside the system. There are some fairly high power diode drivers that we use, coupled with some control electronics, and then we have some other electronics that are used for regulation of nonlinear crystals that we use to convert the laser output to different colors. Before we were using CoDesigner, basically we would get a DXF file is what we would receive. We would then take the components and we'd have to go ask them, okay, how tall are these? How tall are these components? And then we'd have to extrude the materials up to get an idea, because we have some very tight fit applications that are going on. So
a collaboration tool like CoDesigner just really allows us to transfer back and forth easily. Not only does it help us design the space, but it makes for better assembly drawings so that people can build and manufacture this, so I mean it changes a lot of the picture here.
It's an amazing step forward now to be able to have all the exact physical geometry completely understood and known. Being able to see that allows us to prevent problems that we were having in the past. We have an example here of one of our lasers that was a collaborative process using Altium CoDesigner and SolidWorks.
Having the collaboration tool like CoDesigner in there helped us with this board in this particular design. How did we get to this board, I guess, is a good example to go through. This is how it starts a project usually. I mean, you just have a rat's nest of components and in this case, we'll just pull a few of the important ones that we need to find location on right away. Because I need to get Lane involved and give me a board shape that fits in the space, show me where the mounting holes are, and we just got to establish an area where we can do components. So I'm just going to push it over to him for the first time so that Lane can receive it on his end, and he's going to do all the work for me, thankfully. It takes all the risk out of the process.
Did you get that pushed, Jeremy?
Yeah, it's got it pushed over to your direction, so I've got it in there. You can switch over to your screen.
Okay, so I'm pulling it in here. Right, this. So basically one of the first things that comes in with these is gives us the opportunity to come in here and define the physical size and shape of the component. So that is the physical size of the circuit board that we wanted to work with. And then basically what we're able to do, I can position the component So with that kind of placement, then I'm able to come in and add cutouts to the circuit board. But one of the things that we often do is we will go in and add a feature on the board that's going to define all the keep outs. So I'm just going to define a new part at the moment that I will define as the keep out zone.
These are the features that are difficult. They're pretty obscure, random shapes and everything. The thing is, this usually is a lot of back and forth, but since this is a board that we've already went through this process, what you're getting to see is like, weeks worth of back and forth and arguing over shapes and space.
But it's going to have a lot of this information is going to show up in one shot and be pretty well done so that Jeremy would be ready to work with it as soon as we're complete with this. Okay, so I just pushed it at this point. So what you're going to see is Jeremy will now have the opportunity to pull the system into Altium when the push is done. It's still in the process of collecting. There, it's done.
It's already there. All right, so it is fast. I mean, this is great. You know, I would comment too, even when designs are pushed and updated overseas, our server's not even in this part of the country. So it's been really a good performing product. But I want to view the changes, see what Lane did on occasion too. So it's going to give me a list of the preview of what he did. So if I like everything that I see, I can just hit apply and it's going to pull everything in there. Okay, so here you go. Here's all the changes he made. It's got everything I need to get started for the most part.
It would be impossible for a single individual focused on designing electrical circuits to be able to also at the same time envision all the detailed mechanics, because they don't have access to that information. And so this allows the mechanical engineer to effectively assist the electrical engineer in basically properly positioning things to achieve the most compact or the most reliable connection without a bunch of iterative problem solving and back and forth mistakes and fixing. I understand his challenges, he understands mine, and we work together to come up with a solution that works for both of us. And this is the thing that didn't happen in the past nearly as easily.
We're more competitive in the market now because we're able to get smaller. So now we're taking advantage of better PCB design technologies like micro vias and varied vias, and getting our circuit boards smaller and smaller. And at the same time, the space that we're working with in Lane's world is getting tighter and tighter. So it is definitely added to the quality and performance of our laser systems. And so it's worth every bit of time invested in learning the tools to allow you to provide those better products for your customers.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip, we're in partnership with the folks from the IPC. Stakeholders unite and feel alright, digging multi-show synergy. So let's all connect, come on people, let's reflect on the meaning of digital transcendence. Catch it how design and manufacturing combine, check us out, virtual attendance, yeah. Hi, Kelly Dack here, back on the IPC Apex Expo show floor for AltiumLive 2022, Altium Connect. And today, or this afternoon now, for getting down to a few of our last segments, we've ended up at the ITW EAE show floor area. You got quite a bit of real estate here. I'm with Greg Husty. Yes. We just spoke about that being a German last name. He's a strong German last name. Thanks for having us. Thanks for allowing us to come into your area and check out some of this equipment here. We have talked about solder, but in solid form, and we've talked about pastes and things. But the solid form solders are going to feed your machinery, I have a feeling, and take the boards through the process. Why don't you tell us about what's going on here?
Okay. Well, in a wave solder machine, we start the process out going through a fluxer to apply flux. Yep, we can go over here. So we apply flux to the bottom of the board. The flux's job is to prepare the copper on the barrels and leads. remove oxides so the solder will wet to the copper. So we start out by fluxing. Of course, we have a conveyor that'll convey the board through each one of our modules, starting with the fluxer module. Board gets fluxed, then it goes through preheat.
Now, let me pause just for a second. For fluxing, there's been a lot of coverage of fluxing. It's done in several ways and several forms. Can you explain how the fluxing process happens here? Is it
Yes.
Are there vapor fluxes, and is there solid fluxes and liquid fluxes?
Well, we're using a liquid flux, and we're spraying it. So the most common method of getting it to the board in wave soldering today is spraying. So we're gonna spray. We spray the flux as the board's traveling. We traverse the spray nozzle perpendicular to the board travel, and it sprays as the board travels over it until the entire surface of the board is covered with flux. And then we also have to make sure when we spray it that the flux actually penetrates through the barrels to the top, so it covers all the copper surfaces, so then solder will wet to from the bottom to the top.
Yeah, because copper oxidizes, and
Correct.
the idea is we have to deal with that. And the flux
Yes,
deals with that.
yes. For solder to wet to the copper, we have to remove the oxides.
Yeah, let's move down. Can we move through here without disrupting?
So then we have to activate the flux to chemically activate it to get it to remove the oxides. So we do that with the preheat. So we have to create a thermal profile to ensure that we get the flux to the proper temperatures that the flux manufacturers specify. And there's a certain temperature it has to get to, so a minimum temperature and a maximum temperature.
And these are external to the board. These are external temperatures, right? Because obviously
Correct.
inside
Well,
the board,
right.
it's not being fluxed or soldered.
So the industry standard is we're going to measure that as the topside board temperature prior to getting into the wave. So we have to get it to a specified topside board temperature prior to the wave at a certain heating ramp rate, not to exceed 2 degrees C per second typically.
And we see the machines are movable. This angle is adjustable.
It is adjustable. It is adjustable, but we design our process at a 6-degree angle. That gives us the optimum soldering results in our equipment, but we do offer it that we can change it from 5 to 7. So depending on the process, you may be able to fine tune it. Maybe at a 5-degree angle may give you slightly better results, but typically what I've seen is 6 degrees is what majority of our customers run their conveyor at.
Let's see what's the next step in the process here. Where does it move on to? We've got a nice diagram.
Yep. So after we preheat, these are our preheat modules. So that's activating the flux and thermally conditioning the board. Then it'll go into the solder waves. And I can, so the graphic, when it's on, it'll show the solder wave actually pumping. So let me turn that on for you so you can see that. Okay. So as the board travels, it goes to the preheat, and then it's going to go across the wave and apply molten solder to the bottom of the board. And then wherever the copper is exposed is where the solder will wet. And so we apply it from the bottom, and then through capillary action, it's going to wet up the barrel, up the lead, and then create the fillet on the top. That's what we call capillary action or wicking.
Right. So as far as design is concerned, it's very important for designers who are dealing with through-hole components to understand this, understand that there must be enough room in the maximum material condition size of that hole and the maximum material condition size of the lead to still allow room for that capillary action for the solder to flow up. And are you trying to form, well, the IPC standards or specifications are the ones that dictate what the solder joint should look like on the bottom and how the solder is viewed on the top. It doesn't necessarily have to be a perfect fillet on top.
Right. So especially with lead free, we're looking at hole fill, percentage of that barrel filled, and depending on the class of soldering, class 2, I think it's 75% on the ground pins, 100% on the signal pins. Class 3 is 100% on both.
There must be challenges. Some designs might be challenges. What if you have a heavy copper board that has thin copper on the outers for etchability, but they're carrying power, and which could connect to things that are going to sink the heat out. Explain what you do for that. Is this profiled? Is the term profiled, heat profile, used in wave solder?
Yes. Yes, it is. So you can. So you have to make sure you heat to the maximum that the flux will survive, the maximum specs, and then the rest of the heat you need to get the inner copper planes hot. You have to do with contact and the solder, and we call that, the contact time or the dwell time, and that helps transfer the heat by induction into the copper, so then the solder will wet. So in design, it's very important in those inner planes that you create thermal relief on how the barrels are tied to those copper planes. You don't want a solid connect on all those planes, or you can't get it soldered to come to the top.
You heard it. This is kind of a. Sometimes we think of it as diametrically opposed. This is where design for manufacturability and design for performance, electrical performance, they seem to butt heads. A lot of the design engineers, PCB layout folks, they're directed to make these direct connections for performance reasons, but they also need to understand that a board that could electrically perform well, in order for it to perform at all, has to have a viable solder joint, right? So listen to the stakeholders. If there's a way to be able to add thermal relief, especially in the inner layers, and still carry your current, we need to make every effort to do that, right?
Correct.
Because nothing's worse than a cold solder joint. You've gone through your whole process, and a rework is required, which stresses the board even more.
Or may not even be able to be reworked because the component itself restricts access to add more solder to get it to the top.
So your customers are typically EMS providers, right? People building these boards, and so would a designer probably be better to contact the EMS provider than you directly as far as design considerations, because they're in the driver's seat at that point once they have your machinery. Is that true?
That's correct. So they're the process engineers at the EMS companies would be the people to get with, especially the NPI process.
So do you have any live solder flowing here today, or probably?
We don't have live solder flowing, but we do have a video showing live.
Let's walk around there real quick, because that's actually what caught my eye. This is there's a beauty to molten solder for some reason. It's very dangerous, very hot, but at the same time, I think the action and what it does, what it ends up doing is beautiful. Watch that.
A circuit board is going through the main wave, and this is a soldering process right here. So this is actually a test board where we're testing soldering results for topside hole fill with heavy copper challenges.
This first wave was they call it like a disruptive wave. It kind of jostles
turbulent wave. Yes.
Turbulent wave.
Yes.
Heats it up.
Yeah, you get the initial heat in with the first wave, and then you finish up the soldering with the second wave. It'll give you the nice fillet on the bottom of the board with the smooth wave. First wave's job is to get the initial heat into the board.
Now, what's going on right here? Looks like things are overflowing. We've got a problem.
Well, and it's self-adjusting. So the option that we're showing here at the show is an automatic adjustable exit wing.
So was that showing a problem and that it mitigated?
Yes. Well, it's showing how to optimally set up the wave and repeatability.
I see.
So that's what this option does for you. It gives you the repeatability and the setup of the wave.
This has been fascinating. This is the machine. This is what's available today from your company. We really appreciate your time that you've taken to explain this. It's our first dive into wet process, or this wouldn't be considered wet process because it goes solid real fast. But for the soldering, the wave soldering process, we really appreciate it. I'll give you an elbow bump, Greg. With me has been Greg Hust, right? Good, thank you. And we'll keep moving on. I think they have some refreshments on the floor. Are we going to see you out there? It's about time, huh? Okay, we'll see you. Thank you so much. Hey, this is coming to some of our favorite parts of the day. I mean, it's fun to walk around and learn, but another, our theme is Connect. And something they do here to connect people is there's nothing like a little food and relaxation after a hard day on the show floor. So let's go this way. They don't start until a certain time, and I think that the magic time is 5 o'clock. So let's go ask them. See, I'm the guy that loves to ask questions. I'll talk to the bartenders. Woo! Knock knock. Hi. What time are you serving, Lewis?
Yes, sir. We're serving in 5 more minutes, sir. Okay. 5 more minutes, and we'll all you can drink in 1 hour, from 5 to 6.
Okay, this is wonderful and provided by the show floor. And you know what we plan on, if all goes well, we have some guitar action going on here. We got some friends that like to play, and that's not going to be a problem for you, is it?
No. Do they like tequila?
Are you serving?
Yes, tequila.
Look at this. I had no idea. I thought it was just beer and soda. But and we also have lots of water. Push your water.
Oh yeah.
For hydration.
Yes, you're gonna be right on top of the bar. For whoever wants to drink little water.
Lewis, we'll be back.
Yes.
We'll name drop. We'll
Please.
say we talked to Lewis. Thanks so much for being here and for all you do. Great. This is very good. Always exciting. I tell you what, so we don't take up your valuable time, let's dart out. Let's end this segment for the time being. We're going to go get with Andy and Nolan, and we'll pull the guitars out. And that's traditionally what we do at the end of the day here, is pull the guitars out, do a little singing and campfire type blues, and just have some fun and unwind. So please join us for that if you can. And until then, we'll see you tomorrow for the first day of AltiumLive Connect 2022. We'll be meeting with all of the Altium management and the people who are going to guide us through what to expect for the show, and all the speakers. And I'll still be on the sidelines here with the live show we'll be covering all week. So really hope you can join us for the next hour or so, or half hour or so, and that you've enjoyed the day. Really appreciated being your host today. We'll see you tomorrow.
Altium 365 lets you hold the fastest design reviews ever. Share your designs from anywhere and with anyone with a single click. It's easy. Leave a comment tagging your teammate, and they'll instantly receive an email with a link to the design. Anyone you invite can open the design using a web browser. Using the browser interface, you're able to comment, markup, cross-probe, inspect, and more. Comments are attached directly to the project, making them viewable within Altium Designer, as well as through the browser interface. Give it a try and get started with Altium 365 today.
gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and feel alright. Digging most shows synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Hi, we're back live on the IPC Apex show floor. It's in the afternoon now, and we still have quite a buzz on the floor. I'm Kelly Dack, and with me is Ralph Jacobo from All4PCB, and our idea is to bring you along with onto the show floor and meet people like Ralph who are excited to tell you about their company and what they offer as far as materials and some processes. So, Ralph, tell us about it.
So for PCBs, we supply a lot of equipment and materials for the PCB manufacturing process. One of our key products is going to be ViaFill, which is the Tatsuda material and the Sonite paste. And these are primarily used for many applications for building high density type of boards in general.
Tell us about the types of ViaFill. Designers need to know that for thermal transfer, there's a type of ViaFill for thermal transfer that conducts heat through the boards and takes it to the other side. And then there are other fills for different purposes. Tell us about those.
So we have traditionally the non-conductive is basically for via and pad technology. This is to save real estate on your designs, basically taking up less real estate. But you have to then fill these vias with the non-conductive material for a cost-effective use.
So vias or even pads or lands that make contact with component connections or component pins or contacts need solder on the top to make the weld between the two. And if there's a via hole, a hole through the board, where does the solder go? It goes through the board. So the solution is conductive or is ViaFill.
ViaFill, right? The non-conductive ViaFill kind of creates a structural, very stable structure. So when you have a very flat surface, you want to have a very flat surface when you're loading a component. So your solder, you don't have any tombstoning or any kind of a problematic with SMT assembly. So having a very flat structure is important. So that's where the ViaFill material is used to fill and create a very flat structure. And that's primarily with the non-conductive, and then the conductive material would be for creating a thermal, basically a thermal heat transfer of keeping the BGAs or the component a little bit cooler. So it works as a heat dissipation for that.
So the material is squeegeed in a liquid form or a paste form, and then processed. What's the next process? Are we capping it with copper and plating it so that we get a really flat coplanar surface?
Yeah, so there's a few applications that require equipment to actually fill, to have a proper fill. You want to be able to fill with this material that is basically it's a very viscous material. So you need equipment to fill it. You want to make sure that it's filled with no air gaps in between, no air bubbles. And then you cure the material. You actually then cure the material so it hardens, and then you have to really wipe it off or clean off the excess of that paste of the material, and then you do a plating after. So then when you do your final finish, it creates a nice flat, uniform surface finish.
What would you say designers are expected to know what type of material to use when they specify ViaFill, or will designers hang their hat on a IPC spec that says ViaFill per? How much do designers need to know? Because there are so many different types of ViaFill in each class. Tell us about that.
Yeah, there's primarily, just a few suppliers of this of the non-conductive ViaFill, and primarily they are called out with their IPC approved materials. So there's a limited amount of materials that are certified. And, mainly when they're called out, it's either going to be a non-conductive or a conductive fill application that is needed by the designers. The designers will decide that. And based off of that information, I mean, we do have certain specifications depending on the materials that they're using. We want to have very good materials that match CTEs and so on. And that those properties will consist with the different variations of the materials that we have available. So there are different variations within those.
Some of our audience are emerging engineers, new to the industry, and we tend to use a lot of acronyms in this industry. So when you mention CTE, coefficient of thermal expansion, which means some of the materials don't expand at the same rate as other materials, and it's very important. I think Ralph will attest that it's so important to find a similar material coefficient of thermal expansion so that you don't get thermal mismatch. Correct. Which causes what?
Which could cause expansion, which will cause cracks within the plating itself or the barrel of the hole itself. So you want to minimize as much z-axis movement to keep the structural very, very, let's say, consistent throughout the barrel of the plating of the via itself. So that's what drives the connection from top to bottom. So any crack, any deviation will cause a crack in there, which can cause basically opens or misconnection between the top to the bottom.
Very, very good. Very bad issue. What else have you got here? You've got a lot on display. What can you tell us about?
As I mentioned, I mean, all 4PCB has a lot of processing equipment from A to Z for manufacturing of PCBs. We have lamination consumables here, which basically are materials that are used for the lamination process. So as you take a multi-layer and you basically do your lamination process, there's materials here that are used as lamination aids. So you basically put those in between the materials to get a very conform, uniform lamination press, so preventing delamination and so on. So within the process. So
any of our designers who have discussed laminates with the suppliers or fabrication suppliers know that we refer to them often as pre-preg, but they come in all different sorts and flavors. And you've got a few down here. That one caught my eye, called a high temp cushion. Tell us about can we see that? Can you pull that out? This is the good stuff here. So what's a high temp cushion and how can that relate to, does that fit within the stack up?
Yes, so this fits within the stack up. So generally FR4 material, which is a base laminate material for PCBs, have a certain lamination temperature that is required to cure the pre-preg and do the lamination process. With some of the new materials, PFTs and so on, there's some hybrid materials that require a higher lamination temperature. And those higher lamination temperatures, you require basically some kind of an interface there so you can get a proper lamination without damaging your product and so on. So withstanding the product temperature during that lamination cycle is important. So some of these materials, we have different variations for flex, for basically.
Well, this is so thick and it's almost a fabric-like feel to it. Does it get impregnated with resins and in the heat and stack-up process?
In some cases, if you have, you can have some resin that goes on there. So we actually have other materials as well that are kind of, we have some release films that would go on the surface of that, so protect it from having any resin flow on there. So again, ideally, this would be kind of a high temperature release film as well that can go, basically in the stack up of the material. So if the combination of both will provide a good, excellent seal against it, protection of the temperature, and then this will protect against any resin flowing onto the surface of that.
Is this material considered for more exotic applications? This is not your basic FR4 stack-up. So is it common in aerospace products and class 3 type products out there?
Yeah, so class 3 products, a lot of, basically newer technologies that are requiring these hybrid laminates, high-speed laminate materials that may require higher temperatures than your normal FR4 materials, yes.
Like I say, I'll say it and I'll say it again, that I just love coming to these shows because this is something new. I have never experienced this material yet. I don't plan on designing any space flight boards in the near future, but that's okay. I do okay. But now I know who to call. and I'm in touch, and we've connected. And I'm so appreciative for that. Ralph, with me has been Ralph Jacobo with All for One PCB. Give him a call, look him up online, and ask questions. We really appreciate it. So we're going to move on, and we're gonna keep walking the show floor.
Sounds good. Have a great show.
Thanks for having us. Best to you. Let's go this way. Let's see what we can do. What kind of trouble we can get into now. You know, another thing with these shows, a lot of the suppliers, the vendors, you know, they have gimmies. They have candy jars everywhere. I'm trying to stay away from those, but they also have, you know, squishy balls and yo-yos and pens and scales or rulers that are quite handy. In fact, let's go check out one right here. Whoop. How about a deck of cards? You know, everybody needs a deck of cards. I'll take them, thanks. Yeah, we love the show floors. We love the gimmies. It's good to bring things home to the family. But since we've taken, let's go back and talk, see if we can talk to some of the notables here. We had one earlier. Let's see if he's still available. Come on. Ooh. We don't usually do it like this, but we made contact, and we both said, oh yeah, maybe we'll see each other in about 10 minutes. So let's give this a try, okay? Knock, knock. This is the awkward pause, because I don't know if they're with customers or not, and we certainly don't want to interrupt them if they're with customers. Let's try something else. Let's go back to the, have we hit up the Tayo guys yet? Let's see if we can. We're waiting for somebody to be available to talk tech with us. So let's try that. Ooh. I'm so tempted to just go in, and these guys look like they needed love. So I was tempted to just go say, hey, do you want to talk circuit boards? But we never do that live. We don't want to catch anybody off guard. Let's try Tayo. You know, sometimes they learn we're coming and they flee. I get the feeling. Let's see what happens. Wow. This is some really cool equipment. They've got equipment here. Tayo is a really unique company from the standpoint of adopting and adapting to your needs, whatever your needs are. They have a bunch of chemists there and R&D people. Let me go see if I can wrestle one up. Come on. Hi. Do you have anybody that can talk to us yet? Oh, Don. He vacated. Hi, Don. Okay. Well, we've got viewers, and you wouldn't mind talking to us just in general about Tayo, an overview, like where are you located?
Tayo America's in Carson City, Nevada.
Right up the street from where or down the street from where I used to live. Fascinating facility, and I got to mention that, you know, this is why we want to come over. We really want to talk tech with you guys, and because you formulate materials for just about any application. And I can share a quick story that we had an application to create some solder mask, but it had to be a solder mask with a grit in it. Who's ever used solder mask with a grit in it, and how would you apply it? These guys solved it for us and solved our customers' issues, so or the challenge. So we really want to connect base, but we don't want to put you on any spots. And who are we meeting up with?
Jesse Session, who is our R&D manager. Okay. He's also involved in operations day to day.
Okay. Well, we'll move along, and until we can meet up with Jesse, we'll come back. Perfect. Okay. You know, sometimes it happens that way. We're live. So I think what we'll do is let's sign off for the time being, and we'll come back in a half hour or so. Please join us again. I'm Kelly Dack for AltiumLive Connect 2022.
Hey man, you gotta come check this out.
I'll be right there.
Take a look at this.
Whoa. This is going to change everything.
Invite Alex. Hey, are you seeing this?
Whoa. This really did change everything.
Well, gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and feel alright. Digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah. Hi, Kelly Dack, back to you on the show floor of the IPC Apex Expo for AltiumLive Connect 2022. Glad to be back with you. We've had a chance to stroll around and we found something that we think you'll find is interesting. This company, Hitachi Inspire the Next. What's your company name, by the way?
Hitachi High Tech.
Okay, I knew it was Hitachi, but the moniker or the your logo. Okay. Caught me off guard. This is live, you know. So yeah, we've already talked a little bit, and Vicky and Marianne have agreed to explain what their company does, what their machinery does, and it's very important from an inspection standpoint for metals. Who should I start with?
Yeah. Oh, we'll start yeah, easy. Yeah, so we manufacture XRF tools so that we can help with the quality control part of the process. So once you have designed your boards and manufactured the boards, and you want to make sure that your ENIG application or your NEPIG application are within spec, you could use something like an XRF tool to ID and quantify your coating thickness.
Gone are the days where you don't ever cross-section boards to find the thickness, these micro thicknesses.
That's a waste of material. Yeah, we're trying not to do that. So this is a totally non-destructive analysis. Yeah.
We have the benchtop models that can do, like the benchtop models that can do like the wafers or like small nanometer like spot sizes and really thin thicknesses.
So and then for our designers who need to be in touch with our inspection personnel, maybe it helps them out to understand some of the equipment they'll probably be using. Explain the equipment, explain the process.
Yeah, so something like if you're designing semiconductors, you could use something like an insert here, which is the FT160. So I can explain XRF a little bit first. So with XRF, basically, we are using X-rays to fluoresce atoms in your sample. So if you go back to your chemistry class, when atoms get excited, they go to the excited state, the electrons, go to the next shell, and when it comes back down to the ground state, it lets off photons. And that's what we analyze. And just by understanding where the peaks are, we can then correlate that to a concentration. So we could do anything from coating and plating thicknesses to like material analysis. So an instrument like this, I could, see that there's a piece of aluminum right here, and I have no idea what the.
Let's press buttons and try.
Yeah, we have no idea
wonderful.
what the alloy might be. So all I need to do is, put the instrument right up to it like that, pull the trigger, and, give it a couple seconds. So all these lights are flashing. It shows that the X-rays are on. And once it's done, it will beep, and we have concentration. So we have our alloy grade up top and a breakdown at the bottom of all of the alloys.
That's amazing technology and probably very useful. Oh, your pens. Very useful. I can imagine that not only the circuit board industry, but what the jewelry industry or anybody else.
I love analyzing people's jewelry. I could tell you exactly how much.
Did you get ripped off or got what you paid for?
Exactly. Is that really 24 karat gold? I could tell you. Or is it just plated gold? Yeah.
Well, those are the same questions that our inspection personnel, verification personnel in an EMS company are asking. Vicki, tell us more.
Well, that one too is like an alloy sorter. So, if you're like sorter, I mean, that's kind of what the thing was there for recycling, or even I've walked around the show and seen that, there's machinists that make special rigs for the boards and stuff, and they want to make sure they have the correct metal so it can do that. And then, these are more like in the labs, or like even on the control floor to make sure they're, quality check right there on the line. They're all super easy to use. It's not like you need a rocket scientist. So basically you put the part in and you press analyze. It's just as easy as that machine. So yeah. Yeah. So.
Another thing that could be critical is making sure you're ROS compliant. So making sure you don't have a lot of lead in your material. So that comes up a lot with, toys. It comes up with circuit boards, making sure you don't have lead solder. All of that.
And some metals are prohibited, and if their corners cut or a supplier uses the wrong types of materials, we need to know that, and we can't know it just by the surface, right?
And I can't tell you how many times I've gone to a customer and they give me a sample and say, yeah, I'm pretty sure it's gold, nickel over copper, and I can tell you, well, they're missing a layer here, and I could tell you just by trying to run it. Or maybe it's something completely different and they don't even know. Yeah.
Very interesting. Any more to share?
We have the gauge analyzers too for thicker coatings.
Gauge analyzers.
Oh, we can't miss the gauge analyzers.
I know they're not exact.
Because thick coatings on certain metals are really acceptable. But I'm thinking copper for current carrying.
Yes.
But most of these metals we've spoken of so far are protective types of metals, right? Yeah.
We also have a series of analyzers. That we don't have here, but they're thermal analysis analyzers. So they could analyze phthalates. They could do mechanical testing if you're designing a mechanical system. You could do mechanical thermal testing. So if you need information about your specific gravity, that kind of stuff, it will generate a really neat graph to do that.
Well, this has been delightful. I'm sure our audience likes it, and it piques interest. Our audience can contact Hitachi and find out more. You've got lots of literature here. This is a great thing coming to the show floor. You can pick up literature and generate tons of questions that you can call the experts and find out more. So thank you very much. Vicki Lucky and Marianne Walters, thank you. It's great to meet you, and I hope you're having a great show. Yeah, thank you very much. Hey, we'll cut it off for a second here. Take a little break for AltiumLive Connect 2022. I'm Kelly Dack out on the show floor.
We've got to get less wasteful, we've got to get better at what we're doing, we've got to be just generally more effective as an industry and kind of leading the way.
Everything that we've been talking about is based on improving the practice of engineering. But now we are bringing the business of engineering onto the platform.
When you talk to a factory operators, they want to run their factory at about 90% utilization.
And what do they actually run at that mission?
62.
The process through which I communicate manufacturing information and intent to a PCB manufacturer has not kept pace with the tools that I have for designing PCBs. Altium Designer, which is the primary tool I use for designing PCBs, the capabilities of that tool have grown immensely, and yet the process through which I ultimately develop a release package and get it to a manufacturer has been completely static through that entire time.
So what we end up with now is really a supply chain that's very brittle and reliant on offshore manufacturing and mostly offline, right? So it's a very difficult environment to be truly responsive and agile when you're trying to build new product and innovate.
By far, the biggest obstacle that I frequently encounter in getting boards done correctly and quickly comes down to communication.
When we send something to manufacturing today, what's the very first thing we do? We create a package of data, and that package of data is not in the original format in which we created it, and it gets translated into a standard, and there's always something that's lost in that translation.
I'm able to generate all this detailed design information, but then ultimately it still just gets distilled into this like 40-year-old format that I send over the fence into a black hole generally. There's a lot of lack of transparency in this process that has enormous room for improvement.
There's been a lot of talk in the industry about creating a digital thread, the link between the design and the manufacturing. With Altium, they've been focused for years on digitizing the design, creating more capabilities to capture more about the design. At Macrofab, we've been focused for years on digitizing the manufacturing side of the business. So what we're now doing today is connecting those two.
I've released this design up to the Altium 365 cloud. And this is a board that we use in our factory to do some simple motor control for some assembly steps. But now I'm going to go ahead and send it over to Altimade to get fabricated.
With Altimade, the designer is going to be able to sit there right in the Altium design tool. And as they're working, the Altimade tool will contact the Macrofab platform and update pricing in real time as they make changes to their design. That means the designer, through Altimade, will get real-time feedback on the true cost to produce their design and any issues with it that might impact manufacturing or supply chain.
We are okay with the price, so at this point it's basically just as easily as saying, here's my credit card, make these boards. I'm really excited about changes in the manufacturing pipeline that will allow me to capture the far more nuanced and detailed design documentation that I already make in Altium Designer and get it to my fabricators and be able to close the loop on that.
People just expect things to work for them with the minimal amount of investment, from a learning curve perspective, this kind of stuff. I think people expect this from engineering software today. Why should it be any different? They want good user experiences. They want to be able to put in the minimal to get the maximum out. They want to spend their time being creative, doing the things that matter, not jumping hoops through a system.
By having that digital thread of connectivity all the way back to the designer, we've seen products go to market in as fast as 60 days that would have taken 6 months previously.
Sometimes I just have an idea, I want to see it realized in reality, I want to make it happen as quickly as possible. Altimade has been the most efficient way to make that happen quickly and to get prototypes in my hands.
Gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and feel alright, digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out, virtual attendance, yeah.
Hi, Kelly Dack, back with you live on the IPC Apex show floor for Altium Live Connect 2022. Hope you all had a good time. You're having a great time at the events, and our job now is to. I think first I need to do a little housekeeping and announce some things coming up. At 1 p.m. that I'll remind you about just a little later. 1 p.m. we got David Haboud, Altium Designer Best Practices Part 2. And then also we've got on another stage, we've got Vincent Mazur, Avoiding supply chain issues. It's on the Design Challenge stage. So I tell you what, let's stroll down the aisles as we commonly do now. And I want to introduce you to Data.io and Jennifer Higgins from Data.io. Thanks for letting us stop by and learn about your products and processes.
You're welcome. We're glad to have you here with us today.
Yeah, well, tell us, Jennifer, what Data.io is for our designer and our audience out there at Altium Live.
All right. Well, so Data.io we're celebrating our 50th anniversary this year in the industry. Congratulations. So that's a huge milestone for us, but we are the global leader in device programming and security provisioning solutions. So we pre-program semiconductor devices, flash, micro, NOR, FPGA, and we can also securely provision those in our systems for secure manufacturing. And we have this suite of software solutions.
Yeah, so how does it work? Can you take us through the process?
Sure. So let's step over here.
I like field trips. This is wonderful.
This is our PSV 7000. It's doing automated device programming. This is a typical configuration for our automotive manufacturers. It's designed to program very large file sizes. You're talking 6,400 gigabytes of data in the manufacturing process. So this is done outside of the line, so it doesn't bottleneck your production line. But it's picking devices from our tray, putting them into a socket in the programmer, and that's where it'll program the firmware, data files. If it's a security provisioning job, say they want to put keys and certificates or enable secure boot, any of those processes are done in these programmers. Once it's done, customers have the option to go back and have it go over our 3D coplanary vision system, so you can make sure the balls are within tolerances, or if there's leads, that you don't have any bent leads and they fall within the coplanarity. So only high quality program parts are put into the output, and that could be tray or it could be tape.
So this pre-preps, and then they go off to the manufacturer, the EMS supplier, who is going to attach them to the boards, correct?
Yeah, so you can take the trays or the reels of pre-programmed devices, put them right onto the manufacturing line. And so when you talk about security provisioning and securing the supply chain, putting those secrets in at the very beginning of the manufacturing process is very critical.
Tell us why.
Well, because the longer it goes without locking those devices or putting your keys, certificates, authenticating that this is a real device and not a knockoff device, right? So we can do that at the very beginning, so you know that our devices are programmed properly, they're locked, it's an authenticated microchip device.
And a buzz, the word I've learned is traceability.
Traceability. So we have a traceability software suite where it tracks what's programmed, the algorithm that was used, the very specific device. I mean, you could get granular all the way down to that keys, certificates, So there's full traceability. Our automotive customers love that. And it's very important to their process.
Now, will your machines typically go to another service that does this? You'll sell your machines to a service that does this for an EMS supplier, or will this be taken on as capital for an EMS provider?
Great question. So there's a number of different customers or applications that will use this. So there's OEMs who want to control everything in their own factory. They'll purchase that. So Continentals, Bosches of the world, right? They like to do all of the manufacturing inside their own facilities. We also have our systems in a Jabil, so EMS and CMS companies. Also programming centers. So some customers are low volume, but they still need the high quality programming or the security provisioning to happen. And so programming centers have our machines so they could do those small lot devices and customers get that same quality, reliability, and traceability done at the programming center.
So I'm envisioning a programming center set up in a tech park area and a small business that is a programming center that uses your machinery and provides the service. Do I have that right?
You have that right. There's small ones like that, and there's also larger ones like Arrow and Avnet. So these smaller customers can purchase their devices from Arrow and Avnet and add on value-added services like device programming and security provisioning.
Oh, wonderful. Is there a rest of the story?
Well, I think the final piece of the story, besides the security provisioning, which we have an integrated HSM to cryptographically provision those secrets, we also have a software suite called CONNECT, and I can take you over here.
We like walking. That's good.
But another big important part of the process, and this falls in line with the traceability, is MES integration. So integrating your machine into the factory environment and getting that traceability and the data out. So we have our CONNECT software that will enable our systems to connect to an MES and then send and receive data, events, and enable the connected factory.
Excellent. Very good overview. Thanks very much for your time. And I'm sure our audience thanks you. With me has been Jennifer Higgins with Data.io. And I'm Kelly Dack. And I think what we'll do is we'll just walk out. And I think we have an announcement or two to make. So thank you very much. Welcome. You guys are great. Thank you. Yeah. We keep going on the show floor here, and we can keep going and going and going. Right now, I want to remind you about the 1 p.m., if you haven't tuned in already, the 1 p.m. Altium Designer Best Practices Part 2 with David Havoud, and also on another stage, Avoiding Supply Chain Issues with Vincent Mazur. It's over on the Design Challenge stage. So for AltiumLive, Connect 2022, Kelly Dack out here on the show floor, and we'll see you soon again.
As the complexity and demands of electronics continue to increase, the need to improve digital continuity throughout the entire electronics development process is more important than ever. This is the journey towards digital transformation. And while many companies are investing in technology to support this, they're encountering one major hurdle in the last mile of this journey: the inability to digitally connect ECAD to the rest of the enterprise. This means that the value chain still remains isolated and process disconnected. But with Altium Nexus, this all changes. Nexus provides a digitally integrated solution that overcomes this last mile in the journey towards digital transformation, making it not only possible, but easy. By digitally connecting your ECAD into PLM, MCAD, simulation tools, and other technologies, processes are automated, organization-wide visibility is enhanced, and resources are optimized, leading to accelerated design time, lower costs, improved quality, and most of all, a competitive advantage. Explore Altium Nexus now.
Gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and feel alright, digging most show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out, virtual attendance. Yeah. Hi, Kelly Dack here, live on the IPC Apex show floor. Hey, we've been traveling around. We've got AltiumLive Connect 2022 going on right now, and we are darting in, and hopefully it's a good time to show you what's going on the Apex show floor, to connect you and our audience with manufacturing and all the manufacturing operations here. With me is David Hewitt from CHT. You do a lot of post-assembly work here. Sure. Tell us about your products and how that plays into a printed circuit board assembly.
Okay. Well, CHT basically is a global manufacturer of pure silicone chemistry. So we're looking at 1-component, 2-component RTVs. And what we're looking at here in the stand, we're demonstrating this new product of ours at the moment, which is our silicone foam. So a 2-component silicone foam, it currently expands to about 220%. So if we look at this container here, if we put in a volume around here, we'd witness this growth happening here. And one of the applications that we're targeting is lightweighting, obviously, to get the weight right down in a component. So if you can imagine this component filled with a conventional material, it would be 3-4 times as heavy as this.
Batteries are heavy enough. This is a battery, ganged battery module, right?
And it costs money to transport weight around. Everybody knows that. So with a silicone foam, typical example here is we filled this battery box here, and if we have thermal runaway on any of these units here, the foam will contain it, because we're working to UL94V0. So we're looking at foam containment there. So applications for this would be vibration damping on a PCB, staking. If we look at this PCB here, you'd want to stake some of these larger components. Yeah, stake some of these larger components to cancel out any vibration that's going to damage the unit.
Yeah, these power boards especially contain, we designers, sometimes we refer to them as lumpy components. They're massive components, and in shock and vibration they have to be retained, or retained.
Will go into a chiller in a fridge or a refrigerator, as you guys call it. So that would just destroy itself if we didn't stake it. So that's what happens there. So that's a little bit about what we're doing with the foam. We also manufacture 1- and 2-part materials. So 1 part heat cure materials, 1 part thermally conductive materials, up to currently working around 4.2 watts per meter Kelvin, which is a good number. So those are the areas.
Some more solid, less foamy potting material. This is also, I can feel that it's silicone based.
So this is a 2-part addition cure material, so we're using platinum as the catalyst to cure it. Thermally conductive again, about 0.7 watts per meter on standard materials like this. And we can design these in for you. So if you've got an application that requires more than our standard offering, let us know. Let us know what the volumes are, what you actually require, color, viscosity, rheology. Give us 5 or 6 parameters to work from, and we'll develop your bespoke grade. So that's not an issue for us.
Customization is definitely an option. Tell us how some of these materials are applied, David.
Well, you can do those with 2 ways. Some of them we supply to you in cartridges. Others would be in 200-liter drums. So on the stand here, we're just showing. Yeah. On the stand at the moment is a machine from Versamix that we're partnered with, and we're working with this company. But it doesn't matter who you're with. I mean, we can work out a way of actually dispensing it for you. So you can make these as fancy as you want, but what you're looking at today on the stand is something fairly simple. Foot trigger operation. On the front of here would be a mixer nozzle, combining the 2 products together, 2 materials together, and watch that cure off.
We were speaking a little earlier for suppliers, EMS providers that need automation. This can be automated, yes?
You can do whatever you want. I mean, you could have low-level sensors, high-level, automatically feed into there. Cost goes up with that, but you could make it as fancy as you want. You can have a full automation system where you don't have any operators on site at all. They would all be managed for you. Stir the materials to make sure they're fresh. Vacuum the materials to make sure they're air-free, so they're dispensed correctly every time. shot dispenser. So we use time, pressure, volume as the three main parameters to make sure that is filled.
For our designer audience now, we lay out boards. We concentrate on component placement, laying out the traces, the connectivity. But there comes a point on an assembly drawing where we have the challenge of defining a lot of the requirements, and if we foresee that a certain component must be retained in some way mechanically, like with your products, our job is to add a note that we must apply a certain material, curing a certain amount of time, which goes on to the assembly. As designers, we define that, but it goes on to the assembly manufacturers, and they have to deal with it. So it's important to know what's available, and our designers can contact you. Our audience, our entire audience, can contact you with the constraints, the parameters and the constraints, everything that's plus the information that you can custom mix stuff too.
Absolutely, yeah. I mean, the full temperature range with silicone chemistry, you can go from sort of minus 150 degrees C to plus 300 degrees C. So we're involved with SpaceX and companies like this with the Mars rover and so on. So harsh environments, the mining industry. Automotive obviously is our main area, but it's in every single application across the world. It's a clever chemistry, and we win. Basically, silicones are used purely for for high temperature applications, where a PU or an epoxy would fall down. It's a little bit of an on-cost using silicone chemistry, but the benefits are there. Optically clear materials as well for all these different kind of applications. So yeah, but 1- and 2-part materials from CHT silicones.
Okay, and we always think about reworkability if we ever have to rework, and I can see that I can just guess that some of these foams are a lot more reworkable than some of the solid materials, or especially the epoxies you mentioned.
Yeah, absolutely. Reworkability is no problem for us. So the foam can be removed. The adhesion is there, but you can break the adhesion down, or we can increase the adhesion if you need with a primer. But we also manufacture gels over here.
Walk?
Yeah, sure. So if we look,
let's go on back
around. If we come around here,
let me scoot around here.
yeah. If you come here, that looks like there's nothing in there at all, but we're looking at an optically clear material. So we would just call that a water clear material. So this one's been touched a little bit, there's some fingerprints on there, but optically clear material for headlight manufacturers, that kind of thing. So when you have a front end impact on your car, usually that lamp is destroyed. Now we're looking at silicone technology to go into the headlamp to protect from impact, and also allow the light to transmit through.
Also even for inspectability, a lot of these products, components, if it's potted, the visibility goes away and the inspectability may go away.
True.
A lot of mechanical stress can happen during the potting stage. I would think that maybe a clear material like this would possibly be more inspectable.
Lighting technology is moving at a rapid pace now, so we're looking at different silicones that will actually, if you look at my hand, send the light in each direction. So the bulb will move, or the LED will move, and run through our silicone into every direction where the lighting needs to go. So as you turn your car, the light will actually follow the road. That's the kind of thing we're working on with our partners. I'm not sure we can see it here, but we've got the thermally conductive grades here as well. So this one's a new one that we've just developed. We've just got some little chiller units on the stand here. So you're not going to get this through camera, but this base plate is obviously extremely cold. We have a silicone on top here, and the transmission of either hot or cold temperatures is pulled through very, very rapidly. So it isn't a sort of a test you can do on a camera, but
thermally conductive?
Yep. So thermally conductive. So if you think of EVs, let's just concentrate on EV. The temperatures now inside those cars are coming up pretty high. Before, when it was a combustion engine, you had about 150 degrees C in the engine block. Now these are crazy temperatures because we're talking about big currents. So what do we do with that heat? We need to dissipate it, and you can do that through an aluminium cooling fin. There's no issue, but you need an intermediary layer between those two components, and we do that with the likes of these thermally conductive materials. So we would bond A and B components together. And the way you do that is use a primer as well. And when you're bonded, you get a fantastic thermal path. Rather than just a touch to touch, If we have the adhesion, we can shift that heat away as quick as possible. Longer life components, your car lasts longer is the end game.
Absolutely. I just became an owner of an older model EV, and I'm thinking about this all the time. What's going on with these batteries, and how are they packaged? I haven't really seen them. I drive it and I love it. But you know, this technology is exploding right now, the EV industry. So I'm glad to see you're supporting it.
Say there's something around 2 to 3 kilos of silicone on every car on the planet at the moment. Yep. So we won't go through all the applications, but you can imagine it's all the way through the car. And we're involved in every application on those. So literature behind me will tell you exactly where we're used.
How about your molding? Do you create the molds, or do customers typically create them?
Customers would create the molds. So we would make a customer-specific material that they want, either 1-to-1 ratio, 10-to-1, whichever they need. And again, going back to the color, the viscosity, whichever parameters they want to fix in place, we'll make that for them. But so we would supply in the A and B component molding rubbers. They would then take that and make whatever they want, pour it into a mold, do whatever's required.
Well, is there anything else you'd like to show off to our audience here? That's good.
We've looked at all the thermal materials, optically clear. So if you just think of high temperature, low temperature silicone materials from CHT. And as I say, we're a global player, so we manufacture in about 7 or 8 manufacturing plants around the world. So what we're trying to achieve is get the same product in any manufacturing location around the world.
So how our designer audience can call you or email you or look you up on the web with questions. Again, we're all about constraints. We need to know the performance and the specifications of your materials so that we can call them out.
So we're a global player. So as you can probably tell from my voice, I'm from the UK. So I'm over here to support these guys with. Thank you. Yeah, I'm enjoying my time here. San Diego's amazing. So so I'm over here to support these guys as much as I can with the information we already do in Europe. How can we transpose that over into the US market and likewise in return? So that's how we work, and what we as a company transfer information benefits you guys as well as users.
Well, very much appreciate your time, David. With me has been David Hewitt for CHT, and we're walking the show floor here, and we're hoping you're following along. So thank you very much.
You're welcome.
Yeah, look them up. Yeah. Thank you very much for your time. Wonderful. Right now, you know, we're going to be what's coming up at 1 p.m. We want to tag the Altium Designer Best Practices Part 2, which is coming up from David Haboud. It's in our Power User series. Also, Vincent Mazur is going to be presenting Avoiding Supply Issues, and that's over in our Design Challenge stage. So make sure and tune in at 1 o'clock. We may look right and left and go get a bite to eat until then. So we'll end this set and hope you're enjoying it. Hope you're enjoying AltiumLive Connect 2022. Connect with us. We'll see you back.
And to any customers out there that are not using this, I couldn't imagine not using these features. It would be very difficult to go back. Let's put it that way. So. I'm Jeremy Waller. I'm the Senior Electrical Engineer at Quantel Laser in Bozeman, Montana. And that's part of a global company called Lumibird, and we have many design centers around the world. There's 18 mechanical engineers, about 22 electrical engineers in Lumibird that are part of the Altium 365 environment. It's pretty easy with Altium 365 to expand our environment. So we research, develop, and manufacture solid-state laser systems for medical and scientific defense-related industries. Yeah, I mean, our mantra, I guess, would be we're rugged, reliable laser systems.
I'm Lane McNeil, the Senior Mechanical Engineer at Quantel USA. This is one of our newest, and it's a fairly high power, high rep rate laser system. So it operates with diode powered input, but it's water cooled. But the circuit board components of it, when we got going, we have some covers here that we put together, and they're kind of interesting. We have a number of circuit boards that sit inside the system. There are some fairly high power diode drivers that we use, coupled with some control electronics, and then we have some other electronics that are used for regulation of nonlinear crystals that we use to convert the laser output to different colors. Before we were using CoDesigner, basically we would get a DXF file is what we would receive. We would then take the components and we'd have to go ask them, okay, how tall are these? How tall are these components? And then we'd have to extrude the materials up to get an idea, because we have some very tight fit applications that are going on. So
a collaboration tool like CoDesigner just really allows us to transfer back and forth easily. Not only does it help us design the space, but it makes for better assembly drawings so that people can build and manufacture this, you know. So I mean, it changes a lot of the picture here.
It's an amazing step forward now to be able to have all the, you know, exact physical geometry completely understood and known. Being able to see that allows us to prevent problems that we were having in the past. We have an example here of one of our lasers that was a collaborative process using Altium CoDesigner and SolidWorks.
Having the collaboration tool like CoDesigner in there helped us with this board in this particular design. How did we get to this board, I guess, is a good example to go through. This is how it starts a project usually. I mean, you just have a rat's nest of components and in this case, we'll just pull a few of the important ones that we need to find location on right away. Because I need to get Lane involved and give me a board shape that fits in the space, show me where the mounting holes are, and we just got to establish an area where we can do components. So I'm just going to push it over to him for the first time so that Lane can receive it on his end, and he's going to do all the work for me, thankfully. It takes all the risk out of the process.
Did you get that pushed, Jeremy?
Yeah, it's got it pushed over to your direction, so I've got it in there. You can switch over to your screen.
Okay, so I'm pulling it in here. Right, this. So basically one of the first things that comes in with these is gives us the opportunity to come in here and define the physical size and shape of the component. So that is the physical size of the circuit board that we wanted to work with. And then basically what we're able to do, I can position the component . So with that kind of placement, then I'm able to come in and add cutouts to the circuit board. But one of the things that we often do is we will go in and add a feature on the board that's going to define all the keep outs. So I'm just going to define a new part at the moment that I will define as the keep out zone.
These are the features that are difficult. They're pretty obscure, you know, random shapes and everything. The thing is, this usually is a lot of back and forth, but since this is a board that we've already went through this process, what you're getting to see is like, you know, weeks worth of back and forth and arguing over shapes and space.
But it's going to have a lot of this information is going to show up in one shot and be pretty well done, so that Jeremy would be ready to work with it as soon as we're complete with this. Okay, so I just pushed it at this point. So what you're going to see is Jeremy will now have the opportunity to pull the system into Altium when the push is done. It's still in the process of collecting. There, it's done.
It's already there. All right, so it is fast. I mean, this is great. You know, I would comment too, even when designs are pushed and updated overseas, our server's not even in this part of the country, so it's been really a good performing product. But I want to view the changes, see what Lane did. On occasion too, so it's going to give me a list of the preview of what he did. So if I like everything that I see, I can just hit apply and it's going to pull everything in there. Okay, so here you go. Here's all the changes he made. It's got everything I need to get started for the most part.
It would be impossible for a single individual focused on designing electrical circuits to be able to also at the same time envision all the detailed mechanics, because they don't have access to that information. And so This allows the mechanical engineer to effectively assist the electrical engineer in basically properly positioning things to achieve the most compact or the most reliable connection without a bunch of iterative problem solving and back and forth mistakes and fixing. I understand his challenges, he understands mine, and we work together to come up with a solution that works for both of us. And it's the thing that didn't happen in the past nearly as easily.
We're more competitive in the market now because we're able to get smaller. So now we're taking advantage of better PCB design technologies like micro vias and varied vias, and getting our circuit boards smaller and smaller. And at the same time, the space that we're working with in Lane's world is getting tighter and tighter. So it is definitely added to the quality and performance of our laser systems. And so it's worth every bit of time invested in learning the tools to allow you to provide those better products for your customers.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip, we're in partnership with the folks from the IPC. Stakeholders unite, and we'll feel alright, digging more to show synergy. So let's all connect, come on people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine, check us out, virtual attendance, yeah. Hi, Kelly Dack for AltiumLive 2022 Connect. Hey, we're still down here on the show floor, and we're hoping you're having a good show too right now with all our speakers that are going on the different stages. But for now, we are down here on the show floor, and I'd like to introduce you to George Babka, who works for Yamaha. My goodness, this is an impressive setup you've got here. Tell us about it.
Okay, so actually, Yamaha has a couple different booths here at the show. Our distribution partner, Transtech, has some of our more common general purpose machines over in their booth, which is kind of the like I said, more common stuff. What we're trying to showcase in the Yamaha booth here is our latest technology and machines that are just coming to the market. Okay, so obviously everyone's kind of cutting back on the show because they didn't know how many people were going to show up. And we still decided to have a full booth, right? So, but the main thing that we wanted to do is show where we're going, right? So, if you know, Yamaha is a manufacturer of pick and place, dispensers, printers, inspection machines, X-ray machines, and storage towers. So we supply those to the industry, and so what I want to show you today maybe is just the three machines here that we're kind of showcasing. One is the YSP10. Okay, so this is a printer that's fully automatic as options. Okay, and some of the unique features of this, other than all of our printers have this a rotating squeegee blade, and if you can look in there while it's printing back and forth, it's just printing on a blank stencil.
So for our audience, when you say printers, we have to assume there's some emerging engineers out here who have never seen the process. So this is valuable being here. We're printing solder paste. Tell us about the whole process and how that works.
Okay, so the deal there is we're printing solder, like solder balls in flux. So it's like a paste material, like a peanut butter kind of consistency, and we print that with a squeegee through a metal stencil, okay? Kind of like they make t-shirts with, although they use a screen for that, okay? So this technology's been around for a while. So it's kind of mass deposition of solder onto a circuit board. That circuit board, then you place components on it, right? That solder is sticky enough so it'll hold those components until you put it through an oven, which will actually melt all the solder together and use the flux to actually form the solder joint, okay? So, you know, I've been in the printer industry before this, you know, for over 30 years, and over the last, I'd say, 15 years, there's really been nothing new that's come to the market for the printers. It's just like, how cheap can we make this? You know, how many can you have in what time, okay? So, Yamaha is different. I mean, we're still innovating every product line. We're not saying something is a mature technology. So we introduced the YSP-10 here a couple years ago. And some of the newer features on this, which that we introduced, okay, first of all, the standard features for this that make us different in the industry is we have a single squeegee blade. Normally most printers have two squeegee blades. One will print in one direction, the other will print in the opposite. We have a single squeegee blade that'll actually rotate over the solder roll so that we don't have to worry about solder sticking to the blades, because it's always on the same side of the squeegee. But in addition to that, we can actually control the angle. So we can actually control the filling force into the hole, okay? Which is very important in production, because as you use up solder, it changes the dynamics of the print, okay? So that's the short answer. I could give you a 3-hour presentation on that alone, but I'm sure that your viewers aren't that interested.
It is a challenge because, you know, components on boards, sometimes they're mixed technologies and require more solder. Sometimes they're micro technology, and it's hard to squeeze a few balls onto a component land. What's your suggestion? How are some of the stencil? Do you manufacture stencils at all? Or
you know, there's plenty of very good stencil manufacturers out there. One of the things that our machine allows us to do is kind of break over the barrier of limitations between the hole size and the fineness of the powder that's in the solder, okay? Because we can control that fill force, we can actually get more solder through the hole, especially for like through-hole devices. It's not really the small components. It's, well, on that side, it's the fineness of the powder and the size of the hole. But on the bigger stuff, the through-hole components, where you're actually sticking solder, so you're sticking a component through a hole that's already got solder on top of it, right? It's solder paste. We can get more down because we have a higher degree of force control. Okay, so.
Michael, if you can get just a shot of that line of paste I have, before, but check this out. You can just
see it. Now watch it.
The solder. You can see the solder roll.
So the squeegee's going to pick up. Now it's going to rotate over the opposite way, and it's going to print in the opposite direction. Okay, so the solder always stays on the same side of the squeegee blade, and since you're not managing two squeegee blades, you're not managing two different solder rolls. Okay, so it gives you a level of process control that's not available on other machines. Okay, so that's a standard feature we've had ever since we made printers starting in 1999. Okay, so but some of the additional features of this machine is that I can automatically change it over, so I can pull, first of all, I can scoop all the solder off the stencil automatically. I can pull the stencil out. I can change the pin locations or support locations underneath the board. And then I can move a new stencil in and put the solder down all in less than 5 minutes. Typically when you're changing over a line, the longest thing to do is to change over your solder printer, because that takes about 15 minutes. So even for small customers who may be running 5 jobs in one shift, right, having that extra time can allow you to run a whole nother setup in that same time period. So it's kind of like having a sports car and you're hitting every red light along the way, right? It's like, you know, minimizing the time you're stopped, right? So we've always been talking about raw time. How fast is it? Okay, but it's also what's the overall, how many boards did you build a day or a week or whatever is more important than what's the top speed of the machine.
Yeah, that's something I learned going to work as a designer, a PC board designer, going to work for an EMS provider.
Sure.
I learned as a designer that I didn't know before, that time on the assembly lines are measured in seconds. If they in volume, if they can save seconds, they save lots of money.
Sure, right. And so that's the whole thing. So you have to balance your needs between overall, if you're never going to change over, going to run the same product all the time, that's a different process than one that you change over a lot. So one is focused on shaving 0.2 of a second off the line. You can build an extra 20 boards in a shift versus minimizing the time we change over, right? So when we change over a pick and place machine, we'll just pull all the feeders out on a cart, right? So you can put other ones in and you can go right back to work. So you can set up while the other job is still running. So that's how we do that. Here we're doing something similar. We're already pre-staging the other stencil. We already programmed the solder or the support pins, and so it can automatically change over. So this machine as well is doing a lot of parallel processing. So we can be cleaning the stencil while another board's coming in. We can do inspection, and at the same time that we're dispensing solder. And so really trying to get that overall tack time, measured by a board exiting the machine, not how long it takes any individual board in here, but how often is a board coming out of the machine.
Well, once the process is complete, the board lowers down away from the stencil and creates a geometry of solder paste that it's called release, right?
Yes, right.
Okay, so the release is important. The board goes off. Is it inspected at that point?
It can be inspected in here, and so for lower volume customers, you can actually use an onboard camera to look at all the solder on the stencil, or on the board.
They're checked for a good geometry and good deposition. Right. What's the next step? Where do we go next?
The next step is we go over to the pick and place machine. We have two here. Okay, this is our standard machine. We call the ZLX or the YSM20. This has been available since like 2015 or so, or 2014. Okay, this is a dual gantry machine. It comes in a single gantry. Here we're showing two separate heads placing on the boards. And the way we actually speed this up is, if you can see this, the tables are split. So the front gantry is placing on one board, and the other gantry is placing on the same design board, because you're building half the board over here on the first stage, and the second half over here. So it almost acts like an internal dual lane system. And so when I split those tables, those heads can actually both place at the same time without crashing, right?
I hope we have enough bandwidth to show the action that's going on there. That machine is screaming. Right. It's amazing.
So, so you'll see this. Well, I think we have it in dry cycle mode right now, right? So each axis is placing on its own, but with the table splitting, what happens is the tables will come together, boards will transfer, and then the tables will split again, right? So I'm waving my hands a lot, but anyway, so this machine is like, Yamaha every 3 years releases either a revision of an existing platform or a brand new machine. So like every 6 years we'll come out with a new machine. In between we have a speed up version, right? So this is the R series, okay, or the revision series, right? So this gave us an extra 10% output through this. This is about 95,000 components per hour, what they call champion speed with the two heads. Okay.
Let me ask you a question regarding component sizing. Sure. I was here years ago, and the 0201s came out, and then the 01005s came out. Sure. What's the next step, and how are the assembly placement machines handling these newer, micro dust-sized components?
So what we're doing is, 20, 30 years ago, we were talking about going to 06, 03s and how we're going to place these things, and the components keep getting smaller. So, we have this machine is a 35 micron machine. The other machine I'm going to show you is 25 microns, so a higher accuracy for those small components. Okay, so a lot of the problems with smaller components is not actually placing them. It's actually having the vacuum to actually pick them, right? Because you have a little bit of dust in there now. You lose a lot of this vacuum, And then also there's a thing called like a component bring back. If I'm placing a component, I've got to drop it so that if I bring it back, then it doesn't end up being placed because there's very little solder on the board. So, we're able to go down sub 0105, imperial down to 0105 metric, right? So I don't even know what that number is, 008, whatever that is, right? but anyway, so we've done that. We demonstrate that all of our machines, actually, before they are sold to the public, they are used to build our own product, okay? So every feeder that we have has a circuit board in it. And so, and some other control boards and stuff that we have inside the machine, we build ourselves. Why do we do that? We do that first to test the longevity of a new platform, and then two, so we can kind of control the production in our own house. But on all of our circuit boards, we have test placements that are not functional components, but we're just using that to do SBC checks on finer and finer, smaller components than what we're currently placing on that individual device. I mean, any circuit board designer can design in these small components, but then the manufacturing engineers are like, if you don't have to use a smaller component, then don't, just because they're more difficult to operate.
An acronym, and for our audience, we may be introducing some acronyms. SPC is a statistical process control, so it's an inspection point and measurability. Your system adds measurability to, if there's a problem component that keeps happening over and over,
right,
you can identify it and fix it.
That's correct. You're right. So. Yeah, so we have a lot of real-time statistical process control tools. We have a closed-loop link with our inspection machines. So if we find a defect in our inspection machine, it'll send that defected image to the screen of the mounter. It'll show a reference image and the defective image, and you can say pass or fail. If it's failed, you have recovery steps right on the screen, so you can say I can look at the tape just to make sure there's components there, it's aligned right. I can actually take the nozzle over the nozzle cleaner to actually blow out any dust, right? And or I can adjust offsets, okay? So I can do all that inside the machine in real time, okay? So only the boards in between the placement machine and the inspection machine, we're shortening that whole feedback loop, okay? So, go ahead.
George, we talk a lot in design in our design classes about manufacturing constraints. And constraints are often dictated by the machinery that's going to be used at the EMS provider that you're doing business with.
Right.
What are some of the latest constraints regarding component placement, angles, proximity to other components? Can you just fly over that concept?
Sure, right. So, our nozzles are getting, as components get smaller, placing them, next to each other, your nozzles actually have to be smaller. You can't have a big shoulder on the end of them because then you can actually hit adjacent components, especially if you're putting small components right around an IC or something like that. You don't necessarily have a lot of room. So, we've done tests where you would never do this as a design engineer, but putting in components in between the leads of a leaded device.
I love it.
Look to see if you can, can do that. So we do that. So we have what's called fine pitch nozzles, so we can do that. But beyond that, when we look at other constraints, boards are getting thinner, right? They're getting more highly populated. When they're routed, they're a lot flimsier, so board support becomes more of an issue. So, like we have with a printer, we have the ability to actually put automatic support pin placement underneath the board to support it. Okay. The other thing which is interesting is we're starting to see like when people are placing components on top, not on top of other components, but when they place them, they're actually the tops of them are over the other components, okay? So when we want to inspect them, which we'll talk about here in a little bit, how do you see a component when you're looking down and there's a connector right on top of these components? And so when we have the ability to look at it from the side and actually do some measurement techniques that way.
Right. So there's often orders of operations that the manufacturing engineers, our stakeholders, based on your design, are going to have to set up way in advance. Order of operation of components. Some chip capacitors and resistors may have a connector, even a surface mount connector placed over,
Right.
Which may cause problems
Right.
with oven reflow and stuff.
Sure, right. It's all tied together, right? So as you get a more denser circuit boards and thinner circuit boards, the entire processing becomes more delicate. Like when you're putting it through an oven, you have to support the board so it doesn't warp in the oven. Then you flip the board over, and so it was bowed like this, and now it's bowed down, right? So ways to actually to support that board. We have several different techniques for that. It's most critical on the printing for support, but even in the pick and place, having reactive force or something underneath it, so when you place, you're not actually flexing that board. Okay.
This is great information for our design viewers and probably our manufacturing audience also. Sure. That's involved. Again, we're trying to bring it all together and introduce our audience to the stakeholders that exist in the rest of the industry.
Sure.
What makes it all work together? How about your finest, your next scale machine?
Okay. So we've taken the technology of the YSM20, and actually, I don't know if you know, but Yamaha purchased Hitachi High-Tech, the intellectual property and the factory people that were building the Sigma. And the Sigma is a machine that Hitachi held the patent. Before that, it was Sanyo for the first rotary head. So you have like a multi-heads, that basically come around in a carousel to pick it up. Okay, so over the years, our competitors have found different ways to do that without violating the patent. So when we purchased Hitachi, right? So we are the owner of the carousel head. So we're actually just going around in circles like this. So it's either a carousel, a tilt-a-whirl, or a Ferris wheel, right? So having them all on the same axis allows us we can actually pick two components at the same time and place two components at the same time. Okay, so like if you look at a watch dial, you can be placing it at 3 o'clock and at 9 o'clock, right? But actually, we can place it any orientation, any degree of orientation. So we can get these. You need 33 degrees or 37 and a half or whatever you're placing a component. We're able to do that with this head. Okay.
That's required for board real estate or board functionality sometimes. So it's really important.
So what we did was we took the rotary head concept from the Hitachi machine. So this is kind of a fusion between the Sigma and the YSM that we showed you over here to give a single machine. This is also a dual gantry with a split table, okay? But what it'll do is, and maybe you can see it better up here, is, if you look at the video here, right now this is doing a nozzle exchange. All these nozzles are actually QR coded, so I can determine if I have a bad nozzle or I find out I've gotten a poor pick rate with a specific nozzle, it can go and identify that nozzle and exit out so it won't place them anymore, okay? So when you're closing the loop on traceability and things like that, then that certainly helps. Okay, so if we look here, this is simultaneous pickup on this video here. I don't know if you can see that. So it's picking up two components, like the 9 and 3 position, right? And placing them on there. Okay, so and this is high speed. They might slow it down here in a second, but in reality, this also not only allows us to pick two components at a time, but I get more. I can do a longer board in a smaller frame because I can actually rotate the head to pick up something all the way on the left. I can pick it up and then rotate it around to the right and place all the way on the other end of the board. Okay.
That's an interesting designer point. Let me pause you just for a sec.
Sure.
What do designers need to know about size of boards? When we're often given the opportunity to shrink boards,
right?
But sometimes we're faced with a challenge of having to expand boards, and fabricators can build a lot of different sizes of boards. The capabilities have come way up, but a designer has to think, right, about the capabilities of the assembly processing, the printing equipment.
Right.
What are some common sizes that the machinery deals with?
Okay, so normally, like in the automotive world, you'll get what's called M-size boards, which are no bigger than like 330 millimeters or by 250. So that's like 10 by 13.7 or something like that in that area. Okay, small cards. That's where these machines, when you split the table, they're completely separated from each other, so I can place on two gantries at the same time. As those boards get bigger, I can still split the table, and I can still access much of the board. In this machine, I have much more access because instead of doing a, the gantries have to have a physical distance between them. Now I can put both heads, which are now facing each other, placing in the same space, so it's a kind of a dynamic keep out zone, right? I don't want to say crash, you don't want to say firewall anymore, but to keep the heads from operating in exactly the same space, let's just say, we get more efficiency. So even though this machine's only rated for about like 3% faster for the same head design as that, we're actually seeing about a 10 to 15% speed improvement in this machine just because of this dynamic crash zone mapping.
How about with the speeds involved? Old school designers, we used to think of placement and time to place,
right?
Again, order of operation.
Sure.
Do designers really need to think about this, or do we, as far as machine placement, is there really a time burned up by placing components at an angle? Does the machine have to take time to think and do that anymore?
I think most placement machines now are actually adjusting the angle on the way over to place. So none of that is a concern anymore. However, we used to have what we called chip shooters, so you're only placing small components, and then you have a multi-function machine after, which places your taller connectors and things. Okay, what Yamaha has done is they say, hey, we've got a single head, our standard head, which we call the HM head, can place a component as small as these sub 105 components, all the way up to 15 millimeters tall and I think it's 55 millimeters square. Okay, all in a single head. Now, if you look at our competitors, you'd have a different head for different sizes, and so that's fine if that's all you're going to build, but you don't know from one day to the next what you're going to build, especially smaller contract manufacturers. You have to have the ability to be flexible without having to say, well, I'm going to pull this whole head out and put another one in to make this run efficient.
Flexibility is key, and if we flip that equation that you just explained,
right,
designers don't know where their boards are going to be manufactured. So we're talking about a certain sizes and max component heights that you can assemble. It's very important for the designers to, again, get in touch with who's manufacturing your board, who's purchased this machine from Yamaha, to establish capability and design, be able to design for that. Because if someone doesn't have this machine and may have less capability, you have to design for that also.
Right. So the only thing that still you can't do is you can't place through a shield, right? So if you put an RF shield on, those go on last, right? Because but a lot of times those go on top of other components. So if you're going to inspect that, you want to inspect it, and then you have a small machine afterwards to just place those shields, right? So, and we've been doing that for years. We have a much smaller machine just to do connector placement or shields and things like that after the main SMT and the inspection is done. Okay, so. So anyway, so this machine is we had a revamp of the software. Although a lot of people are used to our software interface from our older machines, we can flip back and forth between that. Right. So this is the old interface. The newer interface will actually show you where the boards are moving inside the machine. Oh, actually, they're doing that right now. So, but as the board gets bigger. Okay, so everyone says, well, I need a board. I need a machine that'll do 48-inch board because I may be doing overhead LED panel.
Sure, that's real common now.
So how do you do that? In the same machine, when you tell it the length of the board, it'll automatically adjust. So it knows that, hey, once the board gets to a certain length, I can't split the table anymore, right? So it automatically will lock the two tables together, and then it'll operate as a single lane machine where I'm placing with one head and then, that moves out of the way and then I'm placing with the other, okay? So you lose a little bit of efficiency there, but you don't have to buy a separate machine for that. One of the biggest things that people, they say, is the pick and place big enough to handle this board? Yes, it can handle it. But when you talk about printing, can I handle that long board, right? And then also, when you're talking about these big boards, you need to have conveyors in between them that are enormous, and alignment of machines becomes a lot more critical because now you're talking about a 4-foot panel coming through the machine. So having the capability and not, you say, yes, I can do this in the future if I need to, but I don't need to buy an entire long board line for a product that I don't have, that I'm not building yet. I have the ability to do it on an existing machine.
That's an interesting point. Accuracy and ability to measure boards. A board is not a bare board that's not manufactured the same as your artwork that's you're viewing on the screen. There are stretch factors and stretch compensations. I know that the stencil manufacturers will make. They'll compensate stretch.
That, right.
So when you're talking about a flexibility of stretch, the placement machines have to compensate for that too. And we use fiducial marks and things. Talk to us about fiducial marks and accuracy and how the machine compensates.
Sure. So you can set this machine up to just look at global fiducials, like just on the corners, or like on a longer boards that stretch or whatever, you can actually set up local fiducials that apply to a certain range of components there, right? So why wouldn't you just do that all the time? It takes time. It's like going over and inspecting an area for a fiducial is just like a placement. So that whole routine, takes time. And when you're talking about, shaving off a half a second or whatever, that becomes critical. One of the things that I would like to note is that our machines have this is a rotary head, but we have scan cameras on all our machines, so we can actually look at a component that's up to 12 millimeters square and up to 6.5 millimeters tall. I can actually look at it without actually having to take it over a stationary camera. So if I'm picking and going directly to the board, that's faster than picking, going over a camera, and then going up to the board. So that's about a 30% time savings if you can do that. So, we did that back in 2008, right? And with these newer machines, we're actually increasing increasing the size of the components that we can actually do that with. For our rotary head, we have fixed side view cameras and a light source in the center of the turret, right? So I'm backlighting the component, I'm looking at the component, and I can see how it sits on the nozzle. If it's not completely centered on the nozzle, I can communicate back to a feeder to adjust the pick position for the next board. And all these feeders are intelligent, so I can save those offsets on the feeders. So if I pick this feeder up and I put it on another machine, it reads all that. So we know how many cycles it's been, how many mispicks it's had, and everything else. And so when we go to calibrate these feeders, we can look at the whole history. After 5 million picks, how many were bad picks? What's the offset and everything else? And so we're getting a level of repeatability that we didn't need 10 years ago. Okay.
How about let me we've taken a lot of your time, and you're a gold mine of information, George. And these machines show really well, and they're just fascinating. Designers have questions about things, constraints, like placement constraints, like how many fiducials are required nowadays. What are the size? The standard 1 millimeter round fiducial, that always works everywhere, but as boards shrink and real estate becomes critical, is there anything we can do fiducial wise or locationally wise? Can you go with smaller fiducials now?
We're talking about higher resolution cameras in the entire machine, so we can actually look at smaller fiducial sizes. And a lot of times we'll just consult with the engineers. If they call and say, hey, what's the smallest we can do? It's like, well, we can test things for you. We can run simulations. We have detailed specs about, like the color of the fiducial and everything else. How it's defined with a solder resist around it, or if it's a zone pad. So there's a lot of things we can do for that. We also have the ability for components that aren't normal components, like battery clips or or connectors and things like this that aren't square, we have the option to be able to actually do what they call smart vision, so I can actually create an image for that component on the machine. Okay, so I don't, most of the stuff is actually automatically generated from the CAD data that comes in. Okay, and but for these odd components, we can actually teach those kind of with like a video model teach. Okay, so.
Do you have a minute? Again, I know you need to get back to the show floor, but I see one more machine, and I bet you that's the machine that inspects the work that this machine has done.
Okay.
Let's try it. Follow us. This is wonderful.
Okay. So this is our wire IV. This is our brand new, we call AOI, which is automatic optical inspection. Okay, so we've, this is probably the fourth generation of AOI machine that we have. Okay, it's a true 3D AOI, which means that we're actually looking at the board with a top-down camera, right? And then we're also with a Moire pattern. We're actually putting structured white light, and we're doing a phase shift on it, where we can actually see the component topography based on the interference pattern we see with these things. Okay, so we have 4 projectors. Okay, why do we have 4? It's like, well, because then if one of the projectors is shadowed by a taller component, we can still see it with the other 3. Okay, but we also have what we call 4D, which means this machine goes back in time. No, it actually, 4D will allow us to do off-axis inspection. So you have a top-down camera that's receiving images for the heights, right? So you do a whole surface map of heights, right? And then you overlay this video image on it, and then you can actually look at a component after it's placed and rotate it, right, through the 4D cameras, our angular cameras, and we can actually look at the solder joints. Like if you want to look at the heel or toe joints, you can actually see that, right?
Those are beautiful solder joints.
Right. So, is this necessary for everybody? No, but it's nice to do for at a repair station. When you say this is defected, you can say, well, is it really a defect, or did I just see a bright spot or a bright pad? Okay. Another thing that this can do is actually, if there's what we call a bonus component or a component that's been placed by somebody else, right? It's fallen on the machine. Since we're scanning the entire board, we can actually identify that board, okay? And
that scan. That's a great 3D scan, and that's using the cameras. That's an actual photographic image in 4D.
The 4D is basically stitching together the 4 separate camera views and making it a true 3D model, okay? So, a couple other things. You see these characters on here. We have our own optical character recognition that's not just measuring or looking at matching a video image. You're actually reading this as a 3, okay? So then you can identify the font. If it's not reading it right or whatever, you can set up a criteria, okay? And our machine, and David is our, so he'll hit me if I'm wrong here, but David is our AOI product manager. David Sue, and we can actually set a criteria for each component that if it passes it, go on through. If it doesn't, there's a secondary inspection it can do to verify it's a defect. And you can stack these on top of each other, 7 or whatever. But, we have kind of standard profiles for these things, which makes it easier to program. But if you have a tricky component, there's other things you can do to actually find these things.
What's striking, coming from a design background, we're truly now, and we have been for a while, we're truly to the point of getting an image at the ends of the process, the inspection points of the process, with your 4D capability.
Right.
That image that you were rotating around looks exactly like the front end image that we'll see like on Altium design, CAD drawing. Our 3D capability before the board's ever produced, before the parts are cut. So that's just incredible to me, and I hope it is to our audience.
So here's all the different fonts that it can see. So it's not just saying, well, if the D doesn't look like this, if the D looks like this, on other OCR systems or optical character recognition, it might fail that. Sometimes we call that OCV, or verification only, okay? We're actually detecting this and determining whether it's acceptable, okay? So then sometimes it's like, well, here's a date code or whatever. I'm going to ignore or I'm only going to look at the first 5 digits or whatever to say, yes, this is the component, right? But I can also record these other pieces here, these other numbers, for traceability later. Now, all of our machines take pictures of the board throughout the entire process. We can tie all those images together in what we call a, what do they call that?
Threading or something?
Yeah, it's I'm sorry, it's component monitoring. You know, basically, if you say, look, if I find a defect here, I can say, what did the part look like when I picked it and when I placed it? You know, and I can tie all those images together. And so, what I can do then is determine where the defect occurred instead of just saying, I got a defect here. I'm assuming it came from the pick and place machine. Well, maybe it got bumped before it went into the oven, or maybe there's not enough solder that got put on it, or whatever, right? So that gives the operators the ability, or engineers the ability to identify that. Now, what David just mentioned, what we call QA option, is what we talked about before. If I find a defect here, if I'm placing it on a Yamaha machine, I can actually tell what side of the machine it was placed on, what feeder it was placed on, what reel of components, and so I can drill down and get to the root cause in real time, which is significant. I mean, other
traceability of where the problem is. You've got to that thing tells the story, right? Sure. And you can walk back through it. Love that.
Yeah. So there's a lot of tools here, and when we've been talking about Factory 4.0, or the fourth industrial revolution. It's like we're trying to get all this information. Yamaha's been doing this since 2012, okay? We've been collecting all this information and sharing it with our own machines, and now our challenge, which we've met, is to now communicate with other machines that are in our line. If it's not an entire Yamaha line, how do we take information from somebody else's pick and place or somebody else's solder paste inspection machine and input it in? So that's what we're doing. Now we're all speaking the same language. But as far as the data we're sharing, we have over 10 years of experience of actually communicating down the entire line, machine to machine, and then machine to the network. Okay, so there's a lot of things that we can do, and it's not just how many components can you place anymore, right? It's what's my first pass yield here, right? If I get a whole bunch of false defects, another person's got to look at this board later, right? And that takes time, right? And so you build up this reject queue, and then someone has to determine whether they're good or not, right? I can actually, not me, the machine can actually set up an alert to a QA operator somewhere else in the factory on their smartphone. There's a defect here. I'm sorry. And it'll show the reference image and the defective image, and they can decide whether it's pass or fail, independent of the operator, okay? So a lot of times, if you've ever been an operator on a line, it's like I get graded by how many boards come out, right? So I'm always trying to speed
Thank
it
you
up.
for that perspective, because that's exactly what we're trying to do, is bring designers to the manufacturing floor, introduce them. I mean, you sell to manufacturers, but you're doing a great job of getting us in touch.
Sure.
And really appreciate that.
That's the whole thing of the feedback loop throughout the company. Hey, this works, this doesn't. This is not solderable. Hey, whatever. And getting the design engineers involved in the manufacturing process, and the manufacturing engineers getting involved in the design process certainly helps. So I know I'm taking up a lot of your time here.
No, not at all. You've been a treasure trove of information. We just let the camera run. I hope that's okay with our cameraman Michael and our audience. But we really appreciate this time. I think it was very valuable and educational. Okay. And I'll be back. I want to learn even more. I know you've got a lot of stuff. I've got I've got so many more questions about software and how these things run, how they're set up.
We have a software station down there, which if you have time later, we can show you.
Perfect. What's expected from the designers as far as outputting data? We're a lot more data rich now, so it's a matter of we have buttons to press to output data. Tell us what you like. For instance. Sure. Well, it's been a pleasure. I'll fist bump you, George Babka, and David Sue over in the background. He's been instrumental. Yes. Thank you very much. Let me fist bump you.
Here, so.
Thank you.
My pleasure.
Yeah.
Okay.
Well, for Altium Live 20, let's keep walking. I'm told we're going to keep walking.
Okay.
Thank you,
All right,
gentlemen.
thanks.
So much.
All right. You need a business card for me or not?
I'll take one. Well, I'll come and get it. Let us go. 2 minutes. Okay. We've got just a few minutes before our next events are coming up, I'm told. So I think I'd like to introduce Coping with Design Challenges with an intelligent component library on one of our event stages. You'll see that on screen. And then there's also Altium Designer Best Practices Part 1, which ought to be awesome. So I hope you can tune into that. And I hope if you've been tuned in for the last half hour or so over here on the show floor with Yamaha, it's been a fun time with these guys, and we learned quite a bit. So I think it's a good time to take a break and let you watch the presentations. I'm Kelly Dack for AltiumLive Connect 2022. Thanks for being us, and we'll see you a little later.
Altium 365 lets you hold the fastest design reviews ever. Share your designs from anywhere and with anyone with a single click. It's easy. Leave a comment tagging your teammate, and they'll instantly receive an email with a link to the design. Anyone you invite can open the design using a web browser. Using the browser interface, you're able to comment, markup, cross-probe, inspect, and more. Comments are attached directly to the project, making them viewable within Altium Designer, as well as through the browser interface. Give it a try and get started with Altium 365 today.
Well, gotta act fast, sign up for the broadcast of the Altium Live 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and we'll feel alright, digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out, virtual attendance, yeah.
Hi, Kelly Dack back for Altium Live Connect 2022. We're back down here on the show floor, and we've been walking around trying to find something interesting for you, and we accomplished that mission. With me is Juan Luis Turin from Smart Soul, and you manufacture machinery for all kinds of, it looks like, inspection and rework. Tell us about Smart Soul and what you're doing. I love the robotics here.
Yeah, thank you very much. Well, basically we're a representative company for all these brands mainly in Mexico. We just started operations in the US last year and Central America. And this is our third time in Apex. Unfortunately, last year we don't have the show because of the COVID situation. But this 2022, we are back here in order to show all the products that we represent and distribute here in the US, Mexico, and Central America, basically.
Well, welcome back. We're glad to have you. Let's maybe we can walk the line here, and you can show us what the equipment does, and see what show us what designers might be interested in as far as how boards are processed. We're trying to connect our designer audience with the rest of the stakeholders in the industry.
Yeah, basically we try to provide the whole solution for the electronics assembly for our customers. And unfortunately, there is no enough space to have all the machinery we basically manage. But here you can see some examples of the, let's say, most popular products we basically sell. Here you can see some robots. This is a soldering robot, basically uses to do soldering for PCBs. And we are integrating the solution with a collaborative robot for do the handling, the handling of the PCB. Also, this is just a simple, let's say, application to show the capacity for the robot. It is integrated with a vision system, so the idea is to basically touch the color circle, and the robot identify which color it is and pick the part according to the color.
Can we do it?
I think so. I don't know if it's still working. Yeah.
We just started the show here, so things may not be dialed in yet, but let's try.
Yeah, let me see if it's working. I think it's going.
This is the robot. The robot is on the spot.
Yeah, exactly. We're just opening the show, so
yeah, understood.
We just
our audience will understand.
Yeah, the robot is moving right now. Let me see if I can put more speed on it. So basically, it's gonna touch the screen to pick a color. It's gonna identify the color on the screen and pick up the part. This is just to show one of the features the robot has, which is a vision system which is integrated in order to basically do some actions according what the robot sees. Okay. So in this case, it detects the green color. I'm gonna take this out from here because he's gonna look for the part on the tray. Right now,
he's really thinking about it.
Yeah, yeah. Probably it's too early for the robot, you know.
Yeah, sometimes they haven't had their coffee yet. We know how robots are.
Probably we need to get somebody to get fine tuning here, but the idea is to do that thing with the color. Okay.
Oh, there he goes.
He was missing the yellow one.
He seems to like yellow.
Pick it up. Yeah. So this is the general idea with this robot. We also have a screwing robot. We have different kind of solutions for the machinery here. And
how about around the corner?
Let's take a look on that.
Yeah, and really appreciate you taking us on a little tour here. And it's so early, like we mentioned, the show just started, so things need to dial in. But you've already you're collecting a pretty good crowd here around your equipment. Yeah. Looks like some cleaning equipment here.
Yeah, this is a washer machine. It's part of some kind of processes for certain kind of boards. Idea is to deflux, is what it calls, deflux the PCBs, so the operation of the board in the field could be reliable. Yes. So this is one of the solutions we also are presenting on the show right now, and it's up and running now.
Right. This is awesome. Yeah, so cleanliness is a huge issue for circuit boards. You know, any kind of pollution on the final assembly can lead to what?
Yeah, basically there are products that are critical for certain kind of contamination, like medical product or military product or automotive product now. So idea is to make sure the product by itself or the circuit by itself is going to be completely reliable on the field. And it's going to be no issues with it because sometimes our security depends on this small stuff, all right?
Absolutely. Can we move on?
Yeah. This another machine is a laser marking system.
We want to see laser marking. We just talked to a manufacturer of label and systems that track things. So maybe you can get a shot in there, Michael, of the laser.
If you take a look inside, you could see the laser. Basically, we use this machine, or the people which are assembly the circuits on the field, uses this machine in order to basically serialize each circuit on the
each board on the assembly array, or is this bare board, or this is bare board.
Yeah, so we can show the capacity of the machine, of the laser.
How about, can I ask you a question about this laser technology? How easy is it to laser mark on solder mask versus some designers will put a patch of epoxy, the same material that's used for the legend marking.
Yeah.
What performs the best with a laser? I know it can't be reflective too much.
Correct. It's a good question. Basically, depending on the material, is the kind of laser technology we select. For instance, if we are going to be soldering, if we are going to be marking solder mask, we select CO2 laser technology. Is the best and the cheapest one to do it, all right? If we are going to mark, for instance, metal, like steel or aluminum, we select another kind of laser, which is called fiber laser. So depending on the material is the laser technology it should be selected in order to get the better results, all right?
Very good. And is there a next step in the process? Over here we've got the ER7000. This is great.
This is the paneling machine. It's a milling, the paneling machine technology. Basically, we use this.
This is milling. I see that now. Yes.
We use this kind of machines to separate or singulate the circuits from the main board.
Outstanding.
Yeah, it's a kind of a simple process, but also it should be very precise and very reliable. You know,
a lot of our designers are very familiar with how to create a printed circuit board panel or array. Typically, we send our data out as a one-to-one design to the board fabricator. And we may be prototyping at that point. But once the product goes off to production or volume, they need to utilize the panel, and they will panelize into an array form like this, or a panel, manufacturing panel, and then they'll cut these panels out into manufacturing or assembly arrays. And yeah, what we're explaining here is. What's the configuration? How do we get, do we determine that slots? Does this do any drilling at the same time if we need mouse bites, what we call mouse bites or anything?
Correct. There is different ways to singulate a PCB into several pieces. This one is, or this panel in specific for this kind of technology is a mouse bite, let's say, panel construction. But depending on how the designers basically design the panel, we should select this technology or a different technology. Right.
Yeah, so where I was going with that, it's interesting because some designers, we never have a need to panelize. That can be left to, if your board's going on to production or volume production, the manufacturing folks, your EMS provider, whoever's building your assemblies, will take your one-up data and they'll go ahead and panelize it to best fit their manufacturing parameters with the manufacturers they're teamed up with. So, but the end product is they're going to be using a machine like this to route out the slots so the board can be, some call it X size, that's a 25-cent word, D panel.
Correct.
Yeah.
Well, yeah, and this probably is one of the methods, let's say, that causes less stress in the PCB. I mean, physically speaking.
Sure.
So it's one of the most adopted methods in the manufacturing areas. But you can do it with this. You can do it with press singulation, or even you can do it with laser. Not with this machine, but with a similar machine. You can also depanelize with laser. The only situation with the laser is still very expensive technologies for these days. Probably in the future would be cheaper, and we can do it with laser, which is more clean, effective, and
It can be more accurate. It's widely used, I know, in prototyping flexible circuitry, right? It's widely used in flexible for the laminate materials, FR4, the glass epoxies. Maybe not so much unless it's thin.
Exactly. That depends on the thickness of the material to be cut. That is why it's now becoming more popular for flexible circuits. I mean the laser. As soon as the material is starting to get thicker, you need more power on the laser, so it becomes more expensive. So probably in the future we can see this technology to lower the price, so we can have it for let's say normal environment of manufacturing.
Very good. Well, Juan Lewis, I really appreciate your time sharing with us and our audience. Yeah, best to you at the show here. It looks like you're already successful and you've got some great equipment to show.
Yeah.
With me has been Juan Lewis for Smart Soul, and I'm Kelly Dack for AltiumLive 2022. We'll be back at you throughout the day. Stay tuned and make sure and stay connected.
Thank you very much.
Hello? Hey man, you gotta come check this out.
I'll be right there.
Take a look at this.
Whoa. This is going to change everything.
Invite Alex. Hey, are you seeing this?
Whoa, this really did change everything.
Well, gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and we'll feel alright. Digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Hi, Kelly Dack here for AltiumLive 2022 Connect. Hey, we're still down here on the show floor. As I mentioned, we'd be darting in from time to time to give you updates and give you a feel of the show floor at IPC Apex here. And with me, Joe Pult has been kind enough to tell us about some another important PCB design stakeholder function, and that's traceability of the boards. We learned all about manufacturing and soldering and some of the processes yesterday, but what happens to these boards once they've been inspected and they need to move on out to the world? How does traceability work? Joe's going to tell us about this. Thank you very much. Welcome.
Kelly, thanks for that great introduction. My name's Joe Pult. I'm the Vice President of the Automation Group for Idenco International. Idenco is a manufacturer of consumables, labels, specifically for the electronics industry. High temperature, can go through the chemical processes. We've qualified with all the Kaizen and Zestron, and so we know what labels will work with the right process. And in today's age, traceability is so key and so necessary. Everyone's talking about, with all the automation equipment on the factory floor here, everybody's talking about factory 4.0 and having some sense of traceability. And we start with the labels on our side. We have, they're manufactured for all the critical processes that they go through.
Let me pause you for a second, Joe. So are we talking mostly just assembly, or is this any product at any stage?
Both. We manufacture, our electronics group is for PCB, board level assemblies, but we also do custom labels as well.
Okay, take us on a tour. Yeah. This is great. Come along.
So I'll just show you some of the examples of the labels that we have for board level traceability, all different sizes, all different material styles. We also do solder mask to protect components in the electronics process, in the manufacturing process, and we also do automation via a feeder and custom automation to print and apply the labels. And we work with all the pick and place platforms out there in the world: Hanwha, Juki, Pana, Yamaha, all the big brands. We have an interface that will work with those pick and place machines, and we have a feeder that will attach to the pick and place machines that will automatically dispense the label. It uses a pre-printed label. This is a Juki feeder that will work on a Juki machine. We have interfaces that will work with all of them, but it's pre-printed labels that are dispensed. The pick and place nozzle will pick up the label and place it anywhere on the board for traceability, giving birth to that board. And then Idenco, we can help you with the traceability function as well. Once that serial number is registered, then we can communicate via whatever ERP, MRP system the customer is using, be it Aegis, Oracle, SAP, to then use that data for traceability.
Well, you mentioned, excuse me, you mentioned printing. What are the different ways? You know, there's laser print, there's laser, and tell us about some of the methods. How does the imagery get onto these labels?
Sure. Right here at the center table, we use our printer that we print on demand, right? Any type of serial data, could be a 2D code, linear barcode, human readable, any type of data that you want to put down, we're able to print that data up.
So let's emphasize to us how important traceability is, especially now with where commodities are going, and you know, the world needs to know.
It's huge. It's huge. The traceability issue is huge. Just because you know, once that board starts, they want to know, the manufacturer wants to know all the parts that went on the board. So if there's any recall issues down the road, what batch, what parts went on, if it was 1 reel, 10 reels, so they can have some control of the process of the manufacturing, right?
Very valuable. Looks like you have a great setup. You sell worldwide?
We sell worldwide. We have manufacturing facilities in Europe, Mexico, and the USA.
Okay, so our design, our mostly designer audience, we have a wide audience who I am sure are familiar with marking systems and things. How can they get in touch with Identco and ask more questions?
Sure. Our website is www.identco.com, and I'll give you our main number.
Okay. Yeah, as designers, we love constraints. We need to know the constraints. So how large are your labels? Where can we fit them on our boards?
Great question. Great question.
So catalogs or data, online data works really well.
Everything's online, so you can access everything online, and we also do custom parts as well as our standard parts that you see. Most PCBs, the standard size is a 1/4 by 1/4 size label. And not only on the board, but we can also place the label on top of a component if necessary.
Very good. Sure. Well, thank you so much for your time.
Kelly, thank you so much.
Yes, with me has been Joe Polt from Identco. And again, another stakeholder function is marking boards and traceability of boards. So we thought you might find this interesting, and we'll go find something, some more interesting stuff here on the show floor. Check in with us and do be checking out the other stages that have our featured speakers on there. So for now, we'll sign out. Kelly Dack for AltiumLive Connect 2022.
We've got to get less wasteful, we've got to get better at what we're doing, we've got to be just generally more effective as an industry and kind of leading the way.
Everything that we've been talking about is based on improving the practice of engineering. But now we are bringing the business of engineering onto the platform.
When you talk to factory operators, they want to run their factory at about 90% utilization.
And what do they actually run at that measure?
62.
The process through which I communicate manufacturing information and intent to a PCB manufacturer has not kept pace with the tools that I have for designing PCBs. Altium Designer, which is the primary tool I use for designing PCBs, the capabilities of that tool have grown immensely, and yet the process through which I ultimately develop a release package and get it to a manufacturer has been completely static through that entire time.
So what we end up with now is really a supply chain that's very brittle and reliant on offshore manufacturing and mostly offline, right? So it's a very difficult environment to be truly responsive and agile when you're trying to build new product and innovate.
By far, the biggest obstacle that I frequently encounter in getting boards done correctly and quickly comes down to communication.
When we send something to manufacturing today, what's the very first thing we do? We create a package of data, and that package of data is not in the original format in which we created it, and it gets translated into a standard, and there's always something that's lost in that translation.
I'm able to generate all this detailed design information, but then ultimately it still just gets distilled into this like 40-year-old format that I send over the fence into a black hole generally. There's a lot of lack of transparency in this process that has enormous room for improvement.
There's been a lot of talk in the industry about creating a digital thread, the link between the design and the manufacturing. With Altium, they've been focused for years on digitizing the design, creating more capabilities to capture more about the design. At Macrofab, we've been focused for years on digitizing the manufacturing side of the business. So what we're now doing today is connecting those two.
I've released this design up to the Altium 365 cloud. And this is a board that we use in our factory to do some simple motor control for some assembly steps. But now I'm going to go ahead and send it over to Altimade to get fabricated.
With Altimade, the designer is going to be able to sit there right in the Altium design tool. And as they're working, the Altimade tool will contact the Macrofab platform and update pricing in real time as they make changes to their design. That means the designer, through Altimade, will get real-time feedback on the true cost to produce their design and any issues with it that might impact manufacturing or supply chain.
We are okay with the price, so at this point it's basically just as easily as saying, here's my credit card, make these boards. I'm really excited about changes in the manufacturing pipeline that will allow me to capture the far more nuanced and detailed design documentation that I already make in Altium Designer and get it to my fabricators and be able to close the loop on that.
People just expect things to work for them with the minimal amount of investment, from a learning curve perspective, this kind of stuff. I think people expect this from engineering software today. Why should it be any different? They want good user experiences. They want to be able to put in the minimal to get the maximum out. They want to spend their time being creative, doing the things that matter, not jumping hoops through a system.
By having that digital thread of connectivity all the way back to the designer, we've seen products go to market in as fast as 60 days that would have taken 6 months previously.
Sometimes I just have an idea, I want to see it realized in reality, I want to make it happen as quickly as possible. Altimade has been the most efficient way to make that happen quickly and to get prototypes in my hands.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip, we're in partnership with the folks from the IPC. Stakeholders unite, and we'll feel alright, digging multi-show synergy. So let's all connect, come on people, let's reflect on the meaning of digital transcendence. Catch it how design and manufacturing combine, check us out, virtual attendance, yeah.
Hi, Kelly Dack from AltiumLive 2022. Welcome again. It's going to be an exciting day here. We're down here on the show floor, but at the same time, we'll be getting ready for Julie Ellis and Carl Schatke's speak on designing with manufacturing and pulling people together. And if you tuned in yesterday as we walked the show floor, that was our message also. Is IPC Apex Expo is all about this digital transcendence, but we are all about connecting too. So we're merging the two messages together, getting manufacturing and engineering and design to connect. We hear it now. The show is just starting down here on the show floor, and our show is just starting. So also we've got another stage. On another stage you'll see ECAD, MCAD collaboration, and there's another stage too. I don't have my notes with me, but please check it out. Don't be afraid to click around to the different stages, and we're going to try and come in just about every 15 minutes or on the half hour to give you updates from the show floor here and see how everything's going. So again, really glad to be your show host today, and let's all have fun, explore, and connect together.
As the complexity and demands of electronics continue to increase, the need to improve digital continuity throughout the entire electronics development process is more important than ever. This is the journey towards digital transformation. And while many companies are investing in technology to support this, they're encountering one major hurdle in the last mile of this journey: the inability to digitally connect ECAD to the rest of the enterprise. This means that the value chain still remains isolated and process disconnected. But with Altium Nexus, this all changes. Nexus provides a digitally integrated solution that overcomes this last mile in the journey towards digital transformation. making it not only possible, but easy. By digitally connecting your ECAD into PLM, MCAD, simulation tools, and other technologies, processes are automated, organization-wide visibility is enhanced, and resources are optimized, leading to accelerated design time, lower costs, improved quality, and most of all, a competitive advantage. Explore Altium Nexus now.
Well, gotta act fast. Sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip. We're in partnership with the folks from the IPC. Stakeholders unite and feel alright. Digging multi-show synergy. So let's all connect. Come on, people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine. Check us out. Virtual attendance. Yeah.
Good morning. This is Kelly Dack live from the show floor here at IPC Apex Expo. And this is the first day of Altium Live Connect. And we're so glad that you've joined us. I'm here with two speakers that are giving our presentations this morning, Carl Schadke and Julie Ellis. Thank you very much for taking time to speak with us right before your presentation this morning. Carl, tell us about yourself and what we can expect just briefly, and then we'll get to Julie and then do an overview of what you'll be speaking about today.
So I've been a designer for 48 years, and I've worked in my own company. I've worked with large companies and small companies, and I've done several thousand projects over those years, a lot of overtime over a long period of time. So I'm very experienced with the field, and I'm going to be talking about how design engineering works in real life, what the people are that are doing it. And we've kind of come up with a team concept about this. And we have a design team. That's going to be our offense, and we have a manufacturing team that's going to be our defense, and then we have special teams, and we're going to talk about all the players and their roles, and then we're going to talk about what they do and what they need and how it works, and then we're going to go into a lot of special things that are in the playbook for people, and we're going to go over how different projects get run and some of the advantages of running different kind of plays. So that's our story for today.
All right, well,
is how to play the game.
Well, let me get the rest of the story from Julie this morning. So glad we could talk to you before everything gets kicked off here and before your talk. Tell us about how this design and manufacturing play together, and how designers need to design with manufacturing. I think that's what we're hitting on today, right?
So we think that designers really need to work with manufacturing and manufacturing engineers, because designers are experts in their own field, but they can't be experts in every field. And so the best way to develop a product is to have expertise from all the different people coming together, whether it's the field applications engineers creating stack-ups for the printed circuit board, or the assemblers advising on how they can get better test coverage. And so we're just showing how to pool our resources to get the most brains into the product for best reliability, best product, best cost.
Very good, very exciting. Thank you so much. I think people are some people are coming in right now. This is we're about go time. So it's been a long time running. I know you've taken a long time to prepare. So thank you very much for all you do. And we're going to toss it back. Please tune in to our presentation here, Design with Manufacturing. And also simultaneously, we've got Designs Team MCAD collaboration and design analysis using simulations. So we're really excited to get started this morning, so we'll flip it back to you. Thank you so much.
And to any customers out there that are not using this, I couldn't imagine not using these features. It would be very difficult to go back, let's put it that way. So I'm Jeremy Waller. I'm the Senior Electrical Engineer at Quantel Laser in Bozeman, Montana. And that's part of a global company called Lumibird, and we have many design centers around the world. There's 18 mechanical engineers and about 22 electrical engineers in Lumibird that are part of the Altium 365 environment. It's pretty easy with Altium 365 to expand our environment. So we research, develop, and manufacture solid-state laser systems for medical and scientific defense-related industries. Yeah, I mean, our mantra, I guess, would be we're rugged, reliable laser systems.
I'm Lane McNeil, the Senior Mechanical Engineer at Quantel USA. This is one of our newest, and it's a fairly high-power, high-rep rate laser system. So it operates with diode-powered input, but it's water-cooled. But the circuit board components of it, when we got going, we have some covers here that we put together, and they're kind of interesting. We have a number of circuit boards that sit inside the system. There are some fairly high power diode drivers that we use, coupled with some control electronics, and then we have some other electronics that are used for regulation of nonlinear crystals that we use to convert the laser output to different colors. Before we were using CoDesigner, basically we would get a DXF file is what we would receive. We would then take the components and we'd have to go ask them, okay, how tall are these? How tall are these components? And then we'd have to extrude the materials up to get an idea, because we have some very tight fit applications that are going on. So
a collaboration tool like CoDesigner just really allows us to transfer back and forth easily. Not only does it help us design the space, but it makes for better assembly drawings so that people can build and manufacture this, so I mean it changes a lot of the picture here.
It's an amazing step forward now to be able to have all the exact physical geometry completely understood and known. Being able to see that allows us to prevent problems that we were having in the past. We have an example here of one of our lasers that was a collaborative process using Altium CoDesigner and SolidWorks.
Having the collaboration tool like CoDesigner in there helped us with this board in this particular design. How did we get to this board, I guess, is a good example to go through. This is how it starts a project usually. I mean, you just have a rat's nest of components and in this case, we'll just pull a few of the important ones that we need to find location on right away. Because I need to get Lane involved and give me a board shape that fits in the space, show me where the mounting holes are, and we just got to establish an area where we can do components. So I'm just going to push it over to him for the first time so that Lane can receive it on his end, and he's going to do all the work for me, thankfully. It takes all the risk out of the process.
Did you get that pushed, Jeremy?
Yeah, it's got it pushed over to your direction, so I've got it in there. You can switch over to your screen.
Okay, so I'm pulling it in here. Right, this. So basically one of the first things that comes in with these is gives us the opportunity to come in here and define the physical size and shape of the component. So that is the physical size of the circuit board that we wanted to work with. And then basically what we're able to do, I can position the component So with that kind of placement, then I'm able to come in and add cutouts to the circuit board. But one of the things that we often do is we will go in and add a feature on the board that's going to define all the keep outs. So I'm just going to define a new part at the moment that I will define as the keep out zone.
These are the features that are difficult. They're pretty obscure, you know, random shapes and everything. The thing is, this usually is a lot of back and forth. But since this is a board that we've already went through this process, what you're getting to see is like, you know, weeks worth of back and forth and arguing over shapes and space.
But it's going to have a lot of this information is going to show up in one shot and be pretty well done, so that Jeremy would be ready to work with it as soon as we're complete with this. Okay, so I just pushed it at this point. So what you're going to see is Jeremy will now have the opportunity to pull the system into Altium when the push is done. It's still in the process of collecting. There, it's done.
It's already there. All right, so it is fast. I mean, this is great. You know, I would comment too, even when designs are pushed and updated overseas, our server's not even in this part of the country, so it's been really a good performing product. But I want to view the changes, see what Lane did. On occasion too, so it's going to give me a list of the preview of what he did. So if I like everything that I see, I can just hit apply and it's going to pull everything in there. Okay, so here you go. Here's all the changes he made. It's got everything I need to get started for the most part.
It would be impossible for a single individual focused on designing electrical circuits to be able to also at the same time envision all the detailed mechanics, because they don't have access to that information. And so this allows the mechanical engineer to effectively assist the electrical engineer in basically properly positioning things to achieve the most compact or the most reliable connection without a bunch of iterative problem solving and back and forth mistakes and fixing. I understand his challenges, he understands mine, and we work together to come up with a solution that works for both of us. And it's the thing that didn't happen in the past nearly as easily.
We're more competitive in the market now because we're able to get smaller. So now we're taking advantage of better PCB design technologies like micro vias and varied vias, and getting our circuit boards smaller and smaller. And at the same time, the space that we're working with in Lane's world is getting tighter and tighter. So it is definitely added to the quality and performance of our laser systems. And so it's worth every bit of time invested in learning the tools to allow you to provide those better products for your customers.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip, we're in partnership with the folks from the IPC. Stakeholders unite and feel alright, digging multi-show synergy. So let's all connect, come on people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine, check us out, virtual attendance, yeah. Hi, Kelly Dack back with you out on the IPC Apex show floor for AltiumLive Connect 2022. Hey, I ran into a good friend, Steph Chavez, out on the show floor here. Steph,
welcome to the show floor.
Awesome, awesome. Thanks for having me here.
I know you've been here. You've been here hard at work all week.
Yes, yes.
It's a matter of you are so involved in so many things, all things almost involve printed circuit design, and I understand you had been involved in some of the IPC committees, design standards committees. Why don't you tell us a little bit? Like yesterday, I think it was 2221.
Correct. Yeah. So for example, the 2221 committee that went yesterday, it's a great committee to be a part of because it's true, the design of the circuit board, and getting involved. I had a good turnout. There was quite a good people there, and it's great to see how that spec is evolving and all the different input that's coming in from it, from the different companies, and you're getting both from the fabricator, from the designer, and you're getting a full spectrum, and from manufacturing and assembly, you're getting a lot of good feedback that is evolving that specification.
So, how does a typical meeting go? Almost anyone can sign up. Any of the designers or any of our audience can inquire and sign up to serve in these committees and bring ideas that can make a difference in how things are, all things PCB designer specified. How does it work?
You're absolutely right, Kelly. And I will tell you, this is the excellent way to get off the bleachers and get into the game, because they're free to attend. You can come in and voice your opinion, and you can volunteer. They're always looking for volunteers, and volunteer time and actually make a difference in the spec and add your 2 cents and see the engagement. And you can bounce from committee to meeting. Oh my gosh, there's a whole gauntlet of there's 107 or 8 committee meetings throughout the weekend and throughout this whole week, and really get involved and get engaged to what the full spectrum of when it comes to design, it comes to fabrication and assembly. And this is where it's at. This is where it happens. This is that common language, that universal language of the industry specifications. I couldn't be more excited about the show, the engagement with my colleagues finally back face to face, and then, just the euphoria and the buzz on the floor. And yeah, it's amazing, and I can't support it enough. And I'm a true champion of IPC and what they do here on the floor, and then what you guys are doing with this live stream at Altium. It's amazing. It's keep it up. It's great stuff, and I couldn't be more excited about it.
Yeah, thank you very much. Like I say, all of our viewers out there, there are a lot who have had to stay at home, couldn't make it to the show. So the idea here is to connect. Connect. The theme of Altium Live is Connect this year, and the idea is that we take designers like yourself, and you're a tremendous preacher and advocate of how we need to connect. For years, you have preached how designers need to get out, get to the shows, get to the fabrication shops, get to the assembly shops, to learn and understand the roles of the manufacturing and assembly, test stakeholders.
You're absolutely right. You're absolutely right. And go ahead. And the thing is because of my involvement in the industry and in my involvement with PCA as the chairman, and the supporting of all these great industry associations like IPC and all the other ones out there, is to get involved, collaborate, educate, and inspire. And I mean, that's the core, that's the mission statement of PCA. And that's the thing is, this is where the knowledge is at, and this is where it happens, the magic happens. And there's so many industry veterans that are eager to pass that knowledge on. And I would say to the younger generation, if you really truly want to make a difference in your career, come to one of the shows. Come to the show here, especially come to the committee meeting, and then come downstairs. So when you go from the theoretical of what's happening in the boardroom or the committee rooms, here you come to the show floor and you see where it's truly being implemented, and how you step from whether you're a pick and place machine or where your solder place or stencils or the solder machine rework. It's amazing. It's all here. And this is the largest in North America, this conference. So this is a place to be. And in my opinion, I'm glad it's finally face-to-face, or it stayed face-to-face. And I know a few other industry conferences, they kind of shut down for a bit. And, it's okay. It's okay. You know what? We'll get past this hurdle, and we'll still communicate and collaborate.
Well, it was great to run it. I think it seems like the show has gone on for days. It's like the energy here is good, and
Oh, yeah.
to run into you just the other night, it feels like we've spent a week together already, catching up.
And we still have a few more days to go, and there's so much more to share. And yeah,
absolutely. What's been one of your best experiences here? I know you eat, sleep, and breathe printed circuit board design, and I know you do it here. What's your best experience here this year?
One of my best experiences, I ran into one of a newer generation engineer or a new generation colleague. I won't mention her name, but it was amazing to see that she's here and her view in the future of design. And it's not even board design. She's on the business side of this. And it's amazing to see how the newer generation is looking at our industry and taking it to the next level. And a lot of it, they're doing it on their own dime or their own way of how they're investing in the future. And I feel it's you and me as veterans, do our part to feed them and channel that knowledge and try to help them be successful.
Well said. And there's so many venues for that. IPC has got their emerging engineer programs, and we've got some STEM work that's being done here. And I know that for our AltiumLive viewers, if you're connected with AltiumLive, you know that there are so many venues of education through Altium and the websites and on and on. And we're just, as designers, why don't we send a shout out to all of the people who are involved in education?
Yes.
Thank you.
Yeah, thank you. You know what?
Salute.
Yeah, exactly. Yeah, I mean, keep it up, and you know what? Sometimes you may feel like you're not being watched or people aren't paying attention. Believe me, we are, and you are doing your part. And we need every one of the educators to do their part to help share that knowledge and pass it on, because the gap is just getting bigger with guys like you and me who eventually we're going to be retiring and going away.
Where are we going? Where are we going, Steph? Cancun?
Oh, exactly. Anywhere where they're serving margaritas.
Club Med, maybe.
That's it.
Yeah. Well, it's been a pleasure speaking with you and catching up, and we'll do a lot more catching up, I'm sure.
The pleasure's all mine. And
with me has been Steph Chavez. We're out on the show floor. We're walking, and we're observing and having fun and learning and connecting and reconnecting.
Yes.
How's that? Thanks for being with us. We'll check in. AltiumLive AltiumLive Connect 2022. Kelly Dack, and we'll see you soon.
Altium 365 lets you hold the fastest design reviews ever. Share your designs from anywhere and with anyone with a single click. It's easy. Leave a comment tagging your teammate, and they'll instantly receive an email with a link to the design. Anyone you invite can open the design using a web browser. Using the browser interface, you're able to comment, mark up, cross-probe, inspect, and more. Comments are attached directly to the project, making them viewable within Altium Designer, as well as through the browser interface. Give it a try and get started with Altium 365 today.
Well, gotta act fast, sign up for the broadcast of the AltiumLive 3-day show. Okay. There'll be keynote speakers, events for tech seekers. I'm your host and I'm ready to go. This event will be hip, we're in partnership with the folks from the IPC. Stakeholders unite, and we'll feel alright, digging multi-show synergy. So let's all connect, come on people, let's reflect on the meaning of digital transcendence. Catching how design and manufacturing combine, check us out, virtual attendance, yeah.
Hey, thanks for being back with us. Kelly Dack on the IPC Apex show floor, and we're going to try this again. Greg and I, Greg Papandrew from Direct PCB.
Yes, you know me so well.
I know you so well. And it's very late in the afternoon,
yes.
So forgive us. But we had such a nice walkabout, but we had a little audio glitch, and that's fine. But it gives us an opportunity to walk and talk again,
yes.
which we certainly don't mind.
No.
They got ice cream out here on the show floor. But Greg, you've been in the industry quite a while, and you've become quite knowledgeable on some of our stakeholders, especially our buyers, our supplier management teams, and what they face as far as challenges in doing their job. And you demonstrate and teach classes and a podcast on how they can do it better. Talk to me again about that, and I'm sure some more things will bubble up.
Sure.
Very interesting.
Well, what I do in Direct PCB, and what we do is we offer, not only I sell circuit boards, but I train OEMs and EMS companies on how to buy boards better, how to leverage their spend.
Right.
And it's not all about pricing, it's actually about getting better service. Now, with that being said, part of that service is also avoiding self-inflicted injury. Between engineers and buyers, they don't know how to order boards properly, or how to design an array or panelization.
Yes.
And when you buy a circuit board, it's all about real estate, regardless of where it's manufactured, that determines its price. And right now, with the advent of COVID, the copper prices have gone up, material prices have gone up, freight has gone up, and of course, if you're getting your boards from Asia, especially China, there's the tariff. So a lot of customers have been facing a lot of price increases in the last 6 to 18 months here, that is affecting them on how they should look at buying their boards differently.
You had thrown out a few numbers that just amazed me. What percentages the prices of certain things have gone up?
Well, no. Before COVID, you could send a container, if you're shipping a container, around $4,000 to $5,000. Now it's upwards of